Good morning. We're on the most exciting day of this three-day summit, and a warm welcome to everybody who's logged in virtually. If you can hear me on the virtual meet, just give me a thumbs up. I just want to ensure that it's seamless. Anybody from the virtual attendees? Okay, thank you. Thank you. That's good. And there's some videos on as well. Appreciate it. Thank you. Good morning, and the theme, as you know, is the power of mobility digital twins. We have some very exciting panel discussions today. Did you know the term digital twin was actually coined by NASA in the 1960s to rescue the Apollo 13 mission? They built a physical twin on Earth to simulate problems. Today, we do it in the cloud. We're kicking off with the ultimate superpower of modern planning, the ability to clone reality. Digital twins aren't just virtual 3D maps. They are living, breathing digital replicas of our cities that let us test traffic fixes before pouring a single ounce of concrete. Today, we are bridging the physical and digital. We have in-person breakthroughs like the Thoothukudi DT, Chennai One, and the State Planning Commission's Thinai with Earthian Tech, alongside cutting-edge virtual presentations like WRI's Transport Analytics Hub. We'll even step into the metaverse, represented by Professor Manivannan from IIT Madras. We are looking at scalability, open source stacks, and the million-dollar question: how do these twins talk to each other to solve bumper-to-bumper gridlock? Handing it over to Professor Ramakrishna for the first panel of the day.
So we have a mic. All right. Yeah. You need a collar mic? It's here. Yeah. No, that's fine. That's fine. Good morning, everybody. It's my honor to kind of moderate this first panel. What I'm actually looking forward to learning a lot in this first panel, where products that have been developed within India to address some of these mobility issues at hand is going to be up for demonstration and for discussion this morning. So we, as Samia mentioned, we have a very interesting list of participants with varied applications that they're going to be showcasing this morning. The key question for us should be, what are the problems that we are trying to solve? How is it addressing the concerns of the common person? How is it going to solve their problems? And then the other part is, if we have these solutions, are these sustainable solutions? Can they be scaled and deployed across the nation so that we can move to the future state of having a digital ecosystem for mobility, right? As we, now we have the pervasive use of UPI and Aadhaar in the society, how can the mobility ecosystem be as pervasive and as influential in making our modern lives move along with ease and actually solving problems that happen to the common person every day, right? So the very first one we have is from IIT Madras, where the MInT team has been kind of trying to understand what is the methodology of developing digital twins, and what does it mean in the context of mobility? How the physical representation of the world is conceived, and how the layering and how the data is acquired, and how we actually recreate the physical world in the digital space, and more importantly, how do we use it from an operational and planning perspective? So I believe they have some very interesting things to share. And of course, this is the very first set of baby steps. Okay? And what we are hoping is to kind of make this more concrete. We are also in discussion with the AI Center for Sustainable Cities as part of the Government of India's Mission AI. So they are also looking at how to describe cities in the digital world. So whatever is being discussed here is in sync and will become synced with that world that is going to be deployed across the country from a mobility perspective, right? So I'm going to invite Mr. Venkat Vedam to kind of first walk us through what is in place from what we call as BMCube-S, Bharat Multimodal Mobility Stack. And let's hear from them, all right?
Thank you, sir. Yeah, show me the first image. Thank you. This is indeed an opportunity, and it's also a great learning for all of us to be participating in such a summit where we are having some of the best brains coming together, sharing the experiences, perspectives, and new ideas, innovations, so that we can all collectively understand and ideate and then address the problems that we're all trying to solve together. So about 7 months back, when I started my journey with MInT, I was given to understand what is the primary objective of MInT, which is solving or defining a kind of stack that gets to be the standard and it'll become a digital public infrastructure in the space of multimodal mobility. That was a fairly new subject for me. I have come from semiconductor industry. About 16 years I've spent in NVIDIA, where I had a lot of learning and understanding about deep learning and the kind of autonomous vehicles and the other technologies. But applying those technologies to solving the problems in the mobility space, specifically engaging with multimodal kind of problems. That was the first problem that I was trying to understand. So along the way, we have explored what is digital twin, where we can really kind of like, have a reflection of the problems that we have in the field, in the real world, and then we make an exact replica of that to understand how we can resolve or how we can solve some of those problems. So this was my first, one second. The other image. There are two images. No, the other, it's there. This, yeah. So we started off by defining or trying to understand what is a digital twin. We all know the word twinning, and as Ramki sir has rightly mentioned, and we are trying to create the exact replica of whatever is there in the physical realm, in the digital world, and then we're trying to use the ability to transform or transpose or change or apply the models, various mathematical computations in the digital realm to understand what happens when we change certain parameters apart from just tracking the real world scenario. So digital twin is something that can be applied not only to one specific, hello? Yeah. It can be used in every realm practically. So I thought it will be not out of context to just mention where all digital twin can be used. Fundamentally there are different types of digital twins, and the 6 types of digital twins that I've captured here, which make a lot of sense for the Indian context and whatever we're trying to pursue here. So there is a component twin, which is typically used in the designing of automobiles or the manufacturing of.
Can you get out of PowerPoint and then focus on what is number 2? Just get out of PowerPoint and then zoom in.
Yeah.
Perfect.
Yeah.
Thank you.
So before we started using digital twins in mobility and other kind of areas, way before the AI also getting engaged with digital twins, we have the twinning that was done in the manufacturing segment, where in the automobile sector, specifically in designing different kind of vehicles, using it even in the aerodynamics and other kind of computation, how it looks starting from the physical look of that one to how it actually can behave in different scenarios. So the component twin is the first one, and then the asset twin is essentially to maintain an inventory of large enterprises, and then process twin is something that has probably matured in the 90s when we had the ERP and a lot of focus on the process improvisation had taken place. And then the system twin had come about, which talks about the how we can prepare, create a twin of a system composed of multiple assets and processes. And then enterprise twin is to give a global view to the management or the executive team about what happens in the whole enterprise. And finally, today we have even city twins, such as the Singapore twin, which covers practically every aspect of the Singapore city, starting from the mobility to various aspects, including the civic facilities. The entire administration is covered in the twin. And recently, even in Ahmedabad, in India, we have an announcement for a digital twin covering the land records, where the government is actually proposing to track the ownership and the transfer of the titles and so many other things. So the possibilities of digital twins applications are endless, and it spans across multiple industries. Multiple domains, as you can see in the section 3. Manufacturing, oil and gas, energy and utilities, transportation, construction and infrastructure, healthcare, and water management and environment management. Common use cases I have listed here, and I would like to just briefly run through. And the maturity levels, again, for digital twins, there are 5 levels of maturity. And that is where, we start off with a static model, and then we move on to the monitoring stage, and we use the digital twin for diagnosing the problems or any kind of what if, projections or whatever, and predictions. And then we identify the solutions using digital twins for the problems that we have. And then take it to the next stage, that is the final stage of autonomous state. Next slide. Next image. Center one. Yeah. So digital twin in the context of multimodal mobility has different data sources that are coming into picture here, because when we're talking about multimodal, we have the public transport, we have the road traffic, and we have the rail and metro, and the shared mobility, and freight and logistics, as well as infrastructure, the road infrastructure, the environment, and the external systems. These are all forming the data sources, and the outputs is what we target in achieving through the digital twins, and the outputs that we have the real-time operations tracking and predictive insights and optimized planning and simulation and what-if analysis and citizen services, tracking of citizen services and sustainability and tracking the KPIs. These are all the aspects that we can track and execute more efficiently using digital twins in multimodal mobility scenario. So the problem that I had was, do we build a digital twin that is going to be specific, addressing to a particular vertical, or do we come up with a framework that can be used as a baseline plus layered approach for targeting different vertical solutions so that it can become a part of, integral part of BMQBS and qualify to be part of a digital public infrastructure. So that is where we have approached the entire technology in a particular fashion, and I would like to present that one. Yeah. So this is the MInT digital twin platform, where we are looking at the building of the digital twins in a systematic fashion as the main problem. And we'd like to build it in such a way that any of our partners or third-party vendors who are building digital twins for smart cities or mobility solutions would have a ready-to-use reference platform which standardizes all the data sets, and it creates the interoperability, which is the main problem that is prevailing today with multi-vendor scenario that is existing. So how did we achieve that? We have identified a platform architecture wherein we have taken the layers of infrastructure, and we also are creating an event backbone and a governance layer and a DT runtime engine, which is what would vary from one domain to another domain and which is pluggable. And we plan to build multiple domain-specific DT packs, which, when plugged in for a particular sector, it automatically configures the baseline platform to be ready for the further fine-tuning and customization and data ingestion into that particular vertical digital twin space. And then API gateways are common interfaces that are used for like connecting the data sets and also doing all the process. And then AI inference is going to be a common layer which would help in the analytics and other kind of critical components that are specific parts of this particular architecture. So the idea is we have one engine, and that engine is applicable to any domain. So it is, we don't need many engines to develop different genres of digital twins. We take one baseline engine, and then we have the way in which ERPs work. You have multiple discipline-specific digital twin packs that gets plugged in, and that will control the overall rules and regulations and the policies and the governance and all the related activities that are specific to digital twins of that specific domain. And then a domain pack is the data. It is not the code. That is what is the approach here. So domain pack is what would consist of sample data for each domain, and it would have the data formats, and also it comes with the required tools for normalizing the data, so that even if a vendor has a different type of varying data, that can be converted and then automatically it is ready to be ingested into this pipeline without any kind of serious coding effort. So we are actually trying to reduce the total runway of preparing and building a digital twin from months to days using this particular kind of framework, because each mobility pack would have, each domain pack would have all the events that are specific to that particular domain. For instance, here we have mapped the number of events for mobility, and it comes with about 53 events. And then for healthcare, it has about 34 events that are covered currently. And then logistics, it's about 32 events. So why are we talking about events here? When we're talking about tracking anything, any process through digital twins, we are actually tracking different events. For instance, in the mobility sector, we're looking at the traffic counts, we're looking at the road congestions, we're looking at various other parameters that are part of the mobility solutions, including the air sensors or alternate routing or any kind of all those parameters are covered within these 53 events. So healthcare is again patient-related and treatment-related, what is the line of treatment, and all those kind of things. They are covered in the standard 34 events, and this can keep growing depending on how we pan out the scope. This is the first cut. This is practically alpha. And we would keep analyzing more, engaging with the experts of different domains, and then we'll be upgrading these domain packs to cover practically 360 degrees of each domain related activities or events. So this is actually built with OpenStack, all open source. This is not locking in for any vendor. So this will be zero cost in terms of licensing, and it is open to all. And whatever is built using the OpenStack CC by 4 license components, that gets to be proprietary if any organization or vendor desires to keep it as a proprietary bundle and then promote it or monetize. And this is perfectly aligned with the objective and philosophy of BMQBS, that is Bharat Multimodal Mobility Stack. And this would be the first in line of the BMQBS stack to be followed by the protocol, which would be the backbone and spinal layer for the rest of the solutions, which will be part of BMQBS. So this would be actually acting as a reference platform, starts with a reference platform for small time implementations, and we would like to scale it up to a national level scale and qualify to be a DPI. That's all. I would take any questions if there are. So the implementation of this one, the mobility, what we have done for Thoothukudi. Yeah. Thank you very much, sir.
Yeah, thank you, Venkat. Before we get into what is being done at Thoothukudi, right? So this is, say, release 0.
Yes.
Okay. So the capability of what we are envisioning has to grow over time. So, for example, you have a way to describe traffic movement, say, in 0, right? I have a signal and I'm watching all the buses and cars going through that signal. That is, say, version 0, right? But eventually, you have schedules. You have interventions. You have interconnectivity between the different modes, right? So there should be a release schedule of when those features and capabilities come into play. You can think about that as addressing use cases along the way, which will drive the build out of this capability, right? So a timeline which has capability on the y-axis and time on the x-axis is something we have to publish as well as part of from MInT and BMQBS, so that is kind of the guiding light of what the releases are going to be. So anybody who's using this, for instance, Manish, in particular, as we integrate with the National AI Mission's view of sustainable cities and the digital twin that's being built for cities, this has to closely line up with that, the release schedule here, with what is planned for the cities. So then, whether it's the municipal commissioners, as you kind of said, or whoever is the traffic administrator for the particular urban area or location, can be kind of sync up. And the technology provider, we are not going to build the digital twins for the entire country, right? We are going to give them the toolkit, right? So I think that's something that people have to recognize. Okay. All right. Let's see what we have accomplished. Maybe Amit, you're going to give us the kind of demonstration of what is being done in Auditorium.
Yes, sir.
Yeah. So, but also, Venkat, we also had.
Yeah. Actually, we also have a demo, a pilot demo of how digital twin with this particular stack that we have, baseline stack, integrated with NVIDIA's Omniverse to give a three-dimensional view of Chennai's traffic congestion and other kind of things. Since we did not have direct streams coming in and connecting, it is not reflecting the real-time data. It's actually synthesized, but it will give you a look and feel, and that will be available for demonstration in the demonstration hall in about an hour or so, because it's already in the workstation, which is there in my office, in MInT office. I have to get it here, set it up. So by lunchtime, all of you are free to come. Please feel free, come and ask questions. You can see Omniverse connected to this digital twin stack, which is actually running online in a cloud server.
All right.
Thank you.
Yeah, thank you. Thank you, Venkat.
Hello, good morning, sir.
Yeah.
I'm Sair Mohammed, City of Rago. So I have a question like, yeah. So this presentation gave a good idea like how different events will be coming and processed. So my question is like, so one major part of this infra is like how those events will be generated from physical infra and how they will reach to the digital infra. Like this infra understand what some kind of event patterns. So how that physical infra will be built that send the events to this digital infra.
What you're asking, if I understand your question correctly, you are referring to the events that I mentioned, that each domain pack would be actually having certain number of predefined events, right? Same thing?
Yeah, for example, like if you want to map railway network and each train has to emit certain events and that needs to reach this platform so that it can track the trains. So how those event generator will be installed in trains, how trains will be sending that data to this platform. So that part was not clear to me from this presentation.
Yeah, basically this is a reference platform where we provide the connectors and the endpoints to ingest the data that is relating to each event. For instance, you have taken the railways example. So you have the arrival time, departure times, and the type of train, whether it's Vande Bharat or Shatabdi or whatever other kind of things. So every piece of information that is related to the passenger trains that you have and the cargo trains that you have, different genres or whatever, all that will be captured in a digital format in a structured fashion. And for railways, the domain pack would take into consideration the standard data that is available publicly, and it will be structured in such a way that you can keep adding, populate the data. We only give the skeletal, like, the database structure, right? The event details, the actual live data or whatever, that needs to come from the sensors or other kind of devices that help us monitoring in real time what is happening. And again, tag to specific fixed data such as the train number or things like that. So we give that framework. Is that clear? In the afternoon, we can have discussion in the afternoon. Yeah.
So as part of sending that data through sensors, like will this platform will also provide sensors so that those can be installed?
We support all the sensors. We support different kind of sensors and communication channels as like in a plug and play. When I said plug and play, we would have different types of channels to receive the data into the digital twin system. That is where we are trying to standardize the data formats. Because each, like, if you're looking at other private sector vendors who are building digital twins, they have whatever is the technology that is accessible to them or known to them, they go ahead and build it in that particular, using that stack. Whereas if we standardize that, interoperability will be possible and data can be exchanged, which is not happening today. So we're trying to address that one by providing a platform that is ready to use so that they don't have to worry about the coding effort that gets, that's required there.
Can you hear me? Okay. Thanks, Venkat sir. So what I'll do right now is we'll go through one use case that we have implemented in Thoothukudi. So as Professor Ramki explained that this is the phase 0. So this is probably the hacking before the final packing. Yeah. So that we'll be doing in coming weeks. So I'll show you right now what we have done right now and how it works. And probably I'll be here for the whole day and in fact for tomorrow as well. So happy to discuss any technical part. I am Amit Kumar. I graduated from IIT Madras a couple of years back. And now I work for MInT with Professor Geeta Krishnan and Professor Ramki. So there are 3 modules right now in our digital twin: bus tracking, air quality sensors, and camera. Of course, there are many more things that will come up, let's say simulations and the real life use cases and all. But the 3 modules right now will show how it works. So for the Thoothukudi, we installed about 45 odd of GPS. So if you'll see right now, this is the area of Thoothukudi. And we are getting data from 34. So why we are not getting data from the other 11 or so? I mean, it may happen that the device is in breakdown stage or vehicle is not running, and multiple things can happen in the real world. So if you'll look at a bus, let's say this vehicle, so it will show you right now what we are doing with the latency of about almost like 1 to 1.5 seconds. We are showing the real-time status of a vehicle which is running on the road. So as Venkat sir explained that what is digital twin, it's basically the digital representation or maybe digital real-time representation of what's happening in the real world, right? So let's say this bus is running and this route is, let's say, some 57A, and the recent bus stop that it has passed is Thoothukudi Old BS, and the next one is showing, and the live speed along with the direction. So now what this will do for a particular user, it will give you a predictability so that you can plan your commute accordingly, eventually optimizing your time. And here you can do some of the search. Let's say this vehicle is running on 55D route. So you can search 55D and this vehicle will pop up, right? The next one bus stop is this one, and that's what you can see here. So, and here we have the schedules of what we have got from the Thoothukudi folks. So this is the basic version of a digital twin. In fact, in the campus as well, if you would have used moving mountains, right? The same thing we have deployed for the campus as well, right? So this is one of the modules for digital twin. The next one is camera data. So right now you can see everything as 0, 0, 0, and 0, because there is a power shutdown in Thoothukudi and we are not able to get the real-time data. I mean, that's the challenge of real world. But I mean, these are some of the data that we have. But what I'll do for you, I'll show you the historical data, and that will give you a sense of what's going on overall. And that's what we are representing in here. I'll do it, yes, yes. So this data is from yesterday, 6th. And how we have separated it right now, we have, let's say if there's a junction, and there are few directions for that particular junction. Let's say this one is 3rd mile at its location is there. If I'll open it for you. All right, here you can see. So for every 5 seconds, we are getting the data, and it basically will tell you that which direction the vehicle is moving and what all are the kinds of vehicle with its particular type, and finally in total. So for a particular timestamps, if I'll scroll down for you, sorry? All right. So here if you will see, let's say for example, at this date, at this particular timestamps, it's okay, anything works. But I'm just giving a hint of like what kind of data we are getting. Let's say this one. So one vehicle was there, of which type? Let's say truck or car, right? So maybe let's have a look at real-time data in the day. Let's say this one. Maybe one motorbike was going on. Sorry, 2 of them, and in total 2 vehicles are there, and both of them was moving towards Thoothukudi. So the crux of the point is we have camera installed, maybe multiple camera at a junction, and it shows you that in different directions how many vehicles are moving. So that's what we are showing it here. So there are few simulations that we have planned for this, that let's say if a lane is there, I mean let's say if it is a road with multiple lanes, what will happen if maybe we'll introduce one more lanes? What will it, how it will sort of affect the traffic if we'll close one lane, right? So there are different kinds of simulation that we'll be doing in the final parking part. But yeah, this is how it will look like eventually. Maybe I'll just click here and there just to show you around. Right here you can see one camera is there, let's say 3 vehicles was there. All right. So that's the second part, which is the camera modules. The third one is the air quality sensor, if log in. So it will basically show you the air quality sensor data and a few other parameters. And based on that, some of the use case that we have planned. Let's say that right now what happens in a Google map, if you will see, it shows you that, okay, this is the route where you will have minimum traffic, or if you will go through this route, maybe the lead time will be higher. So one of the use case that we have planned for this one is, let's say, it will tell you a route where you'll have the best in terms of surroundings, I mean, best air quality. So it's good for environment and good for you as well. Anyway, so right now 3 devices are active out of 6, and 3 are inactive. Yeah, these are the dashboards eventually, I think, that will be given to the Thoothukudi folks. But yeah, these are the sort of overall 3 modules we have now that will be eventually looking to make sure that all these 3 modules talks to each other. And if a user gives some commands that, let's say, hey, what will happen if we introduce one bus stand at this particular junction, maybe lat long or so, what will be the final outcome? So it will exactly tell you what's going on inside, right, while talking to all 3 of them. Yeah, I think that was mostly it.
Yeah. Yeah, no, I'm just wondering, where is the mic? Where is it's all disappeared? Okay. Yeah. Thank you, Amit. Okay. So I think this first session or first set of demonstration was, A, what is the methodology? B, how would we actually conceive the data sources? And how do we build it in a very modular fashion, right? There are so many open questions in this. Where should we source the map data, okay? The gentleman from Irago, he kind of asked a very relevant question. What is the census set? What is the data source set? And it has great implications to sovereignty as well. You know, where are we going to use Google Maps? I think probably the result after discussions with the AI mission and in discussions with Mahua, we will probably say no. We will probably be using a map set that is indigenous to India, right? And what are the census sets to use? Because this has to be a toolkit, the physical and the digital. So this will be a physical AI that is given to every city and town to build out what their infrastructure is going to be. So that's the vision. So I think I must applaud the team for taking the first baby steps, okay? But we are looking forward, release after release, as this becomes mature over the next 12 to 24 months as we kind of progress towards scaling it up across the country. All right, thank you. Okay.
Next is a panel.
Right. Who's next, Samya? Oh, all right. So Avinash from WRA. Okay. So I think you're up next, and on the traffic analytics, you have the thing in your laptop, or is it already loaded? Okay, wonderful. Yes. Yeah. Please come on stage. Please come on stage. Thank you. Yeah. Please go ahead. This is okay.
You need a connector? Connector.
Where to point? Here or here?
No, that's
on the screen.
Sensor base. You can just click on it, it will work.
Okay.
But we're using a PDF, so I don't know.
This is in PPT
This
format
is
or
PDF
this is a
format.
PDF?
Okay, then I don't know if that will
So I'll do it.
Yeah, yes.
Okay.
Let it just finish downloading. It's
Sure,
taking
I'll
a-
start.
Hello. Hey, good morning, everyone. Thank you for giving us an opportunity to present our shift initiative here. Till the time this happens, I would just like to start with a quick round of a small question from my side, because I know there will be many questions at the end of the session. So I'll start with mine. What comes to your mind when someone talks about, say, mobility? what's the first word that comes in your mind? Any? This thing? Yes, please. Traffic, okay. Any other? What's the word that comes to your mind when someone says mobility? Cars. Traffic, cars. Anyone? Accidents, okay. Pollution. Oh, that comes to your mind when someone says mobility? That's great. That's great to hear. Uh, okay, so to start, there's one more. You need to do here or here?
அந்த ஃபுல் ஸ்க்ரீன் ஸ்லைடு போடுக்கலாம் கண்ட்ரோல் டூ பிடிஎஃப் இது
ஆமாம் பிடிஎஃப் தான் கேட்குறான்
ஓகே
டூப்ளிகேட் பண்ணலாமா விண்டோஸ் எல் போட்டு விண்டோஸ் 3
அங்கே ஆல்ரெடி டூப்ளிகேட் தான் இருக்குது ஃபுல் ஸ்க்ரீன் இல்லையே அவ்வளோ
இட்ஸ் ஆல்ரெடி
Go here. Done.
இப்போ செக் பண்ணு
நான் டவுன்லோட் பண்ணேன் ஆல்ரெடி டவுன்லோட் ஆகிதான் இருக்கு
டவுன்லோட் பண்ணாவே இது ஓப்பன் பண்ணிடுறீங்க
ஐ திங்க் டவுன்லோட் ஆகலை நினைக்கிறேன் ப்ரோ
Acha, I have to scroll down. Okay. Okay. Oops. Let's play with 60. The switch. Okay. And where's the next page? I don't know.
fit to pages fine sir you just scroll down
Okay. So this is the common narrative that is floating around. So the moment like everything is dominated by congestion, and there are a lot of efforts going towards solving this problem of congestion. But as we know, congestion is just a symptom. It is not a problem in itself. So how to change this discourse? Because everyone is chasing to solve for this congestion, like which are the most congested cities in India, in world. All this is happening, and the result of this is creating more and more roads, flyovers, tunnels. Just to solve for the congestion, the BRTS in Indore got dismantled. So the common narrative across the globe is congestion is getting worse. Everyone drives a car. Buses get stuck in traffic. So just simply keep on widening the roads. But we do understand that it will lead to a lot of induced demand, which will ultimately sort of feed into this cycle, virtuous cycle only. Most of the Indian cities, for solving their mobility situation, they create metros, assuming that everything will be done by just creating a metro. But we do understand just creating the metro in itself won't solve. We need to have a well-planned, very good integrated last-mile services also. Without that, metro won't be able to sort of justify or what's the potential that they have. It can't be converted into on ground. So there is a need to shift the narrative around mobility beyond congestion, and that is what the Shift Transport initiative. It is a collaborative initiative for better decision making through a data-driven and an evidence-based approach. So it has three main components. One is the product, which is the brain of this initiative, where like the transport analytics hub that we are calling. So basically this will help in understanding how a particular city moves. What are the different supply indicators, what are the different demand indicators, so on. The other piece to this is the people, where it is like in a simplified way, or basically to just de-jargonize the complication or the big models or the indicators, to put it in a way that it is easily accessible to different types of users, different types of stakeholders, so that an effective conversation or discourse around mobility can happen, where people can collaborate and co-create the solution. The final piece of this is what the partnership, it's like the local action on ground. So whatever we have understood, whatever we have created, how to get it implemented on ground. So that is what the third component. So in a simple nutshell, it is like a brain, which is a product of it. Then there is a heart, which is like the immersive experience. And then there are limbs for action on ground. So that is how we are putting it. With the key objectives, like how to improve the observability of the mobility indicators, how to diagnose basically what's the problem or what's the underlying challenges, and then how to change it systemically. That's the key objective. The product part I'll come towards the end where I'll show the existing version. But basically this product presents how my city moves, how particular city moves in this simple framework of demand, supply, and performance. In its current version, we have 30 cities, 20 Indian and 10 global. The ambition is not to create a data repository. This is not a data repository platform. Whatever the data that we have already collected or we are putting it out. The main idea of this transport analytics hub is how to democratize the data analytics part of it, like how to make it accessible to most of the users where they can play around with this. Then comes, so just a few screenshots, like how this portal will help. It will not only help in understanding how my city moves, but also compare it. So in terms of supply network, what is the road network looks like? What is the public transport supply looks like? Where are my bus stops? Where are my metro stations? All those information constitute the supply part of it. In terms of demand, as we realize, the OD matrix, the simplest form of the demand, is not readily available, or it is not available for most of the cities. So we have tried to use the newer proxy. It could be population density, it could be employment centers, but the idea is, yes, that is an important piece of information which is missing in its current form. How can we make efforts toward collecting that information? The next is, then comes slowly the analytics part of it. So once we have a supply of public transport, one can easily see how much of my population or how much of my area is accessible by public transport. I'll just do it quickly because I've got an instruction I need to finish in 10 minutes. So adding another layer of complexity to this. So in the previous map, we see what's the public transport accessibility in Bangalore looks like. Now, when I simply overlay it with the heat layer or the heat data layer, I can see on the left, which is the good transit coverage, even though they have a good transit coverage, but they are exposed to not a comfortable or temperature. So what could be the interventions, like how to plan the interventions where the PT accessibility is high and also the exposure to heat is high? What sort of intervention is needed? Because just creating a public transport within 500 meters and assuming people will come usually doesn't happen. So how to improve? On the right-hand side, the map shows there the PT accessibility is also not good, as well as they are exposed to a heat. So that's the challenging area, like how to sort of create a solutions for it. The other part is in terms of the active mobility. If we have a data, anybody can use that data and simply create this, like how my city's active mobility looks like network in terms of walking, in terms of cycling. This is another where the supply side of data we have compiled, as I've mentioned, across 20 cities. If we see, like as the dead-end proportion increases in a city, its speed ratio, the peak versus the free flow speed, keeps on reducing, which is intuitive, but how to read it? So if we go into a city scale, so this is for the Bangalore, if we look at a ward level, we can clearly see towards the west and the southwestern part of it, the dead-end proportions are relatively lower. And also, where the traffic data or the speed data shows, the drop in the peak hour speed is not that intense. On the right-hand side, it is. So how to specifically do? So if we see on this Basanvuri, the network looks very good. The grids are completed, but on the Whitefield side, there are a lot of hanging links, which we are calling it a dead end. So it could be like most of the urban development over the decades, in the last few decades, in Bangalore happened on the eastern part of it, where the network has not catched up with in a fashion of a planned development. So that is what the problems like. Other one is the secondary network. It's not about just building wider and wider roads. Building wider and wider roads won't be able to solve for your problem unless you have a good hierarchy of network where there are secondary network, primary network. So from local, it feeds to the arterial. And this analysis clearly shows the cities which has good secondary network, they are doing relatively better in terms of their peak travel time result. Now, like if we deep dive, so here we see that Ahmedabad has a good secondary network coverage compared to Hyderabad, and how it looks like. So here you can clearly see like why Ahmedabad is having a proper network, there are secondary networks, and therefore it is doing relatively better in terms of speed impact during peak hours. Similarly, so like this, there are various analytical tools which we will keep on adding, and all of these tools again would be open source. So like any user, they can use it in 3 ways. If they want to use with this existing data and play around, they can do that. They can change the visualization part of it to make it more simplify or as customize as per the audience. And the third part is if they want to build on top of it. So as we have looked into the public transport accessibility part of it and overlaid it with heat. If someone wants to build anything on top of it, they can freely or they can easily build on top of it. So these are the three this thing. Then comes the immersive experience part. So here it is like whatever the analytics, whatever the simple indicators that we are calculating or we are estimating for any of the cities, how to engage with a different audience. So this is the example of Namaraste in Bangalore, where it's inside the BBMP glass house, which is like city officials or the city authorities. They are hosting this events for 3 days where people come in, where different stakeholders come in, and they just basically look into like how my city moves, what are the indicators, they engage, and then how to co-create, like identify the problems and creating the solution sort of. And this is another example where we did it in Ahmedabad this year. Again, it was hosted by Ahmedabad Municipal Corporation and supported by WRI India. But this is what, like a big panels or real life, almost 20-25 feet panels, putting the data in a simple visualization way just to catalyze the conversation around mobility. So this is in terms of like all users participated. So this is the immersive part of it. I think I'm done with my presentation. Any questions? But largely it is like to simplify, first to understand mobility, what mobility is, simplify it and put it out in a domain where all the stakeholders can engage depending on it. And then if anybody wants to develop on top of it, they can freely do it or they can easily do it. So that's in a nutshell about the Shift Transport initiative. If there. Thank you very much.
Now, Avinash, thank you very much. Okay, so in the session so far, we kind of talked about sourcing data from sensors. How do we start putting it together? And what Avinash has talked about is, oh my God, I have this data and I have use cases, and I want to understand how to get something out of the digital twin. Now. So obviously they have used various data sources, which has already been kind of built out from and derived from the available sensors and technologies, right? Our goal, as part of the MInT, yesterday we signed the MOU for collaboration, right? As we kind of think about the evolution towards the digital ecosystem, and we have to integrate all of these things and make it available as a one package that evolves over time, which is very tuned to what the needs of how an administration at the municipal level or a city or a town operates. So it gives real value to them. So they are able to take control of their city or their town and deliver real solutions for their citizens. That is the vision, okay? So all of these, we have to be working together, Avinash, really looking forward to it. And we will develop the ultimate kind of toolkit, then becomes what will be the standard for the world, right? Okay, right, thank you.
Thank you. Thank you, everyone.
So sorry, you have a couple of questions there? There's Hillel, okay.
Please go ahead.
Thank you for this very exciting presentation. It seems like you have a lot of cool data and you're doing magnificent evaluation of it. You mentioned the need for actuators, or for actual tools to influence the reality. And then, as far as I noticed, you talked about it very quickly. The actuators you mentioned are relatively weak to my understanding. And you didn't mention at all the only effective actuator, which is road pricing. Are you doing anything on road pricing?
Okay, so so far the initiative has reached where it talks about how my city moves, what are the mobility indicators. In a way, it is not prescribing any solution. So therefore, the importance of engaging with different stakeholders, like how to make it more easily implementable. So that co-creation happens there. So during that point of time, if it comes, like we all understand the importance of public transport needs to come in, but at the same time, it needs a funding source for it. So what could be the potential funding source for it? And then the conversation towards how it can happen. That is one part of it. The other part of it is how to sort of handle it at a demand level, where we say, okay, the particular area is restricted, which you're talking about in terms of congestion pricing. So it depends on city to city and at what stage they are, and from where, from there, how to take it forward. Because if we simply put, this is an area where you need to put a congestion pricing, but at the same time, we need to look into, in terms of the public transport supply, in terms of other supply of the facilities that are available, and then can plan for it. So, but currently, I would say, for the cities, it will not give you directly, like this is the area where you need to put like the congestion pricing or any sort of that mechanism.
Thank you. We can discuss it later, maybe.
Sure. Okay, thank you. Thank you for that.
Thank you very much. All right. So we have two more presentations that we are going to kind of look at it. Okay. I think from State Planning Commission, Shalini, right? Yes. Come forward. Thank you. So you're going to bring a very, very important physical layer into all of this, right?
Hello, one and all present here and virtually joining this meeting. I would like to talk about the platform which is called TINI. It is a digital public infrastructure that we are developing for the state. So I would like to move to the presentation. Meanwhile, myself, I'm a GIS developer and have quite experience in research. And the platform we are developing is TINI. This platform is we made to eliminate the data silos, enabling the interdepartmental coordinations. And we also incorporating the scientific methodology to the system, which will be helpful for the decision making. This is primary goal about TINI. And yeah.
You need a collar mic?
No, this is enough. So I would like to inform you that how this platform is bridging the gap between what is government need and what is the existing technology that is available to address the gap in the government. Here I am starting with an example. It is the biggest challenge in the government, which is making the difficulty in the scientific decision making. One of the worst scenario in this field is the data fragmentation. Here we can see that sectors like transport, housing and land development are still operating separately. They are not working together. Because of this, they are taking a localized interventions. These are sometimes inducing that traffic. Okay. Sometimes this localized interventions is inducing the negative outcomes like traffic congestions or urban sprawl, reducing the accessibility by the population to the facilitations. These kind of things are happening because of the localized interventions. Also, the sectors are using the conventional methodology like using the static report or sector-specific studies. These are fails to predict a long-term impact of what the impact may happen, or what is the infrastructure pressure will be happen before implementing the strategies. These are the biggest challenge in the urban planning right now. We are introducing this platform TINI. Here, I would like to say how we are eliminating these challenges and how policy could be make more appropriate and evidence-based decisions here. Here you can see that there are n number of data we are putting here with the different thematic colors. It is representing that we are collecting data from different thematic areas, from urban, from forest, agriculture, coastal, and other relevant data set across the state. We are using the data from across the state and connecting them with a scientific relationship and positive negative correlation, as well as the sector specific analytical modules. And with this, we can able to do a multi-dimensional perspective analytics and cross-sectoral integration and get the scientific and evidence-based results for the user. This is what about TINI. And I would like to show a demonstration video. Excuse me. தனியா இருக்கு video.
இந்த வீடியோ
Yeah, just stop it. So I have mentioned TINI is a platform for a state. In this, we are developing an application for a problem-specific statements proceeded by the government. And this application we develop for KUMTA kind of local GCC kind of stakeholders. And this platform is for land use and transportation mobility, and policy tweaking. Here what we are doing is we are built an application on the top of the data layers. We can able to tweaking the policy and can able to understand what will happen if the policy has been implemented in ground. Here you can see in this phase, this is one of the demo. I cannot able to show us a live as the team is working in the background. I show in the video. Here we are selecting what is our area of interest here. As I mentioned, we are going to address the problem for land use and transportation. We are selecting the sectors, land use and as well as transportation for this module. And after we have to select what are the machine learning model that going to be we see in the simulations. We have to select those models, and after that we have to ensure that enough models has been selected, and we need to give what is the spatial extent for the implementation or the policy intervention we are seeing, and we also verifying what are the input data here. And after that we are giving two interventions. One is for improving the road with 4-lane facility, and we also going to draw a metro line in this spatially we are going to do this. This is the geospatial policy intervention we are giving with for the 4-lane intervention, and this is the bus road we are proposing. This is the metro line. We are manually drawing in the map, and then we are run the simulation. Before that we are ensuring it has all the settings. We can tweaking here, like we can enable it, what is the parameters we need to be incorporated in this policy interventions, and we need to give the here. After this you will get us a result. What will happen, like how many minutes it will be saved through this implementing the 4 lanes as well as the developing metro line connectivities. Likewise, you can see the summary, as well as if you want, you can also see the result as KPI. You can see here, and the right panel show the graphs, as well as you can see as the KPIs and map results in this platform. So this is what we have developing for KUMTA through TINI. And through TINI, we are enabling the following things. First one is democratizing the decision making. We know that this kind of policy or interventions or planning, it is always lies in the secretary level, and the platform may not be go down to the lowest admin level of village panchayat. But this platform we are developing to all the set of decision makers, and we can utilize Tinai without expertise. You can just chat with Tinai AI. It can able to do the simulation what we seen in the demo and give the results to you. And as I mentioned, we develop Tinai for the state. We can also develop within Tinai like an application what we have seen in the demo. We can develop application for the problem specific statement given by the any other departments. And through Tinai, we are enabling the multidimensional perspective, which is humanly impossible right now. And this architecture is future ready. If it is, we come up with any future specific geo layers or any other data layer, it can be able to adaptable. And this can be also replicable for any other state or for the nation as well. And the decisions are evidence-based, as the applications it is using a scientific methodology and frameworks that we already approved. So the results are evidence-based, and the decision making would be the most appropriate. We are enabling the digital twin ecosystem. We enabling the real world scenarios, and we also enabling the interdepartmental coordination, which is the extremely needed for this moment. And we also enabling the simulation and predictive. We can able to do the if conditions, and we can also predict how many days will take to implement a project, like kind of things. And we ensure the last mile delivery through Tinai. We enabling the transparent government through it by coordinating the data sources from various departments. Tinai will be the single source of truth, and we are trying to build with the open source platform, and we are building it for citizens. So it is open for public. And that is about my talk. And the future of governance is not rely on getting or generating so much of data. It is on connecting them together through the intelligence platform. That is what we are developing. Tinai is an intelligent platform. And thank you for the opportunity. You can connect us through the through the QR. You can access Tinai, and also this QR link you can access it.
Thank you, Nishalini. So amazing work that's being done. What is very exciting is we signed the MOU yesterday with Kumta. And you're already working with Kumta. I'm very sure that you're going to get engaged with what we are doing here at MInT. And I think Dr. Abhinama is also somewhere in the audience. So she is. She and Kumta is going to be helping us build out the digital twin for the city of Chennai, right? So when we look at it, right, so there are so many people and so many organizations and stakeholders who have the same objective. And democratizing, digital public infrastructure, using technology to solve the problems, right? So I'm so excited because this is all coming together, right? Now, we have to work along with the AI mission for the nation, which kind of integrates all of this together so that it becomes a very scalable and standardized solution, right? You have a visualization method. You have an analytics method from Avinash and WRI. We have the components. Now, what parts do we standardize, and how do we standardize it so that it becomes a common language that is something that can be replicated across the country, right? So thank you very much. Now, I think we might have one question, or do you have anything that's...
Yeah, I just want to also announce the vendor is here, Siddharth from Auditorium, and it's on their platform that Tinai runs.
Oh, okay.
Yeah, so
hi.
I'd like to recognize his presence. I think it was a fantastic presentation, and if it reaches layman, then the talk is successful. And I think your talk came through very successful. And that's the power of the platform as well. Are there any questions from the virtual audience? You could key it in, and we'll have somebody relay the questions.
Right. Yeah. Maybe you can
Or
say
if
a couple
you
of words and
want
then-
to share a few words.
Yeah.
Share generic questions. Yeah.
Sure.
Yeah. Happy to take questions. Any generic questions are welcome.
Any questions from the audience? Yeah, go ahead, Manish.
While you were doing it, what are the hardest pieces of the puzzle? And how can cities or governments make it easier to do something like this?
Yeah, surprisingly, the hardest piece of the puzzle is the user profile. Who are we designing it for? So one of the questions that you need to start asking yourself when you're designing a twin is, because reality is complex, who are you designing it for? So who are you designing it for? See, it's sort of counterintuitive because we all love data and you think the twin is built bottom up. I recommend that it should be built top down. I hope it answered your question, yeah.
So is this live, and who is using these? Who are actual users?
Yeah, this is for absolutely for the decision makers. It is live, and public also can access the platform. And the live one is the foundation model of ThiNI. In this, the data can be read and analyzed through the AI also as well.
So sorry,
please.
back and forth. So one of the bigger challenges is the provenance and the confidence of this data sets. And while the user interface gives an illusion to people that the decisions are sound,
Yeah.
and it be a lot of mess behind the scenes that we all are deeply aware of. So how does the tools like these need to state where is the data coming from? What is the confidence in that data?
Yeah, I'll defer that.
And on what basis are we recommending these decisions? Because then decision makers, they're already struggling. Now you are giving them these tools, and so who's going to take responsibility of the recommendations that these tools are emerging?
Regarding the data, we are collecting from the authorities who has the power to generate the data. For example, we're getting the land use land cover data from NRSE, who is publishing the data every year. And also they give land use land cover in 1:50 day, high resolution data in some 5 years interval or 10 years interval. This is, we are ensuring that the data is authentic, first of all, and we are validating the data before utilizing it. We are doing the quality check before using it. If it is the data is coarser resolution, we also give the information to the user that this data can only be limited this scale. So you can use this for a state level planning, not for a village level planning. This kind of information we are giving to the users before using it. And any other thing I must?
No, absolutely. Absolutely.
I'll just add one more point to a question about data. I think the problem with the government is that, they want macro trends. So the ground truthing of data, one part is what Shalini said. Ground truthing is extremely expensive, whether it is a biodiversity thing or whatsoever. What ThiNI is trying to do is to give them a sense of which way the winds are blowing before you actually put people on the task. So it is sort of a funnel. You know which way the wind is blowing, and then you deploy ground truthing. So it's very expensive otherwise.
Absolutely.
So excellent, yeah, thank you. I think we are kind of encroaching into the break, but I have the distinct pleasure of inviting Professor Wadhwani, and we are going to have a very high-tech view of visualization, in a very different world called metaverse. Okay, Professor, please join us. Yes, thank you.
Thank you. Yeah. Thank you, Professor Ramakrishnan and Geeta, for organizing this wonderful workshop on mobility, digital twin. So the speakers before me have given a very deep insights into the digital twin, the demos, and I'm going to give you some kind of, add little more dimensions to the concept of digital twin we are all going to talk about, right? So the metaverse is what I'm going to talk about. Metaverse is slightly different from digital twin. We'd say digital twin is a subset of metaverse, or metaverse is a superset of digital twin, because in the metaverse there will be only digital assets would be there. There is no corresponding physical asset will be there, right? So whereas in digital twin, both the physical as well as virtual assets will be there. They are interconnected. Particularly, it's a two-way interconnection. If you change anything in the physical, the virtual will get changed, or if you change anything in the virtual, the physical will get changed, right? That's a two-way coupling between the digital and real assets, correct? That's a digital twin. But in the metaverse, there may be something that is only virtual or only physical without any virtual component. That also is possible. But still, it is interacting with the metaverse. There is a subset of digital twin, right? So, there is, for something, digital twin is a superset. That is called the digital replica. Digital replica will be only a small model of the real asset, correct? So the real asset means, in the sense, it will have only one-way interaction, not a two-way interaction, correct? So when you change something in the real, the virtual changes, or when you change only in the virtual, the real changes, not a two-way interaction. So these are the things: metaverse, digital twin, and digital replica. I would like you to keep this in mind for the entire discussion, right? So here we have a laboratory or center called Experiential Technology Innovation Center, and there are it's a highly interdisciplinary. Various faculties get involved in it, various other IIT faculties as well, and then global experts as well. It was started 20 years ago as a very small touch lab, haptics lab. Haptics lab is still a unique lab in India, right, where we look at how our touch sensation is actually now working, and then therefore develop technologies to give you touch sensation in the digital twin or in the metaverse or in the digital replica, correct? So since I'm a professor of biomedical engineering, we have been looking at how to help the doctors with the digital twins and the digital metaverse simulations, right? I'm going to ask you to think about the definition of the metaverse or the digital twins a little more carefully. Metaverse is an experience in 3D internet. It is not just the digital world or the physical world or the combination of it. It is an experience of it, correct? So can we measure this experience? Why do we need to measure it? Only when we measure it, we can actually make a science of it. Without the measurement, we can't have a science of it. We can't have a science of metaverse. We can have a science of digital twin, right? So we can't have therefore we can't have an engineering of a digital twin or technology of the digital twin. That is why in IIT Madras, in our center, we focus on understanding the experience of it, experience in a digital twin, in a 3D world, right? So we look at how the human is perceiving all this information when you are in a 3D world, right? Understanding the human perception is the major objective of this particular center, right? So this understanding the human perception is the fundamental of metaverse, and therefore the science of metaverse. And we teach our students how to measure this human perception. We teach another course called psychophysics, which is a very unique course taught in India, right? So, how do we measure this human perception? Something goes on in your brain, right? How do we measure it? How do we quantify it? How do we subjectively quantify it, capture it? That is what we measure it. We teach our students, right? And therefore, we have introduced a new subject called perception engineering, and perception algebra, and perception and physiology. And this understanding, we wanted to spread it to other IITs and throughout India, and therefore create a metaverse corridor and XR corridor or digital twin corridor and things like that, right? It is very similar to the IT corridor that India already knows, correct? So the Oculus co-founder, I'm not sure, a lot of you have used the virtual reality headset called Meta's headset called Oculus headset, right? Its inventor, co-inventor, is a visiting faculty in IIT Madras, and together we are setting up this a metaverse corridor. India is a metaverse corridor. The left side is our one IIT Madras alumnus. Now he was an IAS officer, Prakash Damodaran, and he was the IT father of India, and he is also with us. Together we are helping India build a metaverse corridor. Right? In a metaverse corridor, there will be experiential spaces. Actually, we have a lot of demos which I'm not able to show because it needs a lot of equipments. It is there in the research park, the ground floor, E block. If you can now walk to there, we'll be able to show a lot of these demos. There is an experiential space which we have created. Similar experience space, we are setting it up all over India. And then we are setting up VR skills training centers, and therefore we are teaching VR courses and the manufacturing unit. And finally, the CAVE consortium, a consortium of 300 startup companies working in various metaverse technologies. This is a consortium for augmented reality and virtual reality engineering. This is a unique consortium in India. It has a lot of many compositions, associations, and brands in the consortium. There are partners as well. Particularly for the mobility digital twin conference workshop, this vertical of this consortium may be useful. This is the automotive vertical. There are few automotive companies who are looking into making use of this this metaverse technologies for solving some of our problems. Can you help me to this? Okay. Particularly, I wanted to focus on our specialization called haptics. There is another dimension I wanted to add to it. Particularly the driver safety, or the is it okay? Yeah, driver safety, and basically, basically, in terms of the driver assistance systems or collision avoidance systems and driver alertness systems, haptics is going to be very, very useful. We are working on all this the systems. Not only your haptics, along with the visual and auditory feedback, it is going to be very useful for the driver. And apart from the safety, navigation and accessibility also, we are looking at it. And other than this mobility CAVE, there are educational technologies, CAVE, medical technology, a lot of other verticals are there, which I will focus on later. And particularly in India, we are looking at the frugal digital twin. Can we think about it? Okay, all this in a headset and metaverse, it is very, very expensive for India, right? India needs a frugal technologies. That is what our focus is actually. So we have written the white papers and we looked at the measure of the metaverse. There are several indices we have defined, and we looked at the skills spectrum in India, and we looked at the open source development, and we have our own newsletter, XTAC newsletter, and through this newsletter we have been releasing a lot of reports. For example, recently we released this report on a case study of the Tamil Nadu AVGC XR policy 2026. We looked at the critically analyzed it and released it. It is available on our website. And similarly, we looked at the policy and standards of other governments as well. Now we are going to release it to the Madhya Pradesh and Maharashtra government as well. And this, along with Department of Telecommunication, we have written a recent report on metaverse different use cases, where mobility metaverse also is one part of it. This also can be accessed. And we are regularly running as XR Summit or Metaverse Summit, where we invited A.R. Rahman and given him an award for his contributions to the metaverse, right? And we particularly focus on the global south, because we are focusing on the frugal innovations, correct? Okay. I wanted to just, final word, I wanted to emphasize on our work with ITU, International Telecommunication Union. The ITU, which is a global organization in Geneva, they have looked at the metaverse digital twin in a lot more detail. They have now maybe the stack already available because it is a standard organization. So probably now our MInT can look at what is the stack already available, make best use of the stack already available, so that the interface with the international will be very useful. And they have a cityverse use case taxonomy very well developed, because it brings in a lot of use cases which is very very difficult to get. They have looked at the research based involving the academic institutes as well as the stakeholder consultations. They have now reported these cityverse document. Maybe it may be a good idea to look at it. I'm going to particularly I'm going to focus on now this one. I'll end up my presentation with this particular statement. Now, the digital twin we are talking about, right? Can we think about a haptic digital twin, where we can touch and feel the digital version of the physical one? Where would it be useful? It is useful for us in biomedical engineering. We develop a lot of training systems for our doctors. Wherever there is a physical human being, we have a digital human being, and therefore have a tangible digital twin is needed, where we can do the injection simulation. Not only simulation, but all the touch and feel of it in reality, right? So along with Accenture, we have developed a basic fundamental database necessary for all this haptic digital twin. Because now this is where wherever is a haptics is needed, it needs to use all these databases, and therefore this is actually available online. We will demonstrate it if it is necessary, and this is going to be useful for adding next dimensions to the digital twin. I will stop here, and I will take any questions if there is any. Thank you.
Any questions from the, sorry, this is not working. Yeah, any questions from the online audience? Okay, how about those in the conference room? Any questions? All right. No, thank you, Professor. I think we are very excited that now we have this dimension available as well, which we will start integrating. Thank you for your presentation. Okay, I think that kind of brings us to the end of the panel discussion. Professor Geeta, it'll be awesome if you could come forward. And the presenters who presented today, can you also please come forward, so we can kind of share some of our appreciation with all of you. So, Yeah. Yeah, Avinash, well, you had progressed. Thank you, thank you. All right, thank you, thank you. And who else? No, no, yeah. Yes, yes, yesterday we honored him. Come. You also come forward, Shalini, you can take a picture along with him. Come.
So we'll have it ready. Once you start, we can change it.
Thank you. All right, I think this brings an end to the first panel, and I think I'm going to hand it over to Soumya on the next item on the agenda. All right.
Okay, I'll maybe quickly introduce our next speaker. So we're going to have Professor Bhargava. Professor Bhargava is, of course, a dear colleague from transportation. So he's been at IIT Madras for close to 10 years now. He is an expert in traffic flow modeling. So I think modeling Indian traffic is perhaps one of the most challenging, mathematical modeling exercises in the world, right? With all our complexities, and that's something that he's been working on, and he has a very, very interesting approach that they have recently published. So we invited him to come and give us a talk about the work that they have done. So, Professor Bhargava.
You need a column mic or?
Yeah, it's probably better, right?
On button phones are. Slide is right.
We good?
Yes.
Okay. Good morning, everyone. I think it's still good morning, right? Yeah. Okay. So, very happy to be here. My talk is going to be a little more technical than what we have been hearing. I'm going to get into more details than what we have been talking in the panel in the last few hours. So, I'm going to focus on the modeling aspect of traffic. So, I'm going to talk about a new model that we proposed recently, which is kind of composition agnostic, because we don't need to keep track of how many buses, how many cars, how many bikes are there. So, it's a composition agnostic model, and we call it aerial continuum model for a reason. I'll explain this during the course of the presentation. So, one of the things that we developed is a continuum model, which is a macroscopic model. We'll get into the details of it. But the main rationale or motivation for this model is that we have a huge variability in the amount of vehicle classes that we have, the number of vehicle classes that we have on the road. Right? We have, if you look at this picture that shows that the proportion of households with cars, right, it's pretty variable. Proportion of bikes, number of households with bikes is variable, right? So, when you put all these things together, different vehicle classes together, you will see that every location has different composition, right? You don't see 80% bicycles and 80% bikes, 20% cars, or any one particular composition happening everywhere in India. So, it's kind of all over the place in the sense of the composition is varying significantly across different locations. which means if I build a model which is dependent on composition, it's going to be of limited use because it only works for certain locations. So if I build a model that is composition agnostic, it's going to be much more widely applicable. So that's kind of the motivation for this research. So when we talk about models, right, they are the core of digital twins, right? So we want prediction to the digital twin. We want to do prediction, scenario analysis, right, monitoring, and coming up with strategizing and understanding what are the implications of different decisions that we take. So prediction is very important, and the brains behind prediction is the simulation, right? We need a model that actually tells you if you do this, this is what's going to happen. So the simulation is kind of the brains behind any digital system. And when you talk about simulation, there are a lot of issues that we need to be aware of, right? The resolution, right? What resolution that we are going to simulate, because it's going to give you, it's going to influence the fidelity of the results. Also, if you want to get very high results, then you may need to go for models that will be computationally more expensive. So in the context of traffic simulation, we generally talk about 3 types of simulation models: the macroscopic models, the mesoscopic, and the microscopic. Now people talk about picoscopic models. I did not put it here because I think not very relevant for this talk. But what is more relevant for the kind of digital twins that we are talking about, right? When we talk about digital twins for a city level or even state level, right? We were looking at large regions which we want to kind of digitize in the system. So in the context of that, these 3 seem to be more applicable. So the macroscopic are the ones where we look at aggregate variables. So for the people who are not traffic engineers or transportation engineers, just a quick review. So macroscopic, we look at aggregate values, and then mesoscopic, we look at the link level, what are the features, and then microscopic level, we look at the agent level. So every car's behavior we are trying to model. So depending on what we want, you use different types of frameworks, the macroscopic, mesoscopic, or microscopic. Microscopic are of course computationally very expensive because you are simulating every vehicle. If you want to do a city level or a state level, of course it's not going to be scalable, right? So what we typically look at is macroscopic when we look at large regions. Even though computation is cheaper these days, still makes sense to have macroscopic because it gives you what we want at a reasonable level of accuracy. So what I am proposing here is the macroscopic model. And again, as to revisit, there are some more reasons why we need a model that we have proposed, right? So we have variable vehicle classes, which I already talked about. What does it mean in terms of modeling? They have different kinematic features, which means their acceleration, deceleration behaviors are different, right? The static features are different. Some are longer, some are shorter, some are taller, right? So which means that they get different levels of maneuverability. Like bikes you already know, right? They can kind of seep through stop traffic or slow moving traffic, whereas trucks won't be able to do that, right? So the static features give certain advantages, so kinematic features, and then you have a lane free movement, which means that you have to treat the whole road as one channel. You can't treat each lane and then talk about what happens in each lane, right? So some of these things kind of make the existing models not so suitable. Also, existing variables that we use for defining the state. So what is the traffic conditions on the road? You typically use flow, speed, density, occupancy, and these are variables that we typically use, but those are not adequate because when we say density or flow, I need to supplement it with composition. I can't say the flow of 2000 vehicles per hour. I don't know how many of them are buses or bikes, right? So I can't just use variables like that. So some of these variables are inadequate for describing mixed traffic. And then going to the next level, when I use these variables which are inadequate, the models of course are going to be inadequate, right? So we have existing models which are mostly based on vehicle conservation. People who are familiar with macroscopic models would know kinematic wave model, for example. It is based on the concept of vehicle conservation. Again, that's not going to be very relevant here because of the composition. And similarly, people have come up with multi-class models, second order models, and those things. Again, they suffer with the same issue because they are not scalable. When you have more and more vehicle classes, you need to have more equations to solve. And also you have the impact of composition is going to be still a problem, right? So all of these reasons we need a new model. So before that we need new variables and new models to simulate mixed traffic, what we see in India, right? So that's kind of what we need. So that is what we try to do in this study. Okay, so as I mentioned earlier, we have traditional variables, speed, flow, density, area occupancy, right, which are very well known. And then these are defined based on Eddy's definitions, which some of you may be already familiar. But as I said earlier, when I say speed, a speed of a group of vehicles, but which vehicles are we talking about? We have different kinds of vehicles, right? The traditional Eddy's definition says that the vehicles are all assumed to be the same, right? So you have each vehicle a car in the context of homogeneous traffic, but in the context of heterogeneous traffic, you can have different vehicle classes. So you have time on x-axis, the distance along the road on the y-axis, and then the width of the road as W. So you need a three-dimensional definition of eddies now. Actually, Abhirami worked on this part in her initial stages of her PhD, right? So yeah, so we are going to adopt that three-dimensional definitions of eddies to look at how do I revisit these variables to make it applicable where we can have different vehicle classes. So one of the nice things about Eddy's definitions is it allows you to look at different vehicle classes when I still take the area of vehicles. What is different across these vehicles is the area of the vehicles, right? So instead of counting them as individual vehicles with vehicle number 1, 2, 3, 4, now we look at the area of each vehicle. We have area 1, area 2, area 3, area 4, area 5. Okay, I don't get into the math of it, but broadly speaking, the flow, now we call it aerial flow. What we have is typical flow. Now we have aerial flow, which is defined as average vehicle area multiplied by the total distance traveled by volume of the region. The units are a little different, meter square per r meter. Here meter comes into picture because we look at the width of the roadway, we don't look at lane. So you get in the denominator width of the roadway. Similarly, the density is defined in terms of total vehicle area. So to define them, the area crossing a location is how we define the aerial flow. The total area occupied by the vehicles in a region is defined as the aerial density, which is actually dimensionless. And then the speed is actually same as what we have in the traditional, because it's a ratio of these two, flow and density, so which turns out to be like this. So the new variables that we propose are the aerial flow and aerial density. The good thing with this is now I can use this for conserving the vehicles irrespective of the composition. Okay. So again, quickly go through the equations before we get to the results of it, but when I look at conservation of total area of vehicles entering this surface and this surface, right, and then look at conserving across this surface and this surface, I actually get a very similar model, which is similar to the hyperbolic PDE, the kinematic wave model, where we have partial differential of the aerial flow plus partial differential of aerial density with respect to time gives you the net flow into the system. If you are more interested, the paper I'll have the paper listed in the later part, if you can go through it, the derivation. But the point is, it is a hyperbolic PDE that we can solve very easily, right, to actually figure out what is the density at any given state. So it enables you to do predictions of density, right. Again, these are QA and KA, which are the traditional or the proposed aerial flow and aerial density variables. And these variables are not in isolation, they are actually connected to the traditional variables. So here we give how they are related, and we are very nicely related. So with only some constants, you are able to connect them to the traditional variables. So the area occupancy is connected to this by all of these are constants. Similarly, the aerial density is connected to area occupancy by multiplying with a constant. So they are nicely scaled variables of the existing variables, right. So then we have this data, then we looked at, okay, is this even applicable for Indian context? So we looked at data from three cities. So one from Guwahati, Surat and Chennai, and here is shows the composition of two-wheelers, cars and heavy vehicles. So kind of good spread of compositions. So we looked at all these data to see if these models can be validated. So we tried to figure out the fundamental diagrams which are required to solve the PDE that we showed earlier. So we propose two fundamental diagram, which is two regime fundamental diagram, where you have different equations for different regimes. So if it is free flow condition, you have a nonlinear function, and then if you have congested conditions, you have a linear function of Kj. And so we fit it to the when we do the curve fitting, and what you have here is areal density and then the speed of the stream, and we see that it actually fits very nicely the Smulders. We call this, this is a traditional Smulders fundamental diagram. It fits very nicely. So which looks like this. So you have a nonlinear form in the free flow branch, and then you have a linear branch on the congested side. And then we also build class wise fundamental diagrams. So which means that instead of looking at what is the average speed of the stream, we look at individual vehicle class speed. If I want car speed or bus speed or bike speed, I can still get those variables, and we see that they are nicely, the same fundamental diagram actually works pretty well. And what's interesting here is their behaviors are significantly different in the congested regime. So in the free flow regime, you have most of the vehicles traveling at the speed limit, but then once you are in the congested branch, you have different vehicle classes doing differently. So that's kind of interesting, and that's what we observe in the real world also. And then we did a solution of the new continuum model with different methods. Method of characteristics is a very well known method, and then the shock wave method. One thing that it preserves is you can still use the shock wave equation that we know from the traditional methods, right? The same equation will hold good to get the shock speeds. So, and then we will be able to use the same Gordon scheme because it is also a hyperbolic PDE, right? So, we use the cell transmission type model, which is a Gordon scheme, and this is the equation for it, and we kind of modify the cell transmission model by for mixing of vehicles. So, if I have two different vehicle classes trying to go from one cell to the next cell, how do they occupy the downstream cell, right? So, that is kind of based on, so we modify that based on the densities of the relative densities of each vehicle classes in the upstream cell. Anyway, so then we did some experiments to see whether this model actually replicates what we see in a phenomena level, right? So, we want to see whether phenomenological level we are able to replicate the behaviors that we see. So, here is a case where I have a mix of vehicle classes. So, I have bikes and trucks, right? I have cars and trucks. So, they are mixed together, let us say at a signal, and then signal turns green and they all start moving. What we see in real world is dispersion of vehicle classes. So, you see that the cars will be able to go faster because they can accelerate faster, but then you will see the trucks will actually not be able to accelerate, so they kind of slow down. So, over time, if you have a long corridor, say 2 kilometers or 3 kilometers, you see a separation between two vehicle classes. That is exactly what we observe here. So, they all start together, but then you can see that the cars start going, and then you have trucks which are kind of going below. The other experiment that we did was to see if they are able to merge and then overtake, right. So, we should be able to see the overtaking behavior. So, here I have two different vehicle classes. So, again cars and trucks starting at two different locations. So, I have a group of cars, I have a group of trucks and I have a group of cars. These guys will come and overtake over the time, right. So, you are able to replicate that behavior also with this model. So, yeah, so what we have proposed is a model which you do not need to consider what is the composition. I just need to know what is the area of vehicles that I have on the road, right. So, I just look at total area of vehicles and then I use that to predict what is going to happen in future. Okay. Again, the limitation of this is I am going to get again in terms of vehicles occupying the road surface. Does not mean that I will know how many cars are there, how many trucks are there. I just know that this is going to be the area of road occupied by vehicles in the future. So, how do I use this, right? So, I think we will still be able to use this model with the limitation I mentioned, because we are not so much interested in how many vehicles are going to be. I mean, of course, if we want to know how many buses are going to be there at different time, maybe this is not the right tool. But if I want to know how the system is evolving over time and how the speeds are changing over time, or how the congestion is propagating at different parts of the network, we would still be able to use this model, because it will be able to replicate the traffic condition irrespective of the composition. Okay, so I think we can use it for different applications. I am sure you have many more applications. These are some things that I could think of. So, network monitoring, congestion prediction, scenario analysis, all of these things which are easily replicable with this kind of model, right. And how do I integrate it? Of course, I am sure a lot of you already know this, but we need to represent the system in the network, then implement the simulation model, there are some more models. I mean, it's not like I have this model and I will be able to solve everything, but I need some more additional models that will talk about, that will be applicable or will be required for a network level simulation. Then we need to get the data and synchronize it, then process it, and then have a decision support system, and then monitor performance and strategies, and a feedback that goes back and forth to reevaluate our strategies, right? So the core takeaway from this talk today is we now have a new model which is relevant for mixed traffic conditions, and it is computationally very light because I am not looking at individual vehicle. That's one advantage of it. The other advantage is it is composition agnostic, so which means that I will be able to use it at different locations. But the limitation of it is I will not be able to know every vehicles, I mean how many vehicles are there on the road at a class level, but I will know at a broader level what is the congestion level, what is the speeds that are out there on the road. So these are the main takeaways from this talk. I will be happy to answer any questions. Thank you.
You mentioned that in the simulation you can show that the cars are overtaking trucks.
Yes.
But if you don't know the composition of cars and trucks, how do you know that who is overtaking who?
Yeah, so we calculate the areal density, but then we keep the trucks. So we keep how many trucks are there, so we use the multi-class fundamental diagram. So we did not use, so there are two fundamental diagrams we developed. One is at a stream level. Okay, so I know the stream, but I also have class-wise fundamental diagram. I know which vehicle class. I mean, the simulations that I have done is using this, but if I start using this, as you said, the computations will go high. So ideally, you would want to use this, which means you will not know how many trucks are there, how many bikes are there, but I know the stream. But if I do this, then I will be able to figure out at a class level. Yeah. Good question. Yeah. I hope I did not overshoot.
So this is in PCUs, is it? How are we computing?
So this is not PCUs. This is the whole point of this is not going to PCUs. It's areal density. So total area of vehicles crossing a location over time. So flow is not number of vehicles,
okay,
but total area of vehicles crossing a location.
Okay.
And then areal density is total proportion of road occupied by vehicles. So area by area. Okay. So it's dimensionless. So these are the two new variables that we use.
So, but I mean, suppose you had say 3 two-wheelers, and that area is going to be equal to 1 car.
Yes.
Right now it's going to treat both as same.
Yes. Yes. That's another thing. So we won't be able to understand the variations in that. So the advantage is you don't have to treat them. So I need to know there are 3 cars for 1 bus. It's going to be, they'll be behaving similarly is the assumption, underlying assumption of this.
Sure.
Yeah. Because a good thing is then I can conserve the areas. I don't need to know how many cars are crossing versus how many buses are crossing. I know total area is crossing a location. So. Yeah.
Suddenly have like a swarm of two-wheelers, some protest or something, let's say in Marina. So how does such disruption affect the model?
So, it's not a layman's question. It's a difficult question, right? But it's not very difficult because see, there are 2 pieces to it. So you treat if you have a network and then suddenly it's one location you have vehicles, people coming onto the road to do something, it's captured in the source term here. Okay, so this is part of it is the conservation, but then you have source. Let's say people are coming out of a convention hall to protest on the roads, so it becomes a source of new traffic on the road, right? So we don't simulate people, but bikes and other vehicle classes suddenly coming from a parking lot or a convention center or going into a stadium or coming out. All of these things can be treated as source term within the equation, so it kind of comes in this side. So we will be able to model that.
So there's one online question. How you got the area of vehicle, right? And what are the cells here? Is it communication?
Sense means what?
Cells. C.
Oh, cell. So that is a numerical method. The cells part is from the numerical. So if you are familiar with the cell transmission model or link transmission model type things, where you have upstream cell from which vehicles will go into the downstream cell. So it's a numerical method for solving the PDE. So that's the cell. The first part, area of the vehicles, is you look at the static dimensions of vehicles plus clearance is what you use to get the area of vehicles.
Okay, so let's thank Professor Bhargava for that amazing talk.
Thank you.
And hopefully we'll get to use some of these. Once we have more data, we can apply and we can see how to use these. Thank you.
Thank you.
We have a bag for you.
It was good, right? Okay. Huh? Okay. Professor Geeta Krishnan will now honor Professor Bhargava Ramachilakuri for that fascinating talk. Thank you, sir. Please receive a little momentum.
I'm part of the family, so I don't need any special.
Yes. Thank you, sir. Thank you, sir. We're running late. I will attribute that to the quality of the discussions, quality of the demos, and the passion with which people have been presenting today. On the agenda, we had a coffee break, but I'm now going to skip it, and we're just going to move into the next panel. This is about, the topic is DT for integrated multimodal mobility systems. And in a place like Chennai, India, especially where you have an auto rickshaw, specifically a share auto rickshaw, where you fit 12 people into a 3-seater, right? A metro line, a city bus, and a walking pavement, all part of India's daily commute. This topic makes some really interesting propositions. It's all about making these modes actually talk to one another. We will have Professor Geeta Krishnan as the moderator for this. A powerhouse panel featuring WRI, ITDP, Kumta, URCABS, and IIT Delhi. They will dissect how we integrate emerging transit modes with the world-famous India stack. Think UPI and IRCTC style seamlessness for local transport. We'll look at logistics standardization and consumer-first design. And multimodal mobility in India is legendary, and we've all done the hop, skip, jump kind of routine. Let's explore how we move chaos into co-intelligence. I thank the panel for holding on, and apologies for the delay. We are now getting started with panel 2. Over to you, sir.
I just forgot to. Okay, sorry to interrupt. So I forgot to acknowledge my student who actually was behind all this work. So Nandan, my PhD scholar, was one of the main contributors of this work. So, okay. Now he's a faculty at IIT Kharagpur. Yeah, thank you.
So thank you all. I think we'll straight away get into this panel. I think a few panelists are joining online. Others are here in person. I request Maria Anthony to join me on the stage here, and Bessie from ITDP is also online or in person?
In person,
Bessie
yeah.
is here.
And we also do have
Hi. Avinash?
Avinash here. Avinash Dubedi from WRI. He's probably just stepped out. I will ask him
Maybe
to
he
come in.
stepped out. If somebody can go fetch him.
Yeah.
Thank you.
We do have the others online.
Maybe we can highlight.
Let's make them the co-host, Adi Balakrishna, so that they can speak. Akila from Kumta.
we'll use this, right? Because
Dr. Pravesh,
Okay.
apologies
mic
for the delay. I hope.
Can the online participants please put their hand up so that we can then highlight you? Akila is there. Can we make Akila a co-host?
Just make them the co-host. Adi Balakrishna.
A. Balakrishna is there. Can we make him a co-host? Avinash, you can come on stage. Yeah.
Yeah, that was a short coffee break. I hope you had a 60-second coffee.
Thanks. So, have we made others co-hosts? Balakrishna, yeah, thank you. Akila is also there, thank you.
Thank you. Thank you, Mr. Maria. Good to see you again today. Thank you.
Professor Pravesh is there. Okay, I think maybe we'll have Pravesh join shortly, right? Okay, yeah. Hey, Pravesh, thanks for logging in. Yeah. So we'll get started. I think over the last few years, there's been several organizations, several researchers who've been primarily working on what I would say is public transit data, right? So a lot of work had to be done because we are dealing with legacy systems in a lot of the public transit operators. So they had to, come up to speed, right? Work with them. The digitization process, all of that had to be done. And there has been some fantastic work on that aspect. But what we are also seeing is we have metro systems which have projected ridership, of several million, but they're not able to achieve even 50% of what is being projected. And one of the key aspects that people seem to point out is the lack of multimodal integration, right? So we said, all right, when we talk about digital twins, yeah, for public transit, there is already work that's happening. But we need to look at it in a much broader perspective. We need to think about it as a multimodal digital twin, where public transit, of course, is a line haul. It plays an important part. However, there are other aspects as well that we need to bring in. And some of these modes are operated by the private sector, are operated by maybe small operators, and therefore integrating them is much more challenging, right, as compared to public transit. So what should be our approach for us to expand the ecosystem, right, to have an integrated multimodal mobility digital twin, right? So that's the core, agenda for this panel discussion. So what I would like to do is initiate, maybe I request each of the panelists to initiate the discussion with their thoughts regarding this, right? Maybe you can take a couple of minutes, you can share your initial thoughts, and then, we'll have other specific questions that, we'll share, right? One of the things that we also wanted to keep in mind is it should not only just be public transit, passenger transit, passenger movement, but also logistics, because they're both, part of the mobility ecosystem, right? So of course, Balakrishnan is an expert in logistics, right? And we also want to hear from him on this aspect of multimodality in logistics. So what I'll do is I'll start with the people here on the stage first, right? I'll start with Maria Anthony first, and then Avinash, then Bessie, and then we'll go online, right, next.
Vanakkam, very good morning. It's really great to have a discussion with you all. As an industry expert, having nearly 2 decades of experience with the mobility, because my experience started with FastTrack, one of India's pioneers in a taxi field. which started as a radio taxi. So the concept evolved from radio taxi, then it evolved as call taxi, then app-based cab services. So I can always tell that there is a continuous improvement in delivering the service, making things better, experience better. And as per this particular initiative, these people are IIT across India, they are visionaries. As politicians are visionaries to construct or give very good infrastructure, institutions like IITs, they are visionary, and they want to see how exactly the things should happen in future, right? So for that particular reason, I really congratulate the entire team of MInT for having taken this initiative. Because what exactly a passenger or a commuter is looking forward now, for me, to leave from IIT Madras to airport, okay? I just wanted to go from one place to another. I do not mind, I am not concerned about the mode, okay? So based on the situation and the need of my priority, I need to get a plan. So what are the information available? So that is where we start. We need to start from. What are the information that we have? These information validated in a standardized format, and how exactly this information can be helpful. The information that I have is not, for example, I am owning FASTag as well as WoodCaps. The information that I own within FASTag entity or WoodCaps entity may be really helpful for others, but how exactly I can share? What are the threads? And how exactly we can standardize, we can move forward and standardizing method in terms of sharing information without giving any thread to the data or any other related activities. So this particular initiative really eye opener for many challenges that we have been facing, are the many improvements that we wanted to have in place. So I am happy to share my views as we move forward, and I will be taking valuable information during this interaction. Thank you. Thanks a lot.
Thanks, Mariantri. So I think definitely, but to even hear that a private operator saying, I'm willing to share data is, very pleasant, right? That's usually difficult. So Avinash, if you can share your initial thoughts on.
Hey, hi, good morning. To start with, I would like to answer this in two different ways. The first one from the commuter's perspective. So as a commuter, irrespective of mode, if I want to go from A to B, what is it I need? I need information. Information from different modes, pre, during, and after journey. Pre for planning, during to just adapt if there is something happening, and then post to just keep an information about it. But do this information exist? I would say yes, it exists. But the another question is, does commuter have this information? I would say no, because at every, it's not about the mode, even for the same mode. So say for example, there are buses, but there are two different operators. So the moment my journey breaks or it exchange hands from one operator to other, this flow of information breaks. This is within the same mode. Now, if I go to the different modes, the complexities are even higher. So information exists, but still it is not available. So that's the challenge. So for the digital twin to happen, this is a precondition. Like this seamless flow of information, not only across a single mode, but across different modes. How seamlessly it happens, that will decide the success. So I think to your question, yes, such thing is needed, and different modes, whichever is help commuter to ease their journey, or in whichever, increase the comfort, safety, whatever the feeling. But if it eases, all those modes needs to be included. But the question is how. why any private operator will start sharing the information. So based on our primary discussions, the challenges they feel like that might compromise our business this thing. But are they willing to share? Yes, they are willing to share. So because if we are able to convey the message that it is not only for the commuters, but in a way it will be beneficial for you at the end of the day. So that economics, if it is clear, I think even the private operators will start sharing. But we need to answer the question how. I think during the course of this discussion, we will deep dive into this how part of it, but that's my overall sort of this.
Thanks. I think, identifying the benefit or initiative, right, for everybody. Maybe you could pass it on to Bessie. Bessie is from ITDP, and ITDP has, of course, been doing a lot of work with respect to non-motorized transport in the country. Bessie, if you could share your initial thoughts.
Thank you so much, sir. So firstly, I would like to thank for the invite. It's such a pleasure to be part of the panel. And to start off with, I would say I would maybe focus more on data because that's sort of the hero of building a DT. And sort of I would like to lay it in 3 hierarchies, right? First, you need data. And this is something that as in Chennai or in our country, we've seen STUs adopt towards to. And say in terms of adopting to GTFS or GTFS RT or so on and so forth, right? And that's the first layer. The second would be on how it's more of like data shadow, where how the operator changes something and it reflects to the main data or the reference point from which it's taken from. That needs to be established so that any changes, so because now that a lot of operators will be working towards one reference or one reference data point, there'll be multiple changes every day or every now and then. So that needs to be reflected. And this final part of the story is of how the two-way communication happens, say in terms of simulation or any change in the operating procedure or operations could be simulated in the system or in the DT, and then that reflects to the, say, the depot manager or the operator or so on and so forth. That's where I would like to start with, so that I would like to more focus on the data part, yeah.
Thanks, Bessie. I think very, very important. Data is where we start with. And of course, the data is available, but it's not accessible, right? So that's the point that's come through. So maybe now I'll move over to our online participants. Maybe I'll start with Akila, who's been, of course, working with Kumta and the Chennai One initiative that they've launched, right? Maybe Akila, if you could weigh in with your initial thoughts.
Thank you, sir. Thank you for having me. My focus would primarily be on how a journey itself is perceived from a user perspective. I think multimodal integration is not just station to station, but maybe door to door. How do we bring the entire integration? How do we bring like consistency in the experience of going from a seamless transfer, maybe be it transfer time, the level of service, digital integration, operational integration. So there are quite a few layers to look at it from a point of just operationalizing an idea. But yeah, like my colleagues, my Praveen, everyone from Chennai One team are attending the MInT conference in person. Chennai One is one of those initiatives we took where we looked at how public transport information can be collated. One more thing, as like one of our co-panelists suggested, it's how the information dissemination happens. We don't have standards for that. For example, even though it's multimodal integration, how do we inform people? Is it going to be like set standards, just like signages and wayfinding, where everything is at, you just know, if this is a bus stop in 200 meters, I'm going to find an IPT bay. That sort of standards are yet to be established as well. So I think like standards are going to help us scale and lay the foundation of how multimodal integrity can happen in a more cohesive way. But this is my take. Thank you.
Thanks. Yeah, I think if folks here haven't yet used Chennai One, I encourage you to download Chennai One. I think it's a great app, what they have done. For the first time, they've integrated with the railways as well, right? So I think that's a great achievement that they've done. So Thanks, Akila, for sharing the perspective from Kumta's side. Now I, of course, move to Pravesh, Professor Pravesh from IIIT Delhi. He's an academic, but he's also somebody who is a startup founder. And he's been working on the space for the last decade or so, right? And he's done some pioneering work. His company charter is live in Delhi, Bhubaneswar, and maybe a few other cities that he can share. Pravesh, initial thoughts from you. Yeah.
Yeah, sure. Thanks. I was told that I'm allowed a couple of minutes of presentation also. I don't have a presentation, but I want to show something. Is that okay?
Sure. Yeah. Please.
So I'll just give my initial thoughts first. So, my point is that we talk about a lot about smart cities, and I just want to make a very simple argument today that we need to make basics correct, basics right. For example, footpaths and as somebody said, bus routes, right information, etc. In fact, I want to first of all also acknowledge Chennai one, but also slightly push to say that don't keep the data to yourselves, ma'am. Please open it because that's where, so I know nobody would tell you that. So I want to tell you that if you don't open the data, then it's not useful enough. So tell this to your higher authorities. Anyways, my point is that we have to understand basics, and basics are very, very, really basic, simple. Okay. And now we have, we have this digital twin, which is now getting into a serious mode. And we also have two words, two letters, letter number one is A and the letter number two is I, AI. And that's exactly what I want to show today. That actually is very powerful. I have been working in this area since 7 years. We have released a lot of data. I'll just show you some of it. But before coming to this talk, I spent just 2 hours on something that we have been building, since some time using AI. So I use the Fable model, literally 2 hours, 6 a.m. to 8 a.m. or something like that, right? So that's the thing I want to show you. If you can, if you can allow me that.
Yeah, I think is screen sharing enabled? Yeah. Okay, go ahead.
Right.
Yes.
So can you see my screen?
Yes.
Yeah. So this is the Delhi Delhi map. You can see the Delhi map, right?
Yeah.
Essentially what we had was 5 years of bus data that covered the whole Delhi. So what we did was we built a model. This was pre-AI model. We built a model of traffic congestion using bus data. Okay. All the open bus data, it's available for anybody to use. It's in the Delhi transport stack. We made this model, and then what I did was I simply created, what I said. I told my Claude that build a system that captures, the current traffic using Google Maps. So it's just a Google Maps current screenshot, and it used our model and showed what are the anomalies in the road right now, which means which parts of the road, which intersections, which streets are not supposed to be congested right now, but they are congested right now. Okay. And by the way, this is accurate because we also tested it. So it is actually showing me there are some anomalies. And then we also fed it the data of OSRM, all the temples, all the mosques, all the schools, all the colleges, all the hospitals, etc., etc. It's all open data, right? And it is also telling me the reason why, there is a certain anomaly. Possibly right now. So this is just a very small example, that can be coded in a matter of hours, where you can actually see a live picture of your city and its congestion points, etc. So this is the power of, I'll just stop to share it. This is the power of, AI right now. I think the time has gone where we say that, oh, now we have to build a system, will take 3 months, 6 months, tender, and then, all that stuff, right? Those days are over. All we require is data. All we require is 5 students. All we require is some, crazy profs, idiots like me who will build this, who will, go and beg the IAS officer ki sir, dekho, theek kar do. I'm showing you the problem. Theek kar do. I think that's where we are. I think this is very important that we recognize this power of data. Of course, it's available, but also what you can do using that data using AI. So I never use this word in my wherever I speak AI, but now I really believe that it is very powerful, and it does not require you to be a computer scientist. You can actually be anybody, but you have to just understand the problem you want to solve and solve it. Of course, the key constraint is data, but I'm saying that a lot of data is available and we can actually do a lot of good. So that's my initial closing remarks. Thank you.
No, I think that's amazing. That's amazing, Pravesh. So if we open up data, right, we kind of democratize the analytics, right? Anybody with access to AI can build, tools on top of the data and give results, right? So that's really powerful. So of course, most of us are talking about passenger, right? Balakrishnan has been working with moving, of course, he's from Ford, right? They've been moving people for a long time, but he's from the supply chain department in Ford, right? And he has experience across countries, right, within Ford. So not only he talks about the last mile, but also the global supply chain, right? So maybe I request your initial thoughts on multimodal logistics, digital twins, right? The need and what is it that we can do?
Yeah, no, thank you. Thanks, first and foremost, thanks to MInT for the invite, and thanks to Professor Geeta for this question, right? So in Ford, I handle the metal planning and logistics department. So we take care of end-to-end, both inbound logistics, in-plant logistics, and outbound logistics. Okay, so if you see, let me take from backward, right? So more from the vehicle distribution, right? So we use first mile by, I'm talking a model what we follow in China. Okay, first mile we follow by road, and then we move the vehicle into the rail, and from the rail it goes to the closest railway station, and from there the last mile again goes to dealer, right? So this is one logistics mode. Again, you're kind of turning your multiple transportation management system there. TMS is changing, and the data flow, how you're going to know, one, you have visibility aspect of it, but the content of the data, where it is moving, how it is moving, and that's one of the key challenge. Today we have, the China team has built a lot of AI application to what Dr. Pravesh was saying, right? So I think they're bringing a lot of magic there. By the way, I'm in China now, right? So I was not able to come in person, but that is one powerful thing I see in outbound logistics side. And in the in-plant logistics side, right, between your movement between your inbound and then the movement to the point of fit in the manufacturing line, where you have to use combination of your transportation management and warehouse management, try to get the data. And again, you have different supplier, and different supplier uses different ERP systems, and the plant uses different systems. So your data structure, data flow, everything is totally different, right? So how you are going to build end-to-end ecosystem to understand which part can stop my production line? No clue. Right now, it is all, I have people to go and start chasing parts and finding where the issues are. So again, that's a huge opportunity there from the data point of view, what can be built in. The last leg is inbound logistics, like how your demand churn is happening, and then how the capacity and shipments are taking place from the source supplier to the manufacturing site. So again, there is a huge transportation management involved, and again, different supply base. So if you see the end-to-end in the logistics space in industry, exactly the same challenge, right? So unless you plan, you don't know. And then you have to secure capacity, like your RoRo carriers, like your transportation carriers. You need to plan everything in advance, at least 1 or 2 days in advance. You need to intimate them so that you can line up their capacity to deliver. Otherwise, it is going to be waste, and it is going to stay for long. So I'm very happy that the multimodal logistics and the MInT initiative, what can be done. And basically these data, how it can be harmonized and how it can flow up in the digital twin concept. And once you start providing these data to digital twin, and how I can make use of AI and try to build in. So that's the kind of thought process in which we are heading in our industry operations. Thank you. Over to you, Geeta. Thanks.
Yeah, thanks, Dr. Balakrishnan, for that. I think very interesting thoughts over there. Of course, from the private industry, the challenges are much, much more, right, compared to maybe some of the public transit industry that we saw, right? Next question, I was just wanting quick responses from everybody, right? question is, what are the modes that we need to interconnect, right? And also, what are some of the emerging modes that's coming up in India as well as globally, right? And we also need to think about regional mobility now, right? So it's people are no longer living within the city and commuting within the city. People are living in the neighborhood, commuting, right? In Chennai, it's always been happening with the suburban rail, right? People used to live in satellite towns like Kanchipuram, Chengalpattu and all other places. They used to move into the city. Of course, now the city is blurred, right? The boundaries are no longer clear between Chennai and Kanchipuram and Chengalpattu, but what are the different modes that we need to think about, right? Including emerging modes. Any thoughts on this, right? I mean, we could go in any order, right? If anybody wants to first, go, you can, yeah. Avinash, you want to?
Cool, check. Yeah, to answer the first part of your question, what are the modes that we need to focus on for interconnection? Right, okay, right. So I'll start off with an example. Say a person travels from, say, Ambattur all the way to, say, Tenampet for his work. So he maybe walks his first leg or takes a cab, goes to Ambattur OT bus stand, takes a bus, goes to maybe Thirumangalam metro, goes to the Tenampet and maybe walks his last leg as well. There are 4-5 legs involved in his whole journey, right? If you ask me which modes need to be interconnected, I would say everything. But it can have layers. I mean, your priorities. The first thing that you will have to look at is the trunk routes or the modes that provide you trunk routes, say your metro or your suburban or your bus network, MTC. So that's the first focus that we need to look at. The second, because we also have good data from them. All of them have good data. We have ETM machines, we have AVLS systems in buses, so on and so forth. So the second priority would be to look at your IPT sector. And this is a big challenge for us because all of our IPT sector is informal. We don't have good data sources coming to the government. So if MTC, during this whole journey, right, if MTC has to look at their part, they would say there's one trip from their part. CMR will say they have one trip in their part. But the IPT component is completely unknown to the government. We have share autos which are not regulated. They are not. The fare is not regulated. Ola, Uber, Rapido. We don't know what data they have with them. So that's a focus that we need to look at in the second layer. And finally, third is the infrastructure that will help people to walk towards the bus stop, the footpath network. Again, we don't have good data here to say this is the percentage of roads that have good footpath facilities, or we do not have any data on the LOS of various footpaths. Is it walkable? Is it not? Is it encroached? Is it not? So all of that needs to be mapped again. So these are the major points that I would say, and also maybe map on the traffic volume of all of these roads, because end of the day, when you simulate, when you change your, say example, you add 2 more services to 21G, you need to know what difference it makes to the road and the traffic, right? So that's the 3-4 points that I would focus on. And to answer to the second part of your question on the various modes or the emerging modes, I would rather focus more on, say, the various emerging technologies that fuel these existing modes, say intercity buses, or all of these are now open, right? Redbus, BBook are buses through Redbus or Abibus. Again, it's a digital platform that's been emerging. So the technology is emerging is what I see. And again, IRCTC has opened its platform to various other apps to where they need to just plug in. So I see digital infrastructure or technology emerged and being open source. That's the path I see that transport is going, so that it's more accessible to everyone.
Thanks. Any other? Avinash, yeah.
Hi, in terms of the modes, I would say we can be as imaginative as we can. Consider of any mode, a lot of modes are coming. Also for the intercity movement, like RRTS is happening, high-speed rails are coming, maybe air taxis may come, car pods may come. I think for me, what I feel is these modes will keep on coming. New technologies, how fuel them, that will keep on changing. But the way we design or architect our system, it should be in a way that whatever new mode comes in, that does not require us to change our foundation layer. So say for example, when internet was built, it was never meant to be for the social media usage on the mobile phones. But the underlying layer for it is that robust, anything can be built on top of it. So it's keep on happening. So the way we design our system, the way we design our foundational layer, it should be in a way that any new mode coming can be easily included. That should not require us to rebuild. That's number one. And second, we can focus on the new modes coming in, but at the same time, we should not leave behind the existing modes which are predominantly used by the people. So say for example, walking, buses. In India, almost 40 crores daily ridership on buses, which is even 10 times higher than what Indian Railway carries. So whatever the existing modes are, that needs to be prioritized. Like how we can make sort of commute very simple, very easy for different sections of society. That is very important. Thank you.
Thanks. Yeah. Go ahead. Yeah.
Yes. For the first one, I would say everything has to be included. There shouldn't be any exclusion. Number two, what are the emerging modes? I just wanted to say that there are a few modes that are emerging, but not enough. Like, as we are keen in building a sustainable mobility model, right? We need to, the size of the road or the road size of the road is not increasing, but the number of vehicles are increasing. There are few initiatives. Earlier, Ola, Uber, they brought ride sharing, but due to policy, they were pushed to, they were asked to study down. And I'm not sure. Many of you are aware of the carpooling. Definitely, at least a group of people know how the carpooling is working. Quick ride or blah blah. These kind of initiatives should be promoted by the government itself. That's what my intention is. Of course, it is going to impact the business. For me as a founder of a platform, Urcabs, I definitely know it will impact the business. But the question mark is this sustainability. Are we really effectively using the fleet? What is the number of cars that are being driven by the driver alone? Because I took my car all the way from Perumbakam to IIT Madras, and my car can accommodate 7 people. So how my commutation is helping a co-passenger or person who is really willing to come along with me. So this sort of, this is emerging, but not good enough. This has to be, the policy, we need to have some policy in place.
Yeah, great. I think, again, amazing thoughts there, right? Thinking for the greater good, not just one's own business. So maybe, I want to also follow up on, the point that he was making about the IPT sector being informal, right? People like Urcabs are actually working at making that more formal, right? And you did mention about share rides. The policy needs, improvement. But again, will aggregators, right? Will they be open to sharing this data, right? Or what do people want in return for them to share this data, right? Any thoughts that you have around this, right? Following on Bessie's point.
Yeah, definitely. If you ask me, will I be interested to share the data? I will ask what is the benefit that I will be getting. So the benefit has to be put in the open forum, and if there is no benefit, maybe there can be a sort of encouragement given to the organizations. So there are we do have many businesses that are running based on regulations, but as far as the taxi is concerned, it is not running on a particular regulation. For example, taxi, if I am taking a cab from IIT to Tambaram, I am not supposed, it is called contract carriage. I am not supposed to take another passenger on the way. So it is a problem. So there has to be a change in the policy. The government has to form the policy, and it is, I would say, the government's role or the policymakers' role is really important to make this happen. If we have a policy in place, definitely, and we can enforce the policy. If we have to do this business, of course, this is $1 trillion business. This particular business, taxi business, is $1 trillion business. Why Uber is coming to India? Because they know that it's a huge potential. India is a potential market, you know. So, but if we have a policy in place, and if you ask Uber or Ola or anybody, those who are coming in, to follow the policy, definitely they will be following the policy, and data will be standardized. So I would say it is at the hands of the policymakers.
Great, I think, thanks. So that actually, you know, maybe policymaker that we have to some extent is Kumta, right? Kumta also looks or advises the government on, you know, making these policies, right? So has there been any thoughts, right, with either in the Chennai 1, you know, ecosystem or beyond that? Are there any thoughts that Kumta is right now engaging with in terms of standardizing or coming up with policies for multimodal integration, particularly with, say, data sharing? Akila, over to you. Yeah.
Yes. Currently, we are looking more at standardization of multimodal integration, because even through the CMP, we have identified almost 47 locations which are like prime multimodal integration sectors, which have more than 1 lakh footfall. And we are seeing how that integration can be like brought on like ground first. But in terms of data sharing, we are working closely with TNEGA on the data policy, and we're working on things like that, but it's still in a very nascent stage. So that's where we are right now. And like you had earlier said, even when we were starting Chennai 1, and even when we were starting CMP, where we needed like data, like just Google Maps data or like big data, we weren't able to really access any of those, though we had like lengthy conversations, was going for months. I mean, Geeta sir was there throughout, even for the city logistic plan. We were trying to get so much of data, but even being a government entity, it is really difficult knocking those doors. Even to get access to reach those doors was very challenging for us. But yeah, we have taken a few steps ahead. Hopefully, there will be a better opening next time we go through this in the near future.
Yeah, Pravesh.
Yeah, thanks. So, I just want to, I think, connect a couple of points that, the friend from ITDB mentioned, and just now, Ms. Akila mentioned from Kumta. And before that, the previous speaker, I forgot his name. I think, we should learn something from what is happening around us, is that if we don't have the data, we collect the data. That's what Sarvam has done. That's what a lot of big people have done in AI, and they have really spent a lot of money. And let me just give you a thought on the data collection cost. ITDP person was talking about footpaths, and then of course Bala works on the freight side, right? Now here's an experiment that we did, which will connect all of these things, and I want to say that we can expand this to the countrywide initiative. We actually ran a e-rickshaw in a road for up and down the whole day. We collected the data on how many freight went, how many two-wheelers went, how many four-wheelers went, how many were wrong parked, how many were all kind of data, how many footpaths, how many people on pedestrian, etc. So and the cost was really Geeta, like 2,000 rupees a day for a kilometer length, and we had a good model. We used an open source model to model it, and it turns out that just by tweaking the footpath policy of encroachers and the parking policy, we would increase the freight speed by 25%. Increasing the freight speed by 25% means 25% less cost, or maybe 15% less cost for you guys. And I know that you also have a startup on that lines, which means lesser cost, better business, and it has a downstream effect, right? Lots of them. My point is that the point I'm trying to come is that it's time that we forget about Google's or the world. We can take our own data collection initiative. It's not that expensive. I mean, let me give you a number for Delhi. Delhi is the biggest city in India, around, I think around 1500 square kilometers. Okay. We can collect data probably around 10, 15 crore rupees, the whole data, literally all the streets, around 10,000 kilometers of street in 15 crore rupees. We can build a very good model and we can suggest very good policies on just that one good model. Now, I'm just talking about like 500 crore rupees for the whole, for the whole country. That's a peanut. That's a very small cost to increase the freight, and the passenger logistics by 10%, improve it by 10%. It's a very, very small cost. It will be recovered in 2 months, right? 6 months maybe. So the point is that we have to think big in data collection. I want to again say that the models are much improved now. Forget about Google, we should throw them out, in fact, right? They get our data, they don't give us the data back, right? We should behave, we should decolonize ourselves technologically also. Collect our own data, build our own models, build systems for the people, and I'm sure there is a lot of possibility. So I think all the three connect to each other very well. And of course, I truly appreciate the point of the previous speaker that government should frame a policy of data sharing which is mutually beneficial, right? I think that's a very, very important point, and this is the point we always miss. So I truly second his thought on that. Thank you.
Yeah. So that was Maria Anthony from URCABS. Yeah. Thanks. So I just want to maybe go back to Balakrishna, right? And so you had mentioned about, I was expecting that maybe in the freight side, because it's private players, fewer players, there is going to be better data standardization, right? There are TMS that you mentioned, right? And some warehouse management systems and so on. Who will take the initiative there, right? How will you standardize data in the freight side, right? Because the government is not going to perhaps, push for data standardization in the freight side, because they say, freight is nobody's baby. The government is not really putting as much attention, right? They're saying private people, you take care, right? What is the thought process there? Is there something that Ford is initiating for your supply chain? Any thoughts?
Yeah, it's basically our industry initiative actually, right? So we try to initiate that. I think the government policy what was brought, it was a very nice point, because at one point in time, if you take again comparing China versus India, right? China, we have a Yangtze River. It's a very long river. I think people who are good in geography knows that. And you do a lot of ocean movement, I mean the river movement also as a mobility, right? So beyond railways and road, you do your mobility. And that is a huge opportunity this country has got in terms of reducing the freight cost as well as improving the sustainability model, right? So with the same mindset, we were looking at one point in time, few years ago, why not we can use the Indian coastal, right? The ocean, I mean, a short movement from say Chennai to Calcutta as an example. So why not we can start moving our goods via that route? So again, we tried few options, but unfortunately it didn't work, right? I mean, from the cost point of view, and then the last mile, first mile, and all that point of view. I think this is where the government reformation, I think the government policy, if you bring, okay, by like anything above 800 kilometer, you should be using this route. That is what you really want to drive your sustainability model and all that, right? So those are all the aspects. Definitely the policies can come. Accordingly, it will also reduce the congestion. Today, you may know the eastern coast, a lot of raw material, steel movements, and so many things in industry application movement. And we have a huge, geographically very advantaged country, right? So with all the coastal and other things, we can do wonders, in fact. That's my thought. But in case of any initiative, anything with the supply base today, the independent OEMs are taking. And sometimes we do also do some consortium kind of thing, try to see automotive OEMs together, coming together, can we do something? And we put through some request and all that, but the initiative is all at this stage is one-sided.
Great. I think very interesting point there, about there is a role for government as well to address on the policy side for freight, right? It's not just in passenger, but in freight as well, right? Very, very interesting thoughts there. This is, again, I briefly spoke about standardization. Are there standards available beyond public transportation? Are any of us aware of any data standards for, say, IPT, right, or any of the other modes, right? We talked about, when I talked about new and emerging modes, even I was referring to the scooters, electric scooters, the standing scooters that people are using quite a bit. I know in Israel, there is quite a bit of that, right? Hillel and I have been discussing about these electric scooters, right? If they start coming in, right? Are any of us aware of any data standards available for other modes besides public transportation? Any thoughts on that, right? Maybe Pravesh as well, if he's had any initial thoughts around that.
Yeah, so at least for e-rigs, we did collect some data. It's called GTFS. It's not GTFS exactly, but it's a derivative of GTFS, where we collected a data of all the e-rickshaws which ply in metro. That I think it's a very nice standard. Honestly, Geeta, I don't know about other modes, to be honest. I don't know about the one that you mentioned that works in Israel, etc., the scooters, etc. I'm not sure, but all the IPT can be covered by GTFS and its derivatives very, very easily. So that's a short answer, and we did integrate that to our algorithms, and it did not cause any trouble, at least to us. Maybe we've missed something, but I think almost all the modes, the standardization is not a big problem, is all I'm trying to say. That's my point. Yeah.
Any other thoughts? Yeah.
Yes, I was looking at any such standardization policy or things available, but I couldn't see anything. But what I was thinking, the initiative like MInT can come up with some ideas which can be taken forward and which can be implemented. That's what I was thinking a few days back. So in fact, as soon as I got the invite, I was thinking what can be the roadmap for this particular initiative, how exactly this will reach the success, So definitely I was trying to read something, but I couldn't see any substantial or proven thing. So I would suggest MInT can take a lead and we can work on it. That's what I would say.
Sure, definitely. I think MInT itself is collaborative, right? Of course, URCAP is part of it, right? WRI, we all signed MOU, so we'll jointly work on that. Any other examples from anywhere in the world that we've seen this kind of IPT data also being shared and made available? Any thoughts?
I think yes, to an extent, GTFS and a variation of it can cater. In I think European condition, that NetX model, NetX is the standardization they are using. Then there is a SERI, but GTFS is like, in India, I have not seen any specific standardization beyond public transport. I think the question is beyond public transport. Are there any standards available? So I think we need to create that, but how to do it is more important. So say, my personal experience related to the buses, where there is a lot of data needs to be shared specifically for the e-buses. Now what data standards to adopt? Because we need to have a common data standard. So there could be a policy which is like the data needs to be shared, but how it is communicated is also important. So while doing that exercise where we wanted to sort of create this standard, the process that we followed is like, what are the existing thing? Who are the existing vendors or the hardware suppliers? Because it will sort of impact them also. So we need to keep them in confidence or how to do. But at the same time, whatever the standards that we adopt, it should not be biased towards particular vendor or particular this. So all those things needs to be taken care of. Hello. Largely, I think in terms of the standardization, GTFS and a variation of it can cater to public transport and IPTs. But for the other modes, can we create a standards which is like simple enough to sort of accommodate all different modes into one? So that will, I would say, simplify. We could have connectors like from some IPTs or some whatever the standard they are using, we can convert it into a way that we would like to use it. But even in the first place, if there is some basic common standards across any mode, across any technology, if we can come up, I think that will sort of ease out our implementation part of it.
Yeah, I think that goes back to also what the point you are making. Make standards which can accommodate new requirements, right? So the standards have to be open and flexible enough to add more things. Yeah, Bessie.
Yeah, very similar to what Avinash had mentioned. I think there's a standard called GBFS, if I'm not wrong, general bike share feed specification. I think that's for mainly for two-wheelers and motorbikes. And also we've seen examples of, again, what Avinash mentioned on European markets, or even LA for the matter. They had developed their own platform for the, because this is very niche in nature for them. So yeah, I think it's called MDS, Mobility Digital Specification or something of that sort. I think these two are maybe some examples to cater, yeah.
Yeah, I think definitely there's a lot of bike share as well. So when I was talking about other modes, bike share was one thing that I was keeping in mind. The other aspect, of course, is thinking about it from the customer, right? So when we think about from the customer, their main point is financial transaction, right? So how do we pay? And I think in Chennai 1, there has been some success in terms of integrating all of these tickets into one particular source, right? And I know Pravesh has also been working on something similar. So maybe if there are any specific thoughts in terms of multimodal, financial ticketing integration, right? Any lessons learned or any, problems that still need to be addressed, right? From Akila or from Pravesh, yeah.
Go ahead, Ms. Akila, please go ahead. Yeah.
So in terms of user perspective, like you had mentioned, sir, Chennai 1 has taken steps on how a single QR can take you through multiple modes of transport. But going in the future, it will be like more creative to have maybe like a mobility wallet or something which is like more integrated. Like, and adding to your previous question also, like regarding standards, I think though there are multiple standards still like nascent or like available, I think we have to have something more like common where all these standards can like come together for like a more interoperable model, and how do we integrate it better for decision making as such. Digital twin, I think, should be more focused on decision making. Simulations and predictions are one of the features, but it should like lead to decision making finally, is my thought. But yeah, like regarding financial transactions, maybe a common wallet or how we can integrate it to the existing UPIs and such. Because India does have a lot of UPI systems already available. How can we just make it a little better? Can we like also integrate parking? Can we also integrate third-party system providers like Uber and like all the service providers? Can it be like an like in single card system, like things like that are still explored, but still the integration as such regarding the service provider and the service is still a question because of the multiple options available and very restrictive policy situations also. But this would be a more enabling system because like I mentioned, from a user point of view, it should be the consistency in the experience. How do we make these transfers invisible should be our ultimate goal. So that's how we could see the operations a part of it.
And if
Go
I
ahead,
may just add 30 seconds, one of the lessons that we have learned in Delhi, and by the way also in Pune, because we also have multimodal in Pune now, we run the Pune app. I did not know the answer before, so we built it. And we found that multimodal ticketing is not changing anything. So it's it's okay. We can experiment and we can find some experiment may not work. That's totally fine. So the reason is, according to me, the reason is that the product, so we are talking about payment for the product, but the product should be good itself. Then we pay for it. Right now, the product, multimodal product itself is not good enough that you worry about payments part, right? I mean, it's like I want to buy something first, where I have to decide to buy something first, and then I'll say, how do I buy it, right? If I don't want to buy it, you can improve how do I buy it, but I don't care. So I think the multimodality has that problem right now. Payments, of course, it helps. I'm not saying it does not help, but I think we should more worry about the product than the payment for the product right now.
So we are not yet there, is what you're saying. Okay, wonderful. So I think the next thought, or for the next maybe 10, 15 minutes, where I wanted the panel to focus on was a lot of multimodality is private sector driven, right? Public transport is, of course, government driven, but a lot of this is private sector driven. How do we go about creating this multimodal data repository, multimodal digital twin, models? Is it going to be something that the government has to take the initiative, or is it something that the private sector has to take the initiative, right? So, again, we can go in any specific order. If any of you want to go first, right, just feel free to jump in. But I'd like to hear, all your perspectives, and then, we'll open it up for questions and interactions with the audience, both in person and online. But any thoughts on how or what should be our approach towards developing the multimodal integrated digital twin?
What I feel is it can't be either or, it has to be mixed. The reason why I feel so is definitely there needs to be a top-down approach, at least from the governance point of view. Like what type of data, in which format, what could be the potential uses of it, so that governance and who is the custodian, if there is a data, like if someone is sharing the data, like what all can be done from it, so that basic governance is needed. If that is not in place, none of the private operators would prefer sharing this data. So here where from the top it can come. But in terms of implementation part of it, I would think it is the private sector who will come in with the innovation to build a solution, depending on the requirements. So if we build a system which is completely top-down driven, that maybe we will create a big centralized system which will be too tough or too cumbersome to maintain, or maybe huge amount of resources might be needed to maintain it and also to change it. So that would not be an efficient one, but if it is a modular coming from the bottom also, like depending on the use cases, private sector can come in and build in solutions. Now how to connect that can happen. So I think it's a mix, at least from the governance and that point of view, like policy, you need to share data. So that from the top, but building from the bottom, I would say.
Yes, I would now say the same. Why exactly? Actually, we are working based on priorities. What is my priority and what is government's priority? Years back or months back, we were announced, by the government that each and every vehicle should have, or taxi should have GPS. Of course, many of the vehicles are having GPS, but who is validating the data? So what is the purpose of such orders? So for the namesake, do we have some rules, and how exactly the data that is being published by the vehicle is being used? So for in my case, each and every vehicle that I use publish data location every 5 seconds. And how exactly that can be useful, and should I need to transmit or publish the same the data at the same interval to the common forum, and what is the purpose? So priority. So government's priority is safety and sustainability, right? So to achieve that, definitely we need a policy to be placed by the government, and a governance team should be there to see if everything goes as per the policy. And from the private sector's perspective, definitely, let it be Ola, Uber, Rapido, or Fast Track, Uber Cabs. All these entities are trying to prove their intelligence to give or offer very good experience to the customers. But do they have this connectivity in all the sectors? No. So definitely they will be looking for some collaboration in other sectors. For example, if I am having a cab, I will try to see if I can collaborate with someone who is good in two-wheeler transportation, something like that, or any other emerging transportation. For example, as I said earlier, why can't I collaborate with the blah blah or quick rides so that the experience becomes better, or the objectives like sustainability or other objectives are being achieved. So governance or government should have the their duty. They have to carry their duty as per their priority, and eventually when the government is playing their role, definitely the private parties will come and utilize everything, the data, and they will definitely demonstrate very good customer experience. So that will eventually happen.
Great. So work together, but the priorities are different, aligning priorities, right? So that's important. Yeah. Bessie?
Yeah, so again, I'm on page with top-down approach. I see that the top portion has a different role and the modern portion has a different role. The top portion mainly would focus on framework. That's something that we're already seeing. We've been seeing that beckon as is an example to the world. We see UPI. We see GTF as being, though it's not national, but it's been commonly used. So we see the framework in place. We see all of these frameworks are set in place, and it's more of the state to connect to these frameworks through policy and regulation. And I mean, also when we talk about private sector, I see the government sector, the government or the public sector can easily fit into the framework. But it depends on the regulation and the policy that the state designs. That depends whether the private sector can easily or seamlessly fit into the whole ecosystem directly. For example, as simple as, say, if we regulate a share auto tomorrow, now they'll have to ply on a specific route. They'll have to stop in specific stops. That might not, I mean, that's a different conversation altogether. So how well a state government frames its policy and regulation will depend on how the private sector actually connects to the whole framework. That is what I see.
Even the central government, for that matter. So from online, any thoughts on how we go about doing this? Yeah.
Can I go?
Yeah. Please.
Yeah, I think we should follow the Sarvam, the India AI mission model. I think, to be honest, I never speak, positive for the government. As an academic, we are trained to be contrarian. But I think I would say that Government of India has done a good job in promoting, new initiatives. For example, the one initiative that you and me are part of, Geeta, are the COE, smart cities, right? We have budget. I think the question is, can we think bigger? Can we actually think bigger in terms of solving problems or not? I think the question is that, and I think that's exactly where private sector would come in the picture, because government has thrown its dice. You guys have to give us a plan and we will try and execute it. I think COE is a very, very good step in that direction. Who is stopping us to, build really a fantastic citywide a digital twin for transportation, both logistics and passenger, and actually showcase the benefit, right? Not just talk about it, but showcase the benefit. So I think to me, it's more from the private sector part, more from the academic part that requires, bigger thinking. I think the government is doing quite well in terms of understanding the problems now. So that's my take. So I think it's time, Geeta, you and me and others in the room, we should own the problem.
Manish is sitting right here.
Manish?
Manish Shrestha is here as well.
Yeah. Okay, cool.
So yeah, great.
Yeah.
Thanks, Pravesh. Yeah, other thoughts, Akhila or Balakrishnan?
Yeah. Thank you, Dr. Pravesh, for giving it a bottoms up approach as well. But yeah, I think it has to be a collaborative effort, because the government can set standards, can frame policies, but the way we are going to plug in the data is highly from the private sector side, because it's not like everybody is going to listen to everything what the government says. So there has to be a collaborative effort from both parties. Because the government can frame things, but if it doesn't work out on the ground, it's a failed model. So until the private sector tells us like, this is the way the standards can be set, this is the way it's like easier for like sustainable operations, this is how it can be scaled up, can we like pilot it, like these sort of interests to the government are really going to be like eye-opening for us as well, because like maybe it's Startup Tamil Nadu or any of the new organizations, we are just waiting for ideas to come in, how to make our work easier. For example, Dr. Pravesh had also explained about the road with data and everything. That's something we've been like struggling for years. We still don't have a road inventory data. We don't know how to get it. Is doing a satellite survey, a topo survey, the only way to get it, which is like tedious. It's like labor intensive, time intensive, extremely expensive. And because the collaboration doesn't exist, often if any data is thrown or showcased, the immediate reaction is suspicion. Is this correct? Is this validated? Is it up to date? Is it like 3 years old? Oh, maybe the system of which the data was collected has to be having its limitations. So these are the sort of like hiccups we have in the process itself. No matter how new your data is, there's always a hiccup. So validation, how can we make that easier as well? Make the data collection, the updation, the validation, and the processing. Everything needs to be standardized. And for this, we will definitely need a collaborative effort. Thank you.
That's a passionate appeal. Thanks.
A very interesting thought from Ms. Akila and Dr. Pravesh and the panelists there, Gita. So the thought I'm having is for India specific, right? So it's important, we need collaboration, no doubt. But the private sector need to take the initiative, of course, if you want to really go and drive things, right? And the advantage of going through the government body is, I know there is some lot of already, if you say multimodal logistics park initiative, unified logistics, there are a lot of central data collection platform government has got. One advantage is instead of we creating by ourselves, right? Going through this existing portfolio and existing setup, it also connects different ministry. We are talking transportation ministry, but if you want to do like how it is impacting our business point of view, like a GST, right, for the freight forwarding, you need to go to a different ministry altogether. Then if you start collecting, then you need to start setting up the interface with those different ministries, right? So how you can use one centralized, how government can give us the platform so that to ease our business in a better way, so that you go through that. Maybe you need to build some interfaces through us, but the centralized way is the better going forward to make a better movement. That's what I can think of here. Thank you.
Thanks. I mean, definitely, I think there is consensus there, right? That it has to be collaborative. Maybe we should have a one-day workshop just on this topic, right? And get more players join us, right? I know Pravesh had organized one a couple of weeks back. I think we should build on the momentum. I open it up for questions and comments from the audience, both who are here in person as well as online. I think there is already one question. So Manish also has a question. Do we have more mics? Yeah. Richa, you can go on next. We can have Manish here. Okay, Manish, you can go first.
Okay, hi. So very fascinating discussion, and thank you for the panelists. So I think a few thoughts that come to my head. So this problem of data being fragmented in many places, also jurisdiction issues and who can make these decisions, I think is all very true, right? And not just in the transportation sector. I think we've seen this in across multiple sectors, and for digital to work, we need data to come together. We need all of this good things that we are talking about, AI and all, will not happen unless until we can get not just data, trusted data, right? So there are different aspects of, I think we need to be very careful about when we talk about data. I think what data are we talking about, right? And data that government needs to make decisions, regulatory decisions, they will need to back it up, and admissibility of that data is different. data that is required by private players to be able to do their business, they can take a little more risky approach to that kind of things. I think there are different types and provenance and confidence of data, and I think we should start becoming more nuanced about talking about data. So we've had some successes, right? If you look at and models, and don't think about these areas, but I think about the models. One is, of course, the UADI kind of approach where Aadhaar has come into play. Is that something that needs to be adopted at state level for road registries, etc.? So a registrar separate from the transport department in many ways, because transport department has many other functions. So no matter how much data they release, people will not necessarily trust that data. So I think separating, I keep saying there are first principles of governance. You need to separate who makes the rules, separate them from who maintains the records, who delivers the decisions, who audits, and who appeals, appellate authorities. These functions need to be fundamentally separated. Unless if you bundle them, a lot of conflict of interest comes into play and trust disappears. So I think we need to think through our governance systems very deeply, and this is for the government agencies to think about it. Second, private sector participation. I think we should look at some of the models like neutral institutions like NPCI. These are owned by public-private institutions. Look at the governance structures, how they are owned. They are neutral institutions. Like in case of course, finance, RBI is a great regulator and provides that oversight. Missing strength of regulatory institutions in this country, in many of these spaces, does not allow us to build these institutions. So unless until there is a underlying settlement between the various agencies of the government, and the backstory is, I think, of what happened before Aadhaar or UADI came into play, or what GST, how did GST Council even come to play? For the GSTN network to happen, I think there was a massive debate, go back in terms of how the various people came together, and actually there's a political settlement that happened because of which these institutions were able to allowed to exist. I think we need to be thoughtful about, this is not a technology play. Technology, we know the answers in technology. I think the underlying governance structures have to be put in place before technology can start playing the role. Then we have these missing institutions in the digital world that we need to think about, who will own data, who will interoperate data, who will enable transmission of data between various agencies, who are co-owned by public-private agencies. I think we crossed the space. I think behind us, the traditional institutions will not work for us. So I think these are institutional issues. We need to think this carefully, and these digital institutions with required capacity, capability, policy capabilities that we'll need to put together for, and which is what we are desperately missing, and many of the conversations that we are talking about, hey, it is your job, why don't you do that? It is your job, why don't you do that? And I think that's essentially what goes around between public, private, academic conversations, and I think the issue is there is a missing institution, in my view.
I think, yeah, that's perhaps something central that we should discuss as well in the workshop, right? And bring some of these other parties to the workshop so they can share their success stories, how they went about doing that. Yeah, there's an online question or a comment.
Yeah, so there is a question from Mr. Kapil. Is there any opportunity for startups in IPT GTFS hardware? Any collaboration options? And yeah, that's it. There's a one question. Yeah.
IPDG.
Yeah, IPT GTFS hardware.
Oh, IPT. So I think somebody was mentioning about IPT GTFS. You can speak. Yeah.
Check. Yeah. So yeah, I could call it a cousin to GTFS, but there is standards for IPT, more on motorbikes though. It's called IBFS. That's the standard which is predominantly used in at least a lot of operators.
So I think the role of startups, definitely there is a role, right? We do have Mintathon that we organize, and if you have startup ideas specifically related to these topics we discuss, wait for our next announcement for Mintathon, and definitely you can associate with us, right? Even otherwise, yeah, welcome to reach out, right? Whoever, Kapil or anybody else online or in person here, right? We can definitely have the conversation going. Any other questions, comments before I pass on for final thoughts?
Yeah, so one more
One more from
question is
online.
there. So why can't India work on some radical mode of transportation like failed Skybus prototype of Konkada Railway proposed by E.R. Rajaram Boji?
Okay, I think maybe that's not directly relevant to the panel discussion here, but in terms of multimodality, new modes, I think that's something that we mentioned, right? The digital infra should be open for any new modes that come up, right? But debating on a particular mode, I think that should be a different, discussion altogether. Yeah.
So one last question is there from Sridhar. How much is India ready for multimodal mobility solutions for different class of users, especially physically disabled people? So if any other insights globally on this topic, can you share?
Pravesh, yeah.
Yeah, I think it's a great question. We should talk about it. In fact, let me also phrase the question in a slightly more broader way. What about kids? What about school-going children? What about old folks? Not just differently abled, but also different age, both at the kid and a lot of our conversations are very much aligned to working folks, working class people like me and you, and who are more privileged. But I think I think Geeta, to me, the school children sector, right, which is as big as a working class sector, if not more. I think we have not done enough to promote sustainable mobility, public transport, etc., IPT, etc. And I think we are because of that we are really finishing the foundation that we have had when we were kids, right? When there were not so many cars, we could walk, right? We are finishing that whole thing. So I think I would say this is a very, very important conversation. I think it also requires one more day of workshop for kids. To me, it's a really important problem. Yeah.
Thanks. Any other thoughts from others? Okay, I think, there's one question here, yeah.
So since we're talking about multimodal mobility, my question revolves around integration of the fare. So in 2017, I think we launched NCMC cards, and then from there on we shifted to QR-based ticketing, and then I heard Ms. Akhila talking about digital wallets. So if we compare that approach with what is being practiced in Europe, they have a common mobility card which is actually being used in multiple ways to plan things as well. Where are we heading when it comes to integrating fares, and how such a fare system can be used, the data from these systems can be used back in planning as well?
Yeah, I think the financial thing, there was a question earlier, and Pravesh mentioned that let's get the technology, the multimodality worked first before we get to payments, right? But is there any quick points or thoughts from anybody? Yeah, Avinash, yes.
So I think this is one of the most important points. So whenever we talk about multimodal integration, that integration could be the specifically three things. We are talking about physical, we are talking about operational, and then the financial integration. So this financial integration is really needed, I would say, because the moment when we talk about like the journeys, multimodal journeys, or whatever the journeys, one of the challenges is, so say for example, this is based on our work that we did in one of the cities, is like when you plan your bus network, organically it is point to point, like how the system developed over the years from every point to every point. But this is not an efficient. The efficient way is the directional network, where there are directionalities. If I want to go from here to there, there could be a trunk route, there could be multiple feeder routes. But eventually what happens is, say for example, if my A to B distance is say 6 kilometers, but now if I'm breaking it in this thing, and the minimum fare is related to every 5 kilometers, so I'm paying more. So the moment this happens, my this multimodality will break. So this financial integration is really important. It could be done via NCMC or any other thing, the digital wallets or anything. but it is a very important point to consider when we are planning or when we are doing it, because then it would be the multimodal integration will be good on papers but not on ground. So that's important.
Definitely, it's a key part. Yeah, Pravesh.
Just a quick thought. So, in Western world, which the question had was mentioning, right? There's a single fare, where you go from A to B. The integration is very easy here, right? Now, if you suggest a single fare approach to our bus companies, they won't ever agree. I think that is one of the problem with NCMC card-based usage also. That then you need a separate hardware. There is no single fare, right? You just don't tap in and tap out. So I think that is a crucial nuisance. I guess detail that we miss out many times. Just to add a thought.
Great. So I think we are out of time, right? If there are 2 or 3 words conclusion that anybody wants to make, right? In 2-3 words, if you would like to say something, we'll conclude with that.
Geeta, one final question.
Yeah, we'll start with online
Geeta,
maybe.
Geeta, do you have time for final question?
I think we are out of time, right? We can take it during lunch. Yeah, final word, literally word, not even words. We'll start online. Akila, Pravesh. Akila, go ahead.
Yeah, I'll go ahead. I think the main word I would say is like scalability. Any solution we are planning in terms of digital integration, physical integration, needs standards which can be upscaled. I think that's the foundation. Foundation is my word.
Scalable foundation. Pravesh.
I think I would say ambition and really thinking for the people in an ambitious way. Those are my final 3 words.
Mobility dreams for $1 billion. That's MINT's slogan. Great. Avinash.
For me, I think it needs to be inclusive. We should not be leaving out any section, any particular this thing. So
inclusive. Mari Anthony.
Yeah. It should be an open forum or wherein a proper framework is formed so that the data can be shared and validated. Otherwise, this will become an expensive dashboard other than a digital twins. So
Okay, open framework.
Yes.
Bessie.
Right, for me, to build a DT for multimodal in our context, I think our first focus should not be on the technology nor the standards, rather institutional integration. So that's the base that we need to start from.
Institutional integration. So I think that was a fascinating panel discussion, right? A lot of points. I have several notes that I myself have taken. Definitely have the following workshop. We do have 2 more panel discussions today afternoon and 1 tomorrow. And I think some of those will address a few points that have come up in this discussion. Thank you all, for being a wonderful audience and throwing up interesting thoughts as well. Thanks to the panel. Of course, Balakrishnan had to drop off because of another engagement. But thanks everyone for joining in. We'll continue this conversation, right, with the workshop. We'll plan, shortly. Thank you so much for joining in. Over to Soumya.
Yeah, I know you already asked them for 1 keyword each, but I'll also like to add a couple of keywords that I heard. Ownership from Pravesh. He said we should take the ownership. Private sector should take the ownership. And I think open data frameworks and enablement from the public sector that Ms. Akila talked about. It's been a fabulous round of discussion. Let's round it off with a round of applause to this panel too. It is special that we have Manish here adding and underscoring the points, right? Absolutely on the front lines of execution. I was a little worried that we were running behind schedule, but I think we've made up. And so we've got 45 minutes for lunch. We will regroup at 2 p.m. We'll walk to the faculty lounge, please. Thank you to the virtual participants. It was fabulous to have you all. And the questions. Keep them coming post 2 p.m. Thank you. Yes, let's honor the panelists. Yes. we go slim on. Anything else?
So the lunch, sorry we couldn't organize here because there's renovation happening. It is just across the road, right? We'll have to walk over there. Our volunteers are at the front. They'll, once you assemble there, we'll walk over. It's just a 2-3 minute walk, right? We'll walk in appetite.
Yeah. And you know how to spot our volunteers, right?
don't know. I've asked them to check. So who's online? Is Professor Raj Lakshmi and Professor Archak online? Okay, and what about Professor Raj Lakshmi? Can somebody message her? Geeta, do you have Raj Lakshmi or? I have the number. I do. She's in the panel, right? Because I didn't see her number here. All right. So we have time from what time to what time? We have an hour. We have 1 hour. We have 60 minutes, is it? Yeah. Let's get started. We have a lot to go.
Are we ready to start?
Yes.
Okay. Raj Lakshmi இல்லையா? தெரிஞ்சு இல்ல.
She will be online, sir.
Is she online? Is it connected so we can ask the question? I don't see her name here.
Hello? I'm not able to identify your name. Sign in pass, please. நான் பண்ணி பார்த்தா அனுப்பவா?
Is there another? Is Professor Raj Lakshmi online?
Okay, just she
You
is.
found her.
Can you make her the co-host?
Can you make?
Already.
He
Okay,
already
thank
is
you.
a co-host.
Thank you. Okay,
All right.
Professor. Thank you.
Okay, perfect. All right. Yeah.
Okay, we'll start.
Abhinandan. After you finished, please, I want around 5 minutes, 5 thing, you need your power bank again.
No, sure. No.
But on the lightning, is it coming? Huh? Perfect.
My phone doesn't last, sir.
No, it's like I did so much going on.
Good afternoon, everybody. Apologies for the delay. We're getting started now on panel 3, Foundation Models for Autonomous Next Generation Mobility. Everyone's talking about generative AI writing essays, but what happens when you train AI to navigate the streets of Mumbai, Chennai, or Bengaluru? Welcome to the world of foundation models for autonomous mobility. led by Professor Ramakrishna Srinivasan. We have pioneers from Virya, Ashok Leyland, IIT Bombay, and IIT Hyderabad. We're moving past standard large language models to large spatial and physical models. They'll argue why India needs its own open source autonomous stack to tackle our unique road realities and much more. Over to Professor and to the panel. Welcome, everybody.
Good afternoon. Sabha and Alok, please come to the stage. Excellent. So I believe online we have Professor Rajalakshmi from IIT Hyderabad. Yes, hi. And I believe, can you hear us, Professor? Yes, I think she can hear us.
Yes,
Right.
yes, I can.
Perfect.
Am I audible?
Yes,
Yeah.
you are audible. Wonderful. And Professor Archak Mittal from IIT Bombay will be joining shortly. And when he joins, he will also come on to the panel, okay? So this is so exciting to have some of India's leading experts in this space who have been thinking about some of these problems. And we are going to have a very interactive and interesting discussion, right? So I'm going to kind of cut to the start of it because we lost already some time, right? The first order of business is going to be on exploring what is foundational models, right? So on one hand, you have LLMs. On another hand, you have physical AI. So I'm going to first turn to Sabha and ask him, in his mind, what is that distinction and how does it all fit in the context of autonomous vehicles? Yeah. Okay. Yes.
All right. Firstly, great to be here. And hi, Raji ma'am. Nice to meet you again. It's been a while. And hello, everyone.
Hi.
So, interesting space and time because the world's been taken by storm with this whole LLM wave, right, in the last how many ever years we want to look at it. But I'll lay out a couple of distinctions in my head, how I look at LLMs versus what physical AI is. And I think that's the crux of what we're talking about. One is, we're no longer talking about text and tokens, right? We will have to break out of that. We're talking now physics, we're talking sort of motion, we're talking understanding of environments under constraints. So fundamental difference, physical AI, of course the word says physical, right? But every action has a consequence here that we have to be extremely mindful of. This is one. Two, once we understand the fundamental difference between these, right? Text, token, statistically trained versus, actual physics, actions and outcomes that are perceivable in the real world. The second part is about how we look at failures, right? Like we talk about hallucination a lot today, right? LLMs hallucinate, there's a wrong response, there's a certain, understanding, sure, that's done, but if something in the physical world decides to fail, we all know what the consequences can be, right? So we'll have to look at it with that lens. Then the third comes, okay, how do these models even, or how do these systems even, evolve, or how do we look at them to grow, become more intelligent, right? LLMs typically are trained based on large-scale data of a certain form. You throw anything and everything at it. Of course, you still curate it. You still sort of have a lot of cleanup you do before you start training an LLM. But what it means to train and what it means to put together data for physical AI is very different, right? And we'll talk about that in detail today through this session. But there's also a significant aspect of the dimension of simulation, which we heard some people talk about, and of course the fundamental idea of digital twins, what we learn from it. All of this will start coming into the picture as we think about training for physical AI, right? So that's sort of the third part from my perspective. And of course, there's an interesting convergence that's happening today. We used to hear about LLMs. Of course, you now hear about vision language action models. You talk about end-to-end models a certain way. But for all you know, maybe what we'll end up building is a large driving model sometime, right? So that's just a thought I want to leave with as we dive into the conversation today.
Wonderful. Thank you. Thank you, Sabha, for building that distinction. I'm going to request Professor Lakshmi, anything add? I mean, you've been doing this at IIT Hyderabad for a while. So in this context of the distinction, anything to add to what Sabha was just talking about?
Yeah, I think Sabha explained very well. But, let me just say something like LLMs, they are kind of generalized models, as already he pointed out. They are large-scale AI-trained models. Yes, of course, when we talk about autonomous vehicles, the mobility, what is that we are actually looking at? Are we just looking at LLM? No, actually, it is something beyond LLM, above LLM. So that is what we call as VLA, vision language action models, right? Because if you see LLMs, input is text, language, output is as well the same. Whereas in the case of autonomous vehicles, autonomous mobility, the LLM has a translation, where the mobility is involved. We give input as multi-sensor inputs, language, prompt, text, speech, whatever it is. But the outcome is also action. We need steering, brake, control actions as well. So that there comes actually a kind of distinction when we talk about LLMs or the foundation models for autonomous vehicles. So there is a translation from simple LLM like ChatGPT to what we call as COBLA models or EMMA models, which are actually the VLA models which are used in autonomous vehicles. So that is one of the important distinctions as when we talk about foundation models for autonomous vehicles.
Wonderful, wonderful. Now that the context is kind of clear, we are talking about how do we build out this type of vision models, and operate in the physical space, right? Where we have sensing, perception, and actually controls, right? All of them coming together. I'm going to switch a little bit to a different topic, and we'll come back because we're going to explore all of these things a bit more, right? So when you think about autonomous vehicles, you obviously, the biggest things that you hear about is Tesla's autonomous vehicles. You hear about the autonomous vehicles running around the streets of San Francisco and Austin. So when you look at a context like India, okay, what are the use cases? What are we actually talking about? Why are we talking about autonomous vehicles when you have the perceived problems of congestion and so on, right? So I'm going to turn to Mr. Alok from Ashok Leyland. And I'm going to put that out to you as as an automobile manufacturer, as well as somebody who's thinking of strategic issues. What is your view of where does this all fit in?
No, I think when I look at autonomous, it goes beyond just the driving abilities. I think it will be on the shop floor in terms of the operations. It will be on the fleet management side. It will be, I think, so there are several areas where I think the multimodal input will be critical. So one is, I think, but coming back to your question in terms of use cases, so whether it's the camera, whether it is the sensors, whether it's the ECUs, whether it's the CAN devices, if you really see, and I think it goes back the earlier definition of analytics, where I think you need to have these kind of models, is where you have the 3 V's. You have the velocity, the volume, you have the velocity, and you have the variety. So the volumes, when you talk about the volumes, the kind of data that is being generated by our automotive, whether it's car or commercial vehicles, is a very different kind of order of magnitude. A connected truck or connected car could be generating upwards of 25 GB per day. It could be 200 GB per day, depending on the level of connectedness. If you're talking about L4, L5, then it will actually go beyond into terabytes as well.
So that's, I think, on the volume front, that's really, really significant. And each of this, you can break it down. The ECU will probably be 25 GB per hour by some estimates and stuff like that. And depending on the frequency at which you kind of get this data. Same thing is in terms of the variety, right? You're talking about different sensor inputs. You're talking about camera. You're talking about radar. You could be talking about, obviously, the vehicle sensors in terms of ECUs and VCUs from the drivetrain. So you have those kind of variety coming in as well. Velocity also coming in terms of, if the camera we take it, then camera will have, let's say, 30 to 60 frames per second. Same thing will be on the CAN devices, will be somewhere around 100 signals per second. So the order of magnitude is very, very high. And I think these are the data sets that will require a foundational model. Coming to the use cases, I think there's a lot of use cases in terms of where the safety becomes very critical. So the reaction time is very minimal in terms of when you are, let's say, on the highway and you're speeding and the person in front of you brakes, right? So these are one of the first applications which are coming in. The AEBS is coming in as a mandatory feature, FY 27, 28. So these are the things that are coming in. There is a other driver drowsiness is coming in. There is a lane adherence that functionality is coming in. So I think these are the things that are really on the safety side. So this is really front and center. We're not talking about, let's say, autonomous vehicles to start with. Now that's a very long way off, but I think if we are able to improve the productivity of the drivers, if we can improve the safety, I think that will be the industry focus to start with. Would be my, I think, limited.
Yes. So you are talking about the evolution of individual autonomous technologies that can make driving more safe. It doesn't necessarily mean fully autonomous, right?
No, absolutely, absolutely. But there would be use cases. Coming to the use cases where it can be accelerated. So we ourselves have a prototype for unmanned ground vehicle. Now the defense might be a accelerated use case in terms of our, we have a fairly, I think, expansive kind of borders pan-India. So on the north, you can deploy some of these vehicles. So that, I think, will require use cases that can be adopted earlier. Then there are other closed loop use cases, maybe the tarmac vehicles that are at the airports. They go through a well-defined route and stuff like that. So there could be things of that nature that could come into play. So I think those specific use cases can come in earlier in terms of maybe a not full autonomy, but partial autonomy for that matter.
Okay, perfect, I understand. So I'm going to actually kind of ask a provoking question to Sabha. So Virya and the MINT group has been in the automation business for a long time. I'm sure you see cases for autonomous vehicles in this realm of automation, especially industrial automation. Can you please kind of talk a little bit about that, because I think that will give us a more concrete view of all the types of problems we need to be working on.
Okay. So when we started Virya, right, 2023, one of the first pilots we did, and of course we were looking at two major streams. One was mobility, autonomous mobility for material handling, because that's where the legacy of the group was, right? And the second part was what can we do in the people mobility space. And we were fortunate to partner with Bangalore International Airport, and we did a 7-month pilot where we ran an autonomous buggy inside the airport terminal, picking up people from the gates, dropping them at baggage claim, picking them up at baggage claim, dropping them, let's say, in the parking lots, right? Tremendous learning, but also opened up our eyes quite a bit on what a lot more needs to be done, right? So I'll break my response into two parts. One is where is the clear opportunity versus where there's a lot more that needs to be done and why it's relevant. So in parallel, we started doing material handling trials in factories. We started building robots that can go to factories, move material inside these factories. And we very quickly realized that there's an absolute clear need for safe, repeatable mobility inside factories where there's a lot of material to be moved. And today, the dependency on human labor for that is just not working out great for any automotive manufacturer for two reasons. One, It's not about workforce elimination. Nobody's looking to eliminate workforce, but they want consistent workforce that can actually do more skilled jobs, right? So there was a gap there in how material is being moved where we could solve that with robots. The second was there were clear safety use cases, like Alok rightly pointed out, where introducing robots for material handling right away reduced the risk of accidents in certain operations and use cases. So to summarize this, I think any controlled environment where safety is something of relevance, I think we can right away go ahead and say it's something we should prioritize and go solve with autonomous mobility. And there are plenty of such use cases today in India, right? Now, coming to sort of certain environments where we've had mixed sort of understanding of the situations and we're still seeing things pick up is campus mobility, right? And that again is an area where, and I'm sure Professor Rajalakshmi can talk a lot more about how an autonomous buggy is perceived in the campus setting. But we realize that people mobility, right, is a highly unstructured sort of autonomy problem. Even in a campus, as much as you want to think about a campus being a very controlled environment, the actors, the diversity in the environment, the challenges is all fairly unstructured, right? So these are again areas where today it may appear to be easier to do it with a human operator, but there is going to be a time where as we scale and grow, autonomy can just be more consistent. And the intent to do these in people mobility today in campuses is not so much about trying to solve that as a problem, but I think what we learn by doing this today, we anticipate that helping us solve larger macro problems and last mile mobility even at a city level. And Manish and I were just talking about this over lunch as well today, right? So hopefully that gives you some flavor on how we are looking at autonomy.
Right. So, so in this world of autonomous vehicles, I think clearly this discussion has talked about how do we deploy autonomous technologies on one side to kind of improve the safety on the roads, right? And then, of course, looking at environments where safety is a big use case, but also where where there's an opportunity to kind of deploy real autonomous vehicles is also there. It's not that they are kind of shut down, right? So I think all we need to do is explore those dimensions in terms of where we use it, right? My question is going to shift a little bit so that we can discuss a bit about technology options, right? When you look at the type of models, foundational models, there are so many that are already out there in the Western context or the Chinese context. They're all available. Now, if I say, okay, what is, the question would be, do we build or adopt? Okay, as a nation, and I think there's going to be a panel discussion right after this on sovereign kind of mobility kind of solutions. So how do we as a panel of experts look at the deployment of technology or adoption of technology? What are the thoughts in terms of build or adopt, right? So I'm going to kind of turn to Professor Raj Lakshmi since you've already kind of been doing something in your campus. I'm sure you've kind of thought about this question. So maybe you can start by giving your thoughts on this, and then we can also hear from Sabha as well as from a strategic perspective from Mr. Alok.
Yeah, thank you. So this is an interesting question, whether we build from the scratch or adopt the technology, whether we want to leapfrog or, start from the scratch. How much time we are going to lose by doing this, because we are living in a, era where the technology is changing every 6 months, right? I mean, so it's a very good question that we should address. Let me just again start, because you started with Tesla. What is that conventional model of autonomous vehicle, or the architecture that the AI model or the deep learning models that were used, or otherwise, generally what is the conventional AV, autonomous vehicle architecture? It's, there is going to be a perception where multiple sensors are there. Then we are going to have, I would say, otherwise I will say sensor fusion, perception, path planning, and control algorithms. Like kind of, 4 static modules, which are, built or stitched together to put an end-to-end system of autonomous vehicles. Whereas when we talk about foundation model, which is actually the next generation autonomous vehicle model that we are talking about today, it's no more going to be individual submodules. We are going to talk about end-to-end driving. That is most important thing that we should look at. Now I am not going to optimize each of these subsystems. I'm actually looking at end-to-end optimization. So here actually I'm talking about one single AI model. That's where we are talking about large language LLMs or large AI models, which are trained on huge data set, and it should be so generalized. Okay, so when we are talking about that, so already such kind of models have been proposed, are well established, are being utilized for different applications in the globally, right? I mean, for different applications, there are multiple such models that are existing. So when we are actually going to adopt such models for autonomous vehicle optimization, what are the things that we need to consider is first thing that we actually look at. Because if I want to talk about a foundation model, a large language model, or I would say a VLA model for autonomous vehicle, what are the aspects that I have to bring into picture? What are the kind of data set I have to build in so that, it is end-to-end trained? Because as Sir from Ashok Leyland also pointed out, driver monitoring system, the standards are also getting getting enforced in some of the countries, or in India itself, AIS standard is also being rolled out. Drafts are already out. So my ALM should also comply to the standard, right? So the architecture, more than looking into, I would say, the building from the scratch, what are the features that we need to integrate into the LLM so that it is well optimized for a generalized autonomous vehicle is something, the most important research that we should actually look at. And that will actually come up with the optimization in generalized large language model for autonomous vehicles.
All right, Sabah?
A couple of thoughts, right? One, in a very ideal world, I'd say we should just build, and I'll iterate on, and I'll probably highlight why, right? One is, if I were to broadly break this into 2 types of problems we're trying to solve, there's structured autonomy, which we've seen, I would call even what's happening in the West, where there's a lot more emphasis and enforcement on the rules of the road and driver behavior, right? We can treat that to some extent as structured autonomy, with the edge cases and the long tail being unstructured, right? Waymo, if they solve for 90% of things a certain way, the last 10%, of course, they're dealing with the unstructured part. I think what we're trying to do in India is solve for an environment and a condition where it's predominantly unstructured, right? And then the tail is even more unstructured, right? So if I look at it that way, like Professor Rajlakshmi said, absolutely, we need to cherry pick whatever we can and leapfrog. We shouldn't be wasting our time reinventing something that we truly understand from what the state of the art is. But there's got to be a fundamental sort of understanding at day zero that the kind of environments, the actors, the sort of threats, however we want to call all of these interactions that are dynamic to this vehicle platform or this driving model that we're building, we have to look at it from that perspective. I'll just leave with one example. Most, of course, open source as well as closed models that are today used in autonomous driving, any of the end-to-end early deployments or whatever they've been trained on, they're all based on cars being the primary actors on the road, and then pedestrians or VRUs, as we want to call it, right? Vulnerable road users being the second part, and this is how classical systems are built, right? Motorcycles and two-wheelers are not really in the mix as much as if you look at the amount of training data that's gone in on cars, and it's exactly the opposite in India, right? And if you're fundamentally starting with something that was built for a different use case, and we try to adapt it, we'll lose a lot of time trying to adapt it. So we'll have to take a hybrid approach. We'll have to see what makes sense to cherry pick, but wherever we can build some of these fundamentals right, especially how do we define training data, how do we define the outcomes and the metrics around it, should be things we do with the context of India and in India.
All right. Yes, perfect. I've learned in this last 2 minutes quite a bit from Professor Rajlakshmi as well as from USABA, and we'll have to probe some of those questions shortly. Okay, Alok?
See, again, in a lighter vein, if India was ahead in terms of maybe autonomy, autonomous vehicles, then I think the world could just follow, right? Because of the unstructured kind of use cases, the corner cases, right? There are so many of those in India that I think you didn't need to make the system learn anywhere else. It would have been adaptable for the globe. That's more in the lighter vein, but I think more seriously, I think when I have actually seen even Google Maps telling you to go against the traffic. Now just imagine if your autonomous system is using a logic which is saying, okay, all right, I'll go by the map, I'll go by this is the way I'll go, because Google Maps has actually seen the vehicle going in the opposite direction. So it somehow, I think, has been tricked into believing. So I've seen, I think these are more like odd occurrences, but these are kind of corner cases, extreme cases. So that's, I think, one element. So I think you'll have to see the Indian context for sure. You can definitely, I think I agree with the hybrid approach in terms of you go with, let's say, whatever the Western models are there, but I think you'll have to tailor it to the Indian context. And also, from an India standpoint, look at which are the use cases which are more relevant. So the closed loop cases, maybe on the defense side. So these are the things that probably are much more from a priority standpoint, right? The safety use cases, those are really use cases which are really relevant from an India context standpoint. So I would say that, yes, you can pick up your, let's say, the foundational models, but then tailor it to the India kind of use cases which are much more really urgent use cases for India. So that would be there. See, one is, I think globally you have driver shortages. You have driver skill challenges. So anything that actually improves that, not eliminate that. So it's more in terms of supporting the human in the loop. So that, to my mind, will be really the focus from an India perspective. If you go about designing, let's say, autonomous vehicles on Indian roads to start with, I think that will probably not be the right way to go about it. It will be those use cases where I think there is a real need, whether it's the use cases on defense or the closed loop cases. Yeah.
Right.
It could be mining. It could be mining kind of those going through those difficult terrains and stuff like that. So again, on the safety side, yeah.
So a lot has been thrown open in these comments. I think I'm going to, again, circle back to Professor Rajlakshmi. I think you made the case for the end-to-end kind of thought process in designing. Now, which kind of makes sense when you kind of attach it to the thought process about specific use cases. For instance, when you look at, as Alok just talked about, mining or a very controlled operation, we don't need to kind of reinvent how that might work compared to what happens in Australia or in China. Okay. However, the question becomes whether we would have to kind of make sure there is a level of learning that has to go into those models where you have India-specific elements that are coming in, whether it is road signages, whether it is how you have driving standards. Okay, what are the thoughts? I mean, like, we haven't yet put out in India an open source or a stack or something akin to what might be what NVIDIA, for instance, has done for others to use, right? So when you think about it from that perspective, how would you kind of talk about the need for something that is unique to India and putting it out as an operating system or an autonomous foundational model?
Yeah, so I think the most important thing is, as we have been talking about, India specific. So when it comes to autonomous vehicle, the scenarios are very important. It's just not the driving data I collect. and I just train it. It's just not the detection of a pedestrian or a vulnerable user, but the complete scenario. That's the most important thing. Like, am I going to, when I talk about end-to-end model, now the vehicle should predict. That is the most important thing. The trajectory should be predicted. When as a driver, a human driver, depending upon the other actors in the road, takes a call whether I have to overtake or slow down, depending on everything that I see in the scenario, right? So that is what a foundation model has to do. So it is just not the detection, but scenario understanding, first thing. So when I talk about scenario understanding, what are those scenarios? So that means I should be able to come up with a class of scenarios that my foundation model should be actually trained, right? That is most important. So that is where the entire crux is. So what are the number of, scenarios? So we can broadly say all weather condition, or light conditions. These are certain things, okay? But what are those scenarios? The scenarios are very, very important and critical when I'm talking about foundation model generation. So if I identify the scenarios, is it 10 scenario, 50 scenario, 100 scenarios, which is going to encompass a human-like thinking, perception like a human in the autonomous vehicle, then we are successful building the autonomous vehicle, which is, generalized model. So that is the most crux of it. And we have identified from our research, at least 160 scenarios that the driving data should be classified. Okay, so these 160 scenarios, huge amount of data have to be collected pertaining to these 160 scenarios first. But when I'm actually driving on the road, am I sure that I'm going to capture all these 160 scenarios? Surely not. Even if because there are many corner cases which may not actually happen when I'm actually driving. Even if you drive lakhs of kilometers, the opportunity or the class imbalance always exists because of the corner case or the existence of such kind of scenarios in this environment. So that is where the data generation, synthetic data generation, generative AI techniques also come into picture. So I should actually come up with a statistical model of how to generate that kind of scenarios so that I'm able to actually come up with all these 160 plus scenarios in my data set. I am able to train my LLM model or VLA model with this data set. And then this model is going to behave like a human in the road, right? That is actually the requirement in terms of technology. And if we are able to successfully do it, I think then our autonomous vehicle can work both in the urban scenario, in the controlled environment, non-controlled environment, everywhere. The most important thing is we lack these 160 scenarios, how to get the data, how to train the, the LLM model with this kind of scenarios. That is actually the catch, I would say, for the LLMs to be, or the VLAs to be more generalized in terms of autonomous vehicle.
Perfect, perfect. So I think this has brought out the need for something unique to India, because there are definitely scenarios and use cases and information that is unique. So we do need to work on that. Very curious about the 160. We will definitely have a lot of conversations around that. Okay, that kind of leads us to the next part. The very first element of autonomous, technologies is sensing. Okay, without a sensor, you don't have a data, right? Now, when you look at the sensors, I mean, there's lots of thought process on whether you use LiDAR-based assessments or use camera-based assessments. I want to first, just from a technology options perspective, just quickly kind of probe that before going on to some more discussions on the sensors themselves, right? So are there any thoughts? There's this huge debate going on. So, I'm going to turn to you, Sava. You've spent time in the West as well as here. Where does your mind say we should go?
This is interesting because literally before this panel started, I spent about 30 minutes with Amit talking about scenarios and how scenarios will actually drive the technology and the modalities we need to then, help pick sensors. So it's great to see everything come together of sorts, right? So my first answer is going to be, there's enough variety in sensing technology today, right? Like in the end of the day, physics has helped us come up with all possible ways of detecting something, coming at things. But as we look at it in the context of the conversation today, it's first important to understand what are we sensing, and more importantly, why are we sensing, right? And once we get to the what and the why of the sensing part, right, that then helps us pick the right sensing technology that would be the most robust sensing approach for that scenario, right? In fact, we shouldn't look at sensing for obstacles per se, we should look at sensing for scenarios, because we're trying to make sense of the world around us as well as, few of the actors in that world, right? So with that broad context, getting into the technologies specifically, the most common debate in almost every panel, especially when 4 or 5 years ago, was, well, Tesla's doing everything with vision, why do we need other sensors, right? Well, humans can see, why do we need other sensors? So I want to take a bit of a strong stance here and say, it's okay to appreciate the beauty of physics and the different modalities we have, and hence look at different sensing technologies depending on where it makes the most sense. We don't have to force ourselves to use vision all the time and say vision's the only answer. I think today, well, if we were to quickly go down the list, right, we talk about anything that uses light in any of the spectrum, right? So we look at LiDARs. LiDARs clearly have enough proven sort of advantages and benefits over pure vision-based systems. Then when we get into the vision spectrum, of course, the era of just classical vision and then optical flow and whatnot versus now looking at purely time-of-flight cameras, right? Is sort of getting to that hybrid point in many ways. And then you have spectrums and frequencies through which you can see and interpret the environment very differently from what you can do with vision. And there's enough proven in the whole sort of ADAS world as well on what benefits radars bring to the table. So I'm all for a multi-sensing approach at any given point of time. And thankfully, the tech in each of these sensing domains has improved so much in the last few years that not everything is very price or cost prohibitive today, right? And of course, research will continue on that front. So the approach should always be multimodal, and redundancy is always great in this space. So I'll leave you with that thought.
Wonderful, wonderful. Okay, so you kind of laid out the case, okay, saying, all right, so we need all types of sensors. The very next question then we have to answer is, where are we getting these sensors from, right? When you look at the world of sensors right now, is dominated predominantly from, say, countries like China and to some extent the West, right? So what, I'm going to throw this out open to Alok. Okay. How is the automotive or even the beyond automotive, how is the industrial complex in India kind of taking on the challenge of developing sensors? Are you seeing that? Is that a strategic question being asked in your boardroom?
See, from an India perspective, we had the rare earth challenge, just trying to see a parallel there in terms of wherein the rare earth magnets were kind of constrained because of China supply chain being very, very dominant, right? So we saw the industry kind of at least start to look at rare earth free magnets and stuff like that. On the sensors front, I think still early days. I think there's a lot of import happening. Lots, I think when we look at cameras, and there are very few options there. In fact, when you look at motors, again, there are very few options. So, but the work is on. And I think, I don't know if there are any startups represented here. Startups are doing some good work, at least making some initial kind of foray in those. But still early days, I would say. But I think because of the China Plus One, I think the world is looking at India enhancing its kind of footprint in some of these areas where it has not been there traditionally. So one would see, I think 5 years from now, I think one would really hope that, I think that ecosystem is getting developed. We as OEMs always on the lookout for localization, looking at how you can actually de-risk your supply chains. So I think that's pretty much, I think, very high on our priorities. So for example, I think wherever we had exposure to China, we had tried to see whether I think there is a local source, or I think we can de-risk that supply chain through maybe even better relationships with our counterparts there, or let's say look at other technologies as well. So I think this is very part and parcel of an OEM DNA in terms of looking at how you can de-risk. But some of these questions are much wider than just an automotive question, right? Because for getting a sensor manufacturing in India, it will require, I think, multiple of mega trends, right? One of the mega trends definitely is the geopolitics right now that is happening, right? Capability is there in India. So I think then there should be sweeteners like the PLI scheme of the government. So that comes into play. So there are 3-4 multiple mega trends which will make this happen. And I'm confident, I think we will move in that direction, but long way to go.
Right. So the ecosystem to evolve, right, requires some incentives and some policy structures, as you kind of rightly pointed out. Now, maybe, and that is not a road that will kind of, start and end tomorrow. You're not going to have that sensor, those options readily available, right? So how do we make progress in the meantime? So we have all of these, I mean, recently we had this scare in Delhi where, we had e-rickshaws being turned off, right, on the road. So how do we kind of set up in terms of our compliance and regulatory frameworks in terms of what is allowed to operate and what is not allowed to operate? I want to kind of probe that from a perspective of what is the what are the standards and what are the mechanisms that we have to put in place so that we get the right technologies that are allowed into the system here in India.
No, I think as you go forward, I think because of these sensors, because of these technologies, the vehicle is becoming a software-driven vehicle, right? So that means the cybersecurity, all these elements become very, very important. And I think the standards will have to keep pace with maybe with the technology. I think that's really critical because it can be abused. You can actually have, let's say, maybe agents who can manipulate, as you rightly said, switching off the batteries and creating havoc. It can even, I think 5 years from now, a lot of more cars will be software driven. So that means you can actually create, I think, some scare on the highways as well. So I think standards will have to keep pace. It will also, I think, and I think we were talking about the technology stack, the hybrid technology stack. While we are, I think, to accelerate, hybrid technology stack is good, but we should have a complete kind of a view in terms of no black box within that technology stack. Because typically when we have adopted technologies in the past, sometimes there are areas of, let's say, we don't know what it is, right? Now that is something that we can't deal with, right? Definitely on the defense side, but even on the civilian side. So I think that's where I think we have to really progress as a country, as an industry as well. But what the government has done, interestingly, is they have taken a graded approach. When they came out with the PLI scheme for across sectors or different for industries, they said, okay, they don't say that let's shut down everything from day one. They'll say, okay, you can import, but the value add starts to happen in India. You can start with assembly, then you go to the next level of value add. So it gives a glide path for the industry to really step up. And that's the way to do it. Otherwise, people will say, okay, this is just assembling technology, is nothing really great. Right? That's what people said about the mobile ecosystem. When Apple came to India, I think they didn't come alone. Foxconn, for example. They came with hundreds of their suppliers. Our government actually hosted them. I think they had Invest India as a setup which actually hosted them. So then the entire ecosystem looking at India saying, okay, can I set up a base? Now that is the level of, I think, a change needed to make sure that the ecosystem starts to develop and we put in those policies in place.
Thank you. I think that was an amazing exposition of where we should be heading towards, right? But this also brings us back to the question, as we build out an India-specific kind of foundational models, right? And then it has to be matched up with a India-specific or a sensor set that is something that we can envision as being available here. And maybe there is a set of standards in terms of input-output that we actually define. So any thoughts on that? I mean, Sabha, you're doing this day to day. when you look at the evolution path, how do we kind of think towards what might be the sensor set, and how do we kind of look at specifications so that we are able to match towards that kind of trajectory of how technology will move?
So, I guess two thoughts on that. One, once we have a full understanding of the scenarios, what we're doing, and of course we define the unstructured part of autonomy really well, right? Sensing technologies to scale have to be very cost effective, right? So we'll have to absolutely play that right from day one. It's great to build one autonomous pilot with 5 LiDARs and 4 cameras, everything, right? Like great learning, extremely important. But also once you go down that path, you're then always trying to cut something, and then there's always a trade-off. You're always trying to see what did I give up to get what, right? The opportunity we have today as we talk about foundational models, what we're doing, and whether it's a hybrid approach or however we converge, right, is we also get to take a hard stance on what our constraints are for today as well as for 2 years, 3 years down the line in terms of cost, in terms of scalability, and then build the models with that assumption baked in right from day one, right? And I think that's really what we should be doing, right? This is one thought on the how we approach, how we see this scale. In terms of sensing technology itself, and of course we heard from Alok as well, it's a little too early right now to talk about what's happening in India maybe. But even if you look at this globally, right, certain sensing technologies have just been fairly monopolized. Like we talk about 2 or 3 LiDAR partners in China, a couple in the West, right? And clearly they are handling 80-90% of the market, right? Sure, there's the 10% with other LiDAR makers in China, but not at the same yield rates, not at the same sustainable business approach, right? There's a lot of opportunity for fundamental research in India today to look at why these failed, why they've been successful, and again, leapfrog. We've been great at leapfrogging, and I think we should start thinking about how do we leapfrog in specifically sensing technology, right? And so that's just another direction that we should pursue across both academia and the industry to see if that's something we can spend a little time on, right? I'm sure a lot of you have heard about like recent announcements from some LiDAR makers, right? Like today, Ouster has a LiDAR that gives you the point cloud, but also literally gives you a sort of full color RGB image that comes off it, right? Imagine the possibilities of now interpreting the scene a lot differently than what you used to do as just a point cloud, right? So there's a lot of convergence in what is expected out of a sensor as well, right? And it's a very unique opportunity for us to think about it, revisit these things fundamentally and say, can we do something different?
Wonderful, wonderful. So there are opportunities for foundational research to happen as well. So I'm going to turn a bit to Professor Raj Lakshmi, right? So to do all of this work, whether it is, looking from the software side, training models and or from fundamental research on sensors, do we have the talent in India? How is the talent being developed, and what is our sense of this current state, right? And is enough effort being put together to actually do all of this, right? The types of engineers, people who understand all of this.
Yeah, I think it's an excellent question. But I think I want to also address the cost perspective, when we talked about the cost and the sensor technology, I would say that is a bottleneck which we are talking about a conventional autonomous vehicle architecture. But, the cost we are going to pay when we are talking about the foundation model, that's going to be more in compute as well. That is again the biggest challenge that we need to address. When I'm actually going to integrate a foundation model in an autonomous vehicle in the real time, accuracy is going to depend upon the compute that I'm going to integrate. Because, at this point of time, conventional, traditional architectures can work on a simple Orin Nano itself. with simple sensor perception model. But when we are talking of perception from or an LLM or a foundation model driven autonomous vehicle, it's not going to work with simple Orin boards. You have to talk about a workstation because you're going to run a 7 billion parameter or maybe a distilled version, which is a 3.2 million parameter or billion parameter. And that also requires a workstation in real time sitting in the vehicle where everything is going to cost, not only the compute power, everything. And we have to now, the challenge is, when I'm talking of a generalized AI model or an LLM for autonomous vehicle, what is the kind of distillation I'll have to do? What is the number of billion parameter which is going to perform equivalent to the, large language model in real time itself is a big challenge or a research, I would say, that we'll have to actually look into. And the cost that we are going to pay in terms of compute, in terms of compute, in terms of power, etc., in order to accommodate this kind of LLMs or foundation model as autonomous vehicle itself is a big question mark. Are we able to afford that kind of thing for autonomous vehicle in Indian context? Is something we'll have to look into. That is one thing which I thought we should add, because the discussion is all on foundation models.
Yeah, absolutely, Professor. That's an excellent point in terms of the compute and the capability in that front as well, right? Yes, it's not just the sensors, but also the compute.
Yeah. And coming to the talent pool, so actually when it comes to the talent pool to handle generalized, I would say LLMs and other things, I think than AI engineer, we would like to see an, kind of an interdisciplinary engineer. He should be kind of a core engineer with AI as an adoption than, because it requires a lot of system level thinking as well. It's just not integrating the AI algorithm, making it run in the vehicle, but rather, how should the system be built to optimize, because we are talking of an end-to-end architecture, right? So do we have that kind of talent pool? It's very important that we should build from the scratch, because now the things are very specialized, but of course there are a number of workshops and other things, and even we are seeing a number of integrated, I would say, interdisciplinary programs also coming up. At least in all the IITs, we have most of the master's program and a number of centers for interdisciplinary programs where multiple departments come together to offer master's programs. I think these kind of translations in the academic program is really going to be the game changer to have, I would say, in-house or I would say a homegrown capacity building for this kind of next-gen technology requirement in the country.
Wonderful, wonderful. Yeah, I think this calls for collaboration as well.
Yes.
The thought that kind of came across this thing was, we have to learn and maybe even have cross-campus kind of programs that take people to actually where the work is being done, right?
Yes.
Right. Now on the other side, I'm just going to kind of go to the industry, kind of, as you are kind of working on some of these things, including for your defense project, or at media looking at what happens inside a warehouse. How are you looking at talent and how are you developing it? Or is it just available, or you have to spend a lot of time training engineers?
So I think we are trying to solve this problem. I think the closest analogy comes to mind is using a jigsaw. So you have the academia, you have the startups, you have the suppliers, you have the governmental setups. So trying to see where I think the solution can you bring some of these together, not all of them all the time, but I think trying to solve it that way. So we're working with startups, for example, in some of these areas, working with our supplier partners, because a lot of our supplier partners are supplying these sensor-based product systems. I think those are really, really important. And things come to mind as we are talking autonomous vehicles, but even the early stages of AEBS, automated emergency braking system, just think about it. More than, I think, 99.9% of the vehicles, let's say when it gets launched, are going to be non-AEBS, right? And you have one truck which is actually in AEBS compliant, so it will actually apply a brake, right? The rest our ecosystem is not. So how it actually operates in that ecosystem, and Europe has gone through this, and I think that's where I think we really need to look at each of these scenarios and see how our systems and solutions will work towards, I think, because you don't want situations on the road, right, in terms of, so I think that's where I think we have to really make sure that the standards and the overall ecosystem comes together towards solving these problems. That's where government will come in from a standard standpoint, startups and let's say suppliers will come in with their solutions, which will make sure that that scenario is taken care of, and OEMs making sure that again a very rigorous testing happens before it gets launched.
So talent has always been an interesting topic, but I think what we really need to build, and I think Professor Rajalakshmi said this very nicely, right? We need to build a strong systems engineering team, right? And that's all we really need, because there's enough depth, expertise in models, the math, what do we need to do? We have all of that that's extremely focused, but lacking the system level context, right? So we've been spending a lot of time purely looking for multidisciplinary engineers. It doesn't matter what their discipline on paper is, but if their intent is to be multidisciplinary, I think that's all we look for. And then everything else is, you know, something you can train. You can give them the opportunity and platform to learn and they take off, right? And that's literally how we've built Viria today to about 75 employees so far, right? Of which 30 plus is the engineering team. But the second part that we're doing, and I think this is something we're very passionate about, is we're engaging directly with academia across the country. We have multiple engagements already in Bangalore, and we're working closely with different colleges where we're helping with two things. One is wherever there's a need, help them set up the infra and the lab setup for them, for the students to get an early level understanding of what robotics mean, what physical systems mean, and then of course, as we talk about physical AI, what does that mean? But we're also partnering with them as much as possible, wherever possible, to apply for DST grants and promote the culture of research, right? Like something that the West has done really well is industry academia partnerships from the context of research and supporting research is something that's very established, right? But that's not necessarily the case in a lot of the academic institutions in India today. When you go to the level, sort of to the next year after the IITs and whatnot. So we're trying to build that culture because there's great talent. There are students that are very passionate that would love to do these things. And today the rate at which they pick up things and learn is insane, right? So we're definitely trying to create a platform where they can do that. And same thing where we're also investing time in training faculty to the level where faculty can do enough to get students inspired to get into this space. All we need is inspiration, systems level thinking, everything else can be figured out. So I don't think we have a talent shortage problem. We have a talent molding problem that we need to work on, but otherwise, I think it's going to be exciting.
Talent enablement, yes, absolutely. Wonderful. So I think we explored quite a few topics related to autonomy, whether it's standalone technologies or, you know, how do we create, you know, the foundational models to realize fully autonomous vehicles, you know, what these various dimensions are around that, right? So first, thank you. Thanks to the panelists. Now, I'm going to open it up for questions, all right? So first, let's start with online. Are there any questions on the online system? Yeah, there are. Okay, yeah, come on. Yeah, go ahead.
So there is one question from Pranav Jain. The question states the following. Tesla drives its own car and dumps it whenever the car comes in a charging zone connected to internet. What are the innovations regarding managing the huge data generated by connected vehicles, especially on transmission cost too? Is Edge AI playing a huge role already in India? That's the question. So I think there are two parts to the question. So whoever is comfortable with that.
Okay, I'll take a first pass at this because one, I mean, great point, right? In the early days when Tesla was trying to get a lot of data out, charging was actually the way where they would use a link in the charger to upload a lot of data. And this was at an era where the cost of data transmission, of course, was very high. So the shift is one, thankfully in India, in a comparable basis, the cost of data in India is definitely, you know, lower, right? And thanks to the government, thanks to maybe even how we look at things. But having said that, in the last, especially couple of years, if you look at the only way to scale is to not it's not about the volume of data anymore, it's about the quality of data, right? So Edge AI is going to be a key part in not just Edge AI, but even what we do on the edge is going to be a key part in interpreting and deciding what's relevant, what's really required, and then just make sure we get that to the cloud or wherever for us to then feed into the larger part of the data flywheel ecosystem, right? So there's definitely going to be a lot of reliance on what we do on the edge today to keep this cost low. And then the cost is not just about cost of the network, what we pay to the provider, right? It's actually the cost of what are we doing holding all this data, right? Unless we really have meaningful data, right? We talk about digital detox today, everyone's deleting photos on their phones after a point of time, right? We're just hoarding data for no reason. So it's important that we be more pragmatic about what we push in the first place.
So I guess what we do with the data essentially is we have an uptime solution center, and that actually monitors the health of our vehicles on the road on a real-time basis. We have, let's say every year we sell multiple lakhs of vehicles, 2.2 lakhs to be exact. Last year we sold a good proportion of them have telematic solution. So we actually will monitor their health and see whether I think there's some intervention required. So I think those elements is something that we look at from a data standpoint. I think those are the building blocks the way we see it. Over-the-air updates, I think those are normal. Before the vehicle comes into the service station, I think getting all that history, these are now par for the course now for us.
Sir, also I had a similar question to that. Sir, you had mentioned about the quantity of data that's generated every day, like 200 GB of data. My question is that what is the frequency of overwriting this data? Like if it's like an dashboard or something, we can continuously overwrite it. But like how do we manage this huge volume of data? And because we need historic data for predictions, right? So how do big companies handle this kind of
So you need a data strategy there. I think you would have heard terms like data lake, I think the cloud, right? So each of us operates in that infrastructure. So we have one of the cloud operators, I think manages our data, right? So there are decisions that you will do on the edge as well. So not everything goes to the cloud. There will be something on the edge as well that means on the devices itself. So all those are really strategic calls to be made. Just to give an example, we actually, our telematics itself will generate terabytes of data in a year. So I think the order of magnitude has changed quite a bit in terms of, and then the associated costs that come along with it. So you have to monetize it then, right? So you have to make sure that either you improve the uptime, so create that value for the customer, or monetize that data. And there are different ways to do it.
Are there any other questions online? One online. Okay, we'll come back to that online question. Any questions from the audience? Yes. Somebody please get a mic to that question.
Hi sir, am I audible? So since we were speaking on autonomous vehicles, I was just wondering, and we're speaking about future, shouldn't we be more focused on vehicle-to-vehicle communication and more autonomous, since we are more focused on individual autonomy? I mean, the future should be more of like all vehicles could communicate with each other, the traffic should be completely manageable. Isn't that supposed to be the great future we are looking for? Since digital twin is even such a thing, right? So that's what I was wondering. That should be also part of it.
That's a great question. Okay, it's not looking at autonomy just from the perspective of. That's a great question. Not only looking at autonomy from the perspective of an individual vehicle, but yesterday we had a talk where we talked about platooning and how autonomous vehicles kind of talk to each other. And so, who wants to take this on? I mean, Professor Rajlakshmi, are you doing any research in this? Yes, please.
Yeah, I think yes. I mean, it's no more of future research actually. Already DOT has sent a noting on what should be the technology that should be used for V2V or V2I, V2P kind of communication between vehicle and its surrounding. It can be another vehicle, it can be an infrastructure, it can be a pedestrian, it can be with the network as well, V2N, right? So the noting have come from DOT already, where we are going to adopt the CV2X technology. The frequency bands have been already, identified by DOT for this particular purpose. So once the noting has come, that means the products are going to be manufactured and getting integrated into the vehicles, right? So I would say it's not a future technology. Already we are going to have connected vehicle technology rolled out in practice very soon in the country.
No, thank you, Professor. I'm also going to ask Geeta to talk a little bit about MInT and its role in this kind of as these standards come into play.
Yeah, so we have Intelligent Transport Systems Committee within BIS, right? For which we are also a part of that. And within the committee, they've actually asked IIT Madras to take a leadership role in looking at standards for V2V as well as autonomous vehicles, right? So great question. You're at the right place. We'll work on these things together, right? Yeah. So maybe in the next month or two, we'll have focused meetings around this topic and how we want to take it forward, right? So that's something we will do. Yes.
So I was also wondering, like ma'am was saying on 160 scenarios required, the data is already generated. I mean, they are rare cases, so we can't get the actual data, and it's gonna be generated by a synthetic AI. So how far would it balance it? Wouldn't AI be so biased over it? Like there are rare cases like this. How will we manage it, ma'am? Since synthetic AI is becoming the boom in research, I want to know it. And how
So it's not just the synthetic data that is going to, we are not just going to generate the data synthetically and train the model. We have lakhs of already actually driven data set. Okay. Only thing, there are some, for example, of the 160 scenarios, there is something which we define. We again classify the scenarios into 3 classes. One we call it as a normal, the other one is called as a pre-crash, and the third data set or the scenario is a crash scenario, right? So not all the scenarios are already available, as I told before also, in the driving data that we have collected. Only in such kind of corner cases, we are going to have synthetic data generated. And we also ensure that class balance is there, and we ensure that synthetic data generated is, that's what I was talking about, the statistical models for generating synthetic data as per the requirement, whether it is pre-crash, crash, or normal scenario. That's again a good research area for this purpose.
Thank you, ma'am.
Thank you. One last question.
Yes, sir.
The online.
A question from Krishna BV. He has asked, will India be able to afford VLA workstation in autonomous vehicle for common people? Or maybe we have enough talent pool to design and export them from outside? So that's the question.
Wow, who wants to take this on?
What's the question? Will India be able to afford?
So,
Can they be designed here?
okay, I think maybe the question comes from what Professor Rajlakshmi was saying earlier about having a workstation, the cost of compute, then the cost of power and whatnot, right? So let's quickly, for a second, reflect on where we were 3 years ago, where we are today, right? And I think the answer pretty much lies there. As we work through this, as we build this, we are going to get efficient. The cost of compute is going to be more affordable, and more importantly, our models are just going to get better and better, right? So I really don't think this will be necessarily in the top 5 of the problems we're trying to solve, because we will continue across all of the streams to solve for it, right? So, and historically, we've always seen this happen with any technology, right? The affordability, sort of the rate at which that becomes more feasible is definitely down the line. So, but I'll also leave with 2 thoughts on the actual what elements cost compute, right? Of course, globally, we're dealing with a memory shortage problem. Everyone's aware, right? There's a big cost of memory challenge going on, which hopefully is a passing cloud and we'll get past it. But if you look at the chips themselves, and the more efficient we get at what we build and how we run it on a chip, naturally, right? And also as chips get thermally more efficient, naturally we're going to see a decrease in the other systems that are required to keep this alive, right? Your cost of power is going to come down to run this compute. You don't need external cooling now. You don't need, like if you look at a Waymo vehicle from 4 years ago, the separate coolant circuits to cool compute in the back, X, Y, Z things versus what it takes today is significantly changed. And the vehicle's probably 10x more capable and intelligent today. So with that trajectory in mind, I think we're okay. And I think Professor Geeta has something to add.
See, this cost question, common man question, right, usually comes from the old thought that everybody wants to buy a car, right? So it's not necessary that, somebody has to buy a car, put a GPU in that and, have it autonomously drive itself. You'll have fleets which will use this technology, right? The cost of an Uber ride will become 1/3 or 1/4 of what it is today. Then it becomes affordable for the common man to also take, a taxi, right? So we need to think about different business models. It's not about owning, it's not like putting a GPU into a Tata Nano, right? And everybody looking to own it. I don't think that's the model which will work here. Right? It's more for the fleets and how the costs go down there.
Wonderful. I think we've had a excellent discussion, which kind of talked about how we are going to collaborate. What are the things we need to think from an India context in terms of autonomous technologies and autonomous vehicles, sensors, compute. We've talked about lots of different things. I really want to thank the panelists for sharing their thoughts and ideas. Let us give a round of applause for our panelists, please. And I would also like to invite Professor Geeta so we can recognize our panelists. Professor Rajalakshmi, you're not here in person, but there's a small memento which we will make sure that it gets to you.
Thank you so much.
Thank you very much. Yeah, wonderful.
You can come this way.
Yeah. Wonderful. Yes. Thank you.
Thank you. It was a wonderful session again, panel 3. And Professor Rajalakshmi, I'd like to ask a couple more questions to you actually, but we're running out of time. I'll probably mail them to you. I know you talked about sensors versus end-to-end foundation models, and my question was actually on the safety aspect of it. I don't know if we have time for it or if we touched upon it or if I missed it. Did we talk about the safety aspect, like would you be able to say where it went wrong in a end-to-end foundation model versus?
I think we can definitely explore that. Professor Rajalakshmi, I'm sure, is going to collaborate with us. We are going to get her into campus here as we kick off the MInT project around autonomous vehicles.
Okay, but do you have a 30-second answer for it?
Yeah, so actually that is where, we were talking about that hybrid way, right? I mean, adapting the foundation model, but also integrating what we want into it. So that there is what I would say the safety, component is inbuilt in the foundation model itself, before you actually go for action creation, the safety. When I say about the safety, we'll be talking about the standard getting integrated, whether action, the trajectory that is being predicted, is it complying to the standard, is something which is going to be integrated as part of a foundation model architecture itself. That's one of the important components which we will bring in as the, novelty or a modified foundation model architecture, safety critical foundation model architecture for autonomous vehicles.
So if I dragged you out of the IIT Hyderabad campus and we went bangle shopping in Charminar,
yeah.
I'd like to see if we can experiment that with the model sometime.
Yes, it should work actually, because that's the expectation with this foundation model.
All right, thank you. And thank you again. We had a quick 30-second chat yesterday with Alok. Alok and I had a chat on how this panel would turn out. but I think it has exceeded expectations in terms of the quality of the discussions and how it was, challenging each other more over coffee. I'd like to encourage everybody to actually move into the exhibition hall where we have the Mintathon winning exhibits, demos, and the teams are very excited to discuss those with you. So let's meet over coffee at the exhibition hall. And we will regroup at 4 p.m. for panel 4. Thank you to the virtual participants. We'll meet again at 4 p.m. Thank you.
coffee break. The Q&A kind of spilled over from the previous session, so just a minute more. So can we highlight Satya sir and Mr. Danny there, make them co-hosts.
All right, I see Professor Ramki walking in, so we will start panel 4 now, the last panel discussion for the day. Welcoming you all to this very exciting topic, Sovereign Mobility DPI Architecture. We've got people virtually as well, and very invested people here in the hall. Who owns the digital roads of the future? Panel 4 introduces a massive concept, sovereign mobility DPI architecture. It's about building digital public infrastructure that keeps our data secure, independent, and locally governed. Mr. Satya Kumar from CRIS guides this critical policy discussion with experts from Genesis, Mohua, and Professor Kandaswamy Paramashivam, and IIT Kanpur. They're mapping out our national roadmap, government certifications, and how we adapt global tech paradigms while keeping our digital architecture strictly sovereign. Over to you, Mr. Satya Kumar. Yes, inviting
Good evening,
Mr.
everyone. I
Bhanu
hope I'm
Badoria and
audible.
Professor Kandaswamy Candy over to the stage, and Professor Ramki as well. Thank you.
Yeah, good evening to all the distinguished panelists. I hope I'm audible.
You are audible, sir. Could you just increase the volume a little bit? We'd like to hear you a little more clearly. Just 2 points more of volume will be great.
I think that should do. So welcome once again to all the distinguished panelists. Just to open the discussion, sovereign mobility DPI architecture. Where do we stand as far as India is concerned in terms of a nationally governed, open, interoperable digital architecture that enables safe, seamless, intelligent, and trusted movement of people and goods across rail, road, metro, air, port, logistics, while ensuring that India retains control over data, standards, certification, cybersecurity, and strategic decision making. This is a very important topic, and to set the ball rolling, I would request Professor Kandaswamy Paramashivam. You need to put it on. Yeah, just to reiterate, am I audible? I think we have already kickstarted the discussion
Satya,
with
you're audible. You're audible,
Professor
Satya.
Kandaswamy to be the first speaker in terms of setting the context in terms of what sovereign AI in India means from the mobility perspective. Okay, while the PPT is going on, I think I would like to turn to Mr. Sudhir Saxena from IIT Kanpur, if he's also on the panel, to make his opening remarks on the topic. Mr. Sudhir?
Yeah, can you hear us from the conference hall here?
Yeah, you're audible.
Wonderful, wonderful. So that problem has been solved. So I guess now we just have to share.
You all know that the AI runs on huge amount of data, and therefore it is the first part of the aspect of AI. Only then we will be in a position to be very sure that this particular data sovereignty is assured. You can say AI is fine. You all will think that this Puttaswamy judgment was the one that really set the tone. You all will think that there is already some kind of a law which will make the data very safe and secure. It can't be. Actually, it is the other way around. The first kind of policy decision was by the RBI. RBI said that all the customers' data should be resting only in the Indian continent. It can't go outside. So that was the first decision. And it was not for the vendors. It was to protect the customer's database. So obviously your MasterCard, Visa card, Apple Pay, everything, they all relocated to comply with the decision of the RBI. So that is the turning point. There was no loss asset making it mandatory that you should have it here. It's more for the customers. But the business houses fell in line. So that is the first way. Then you'll ask the question whether the social media data that's having huge amount of data of your personal thing, is it resting in the Indian country? No. We have some compliance guidelines, and still today, they are all outside. Other aspect is with regard to the so-called cloud services that they are providing. Whether those cloud services are available mandatorily here, they are not because of any statutory guideline. It is more because of your need for making the business work. So basically, the compliance to the RBI, compliance to various rules and regulation, made the business houses to ensure that there is data sovereignty. So this is the first aspect of data sovereignty. The beauty is this data sovereignty kind of promoted infrastructural sovereignty. We have the huge India database rail like UPI, Aadhaar, and your Ayushman Bharat, and your DigiLocker. We have the infrastructural sovereignty in terms of having it. So the first bucket, infrastructural sovereignty, is there. Second bucket is your data sovereignty is there. Model and your operational is what's happening today and tomorrow. And therefore, to really touch upon the sovereignty, we need to know whether there is a kind of fulfillment of all the four buckets, basically infrastructure sovereignty, your data sovereignty, model sovereignty, and that of the operation sovereignty. Thanks to the efforts
Great,
for the
Doctor.
government.
I think that was a wonderful exposition in terms of looking at from these four pillars of infrastructural sovereignty, data sovereignty, model and operational. While infrastructural and data you mentioned, we are more or less sovereign. You would require a lot more to go in terms of the model and the operational sovereignty before India can really call itself as a 100% sovereign mobility as far as DPI is concerned. With this, I would go to Professor Sudhir Saxena from IIT Kanpur to give his exposition as to what should be the roadmap for India going from taking off from, say, what Professor Kandaswamy has mentioned. Infrastructure and data sovereignty are almost given. So how do we fill up the other two buckets in terms of going to a more robust model and operational sovereignty, and perhaps even cyber standard sovereignty and industrial sovereignty? Mr. Sudhir Saxena? Mr. Sudhir, you're not audible. Are all others able to hear Mr. Sudhir?
Mr. Satya, there's a connectivity issue. Perhaps Professor Sudhir can speak over audio. Will that be okay?
Yeah, I think that should be fine. While he gets into audio, I think I'll just turn to Danny Savler from Emphasis to give his perspective on the issue. Mr. Danny?
Yeah, so Professor, can you hear me?
Yeah.
Am I audible?
Yeah, absolutely.
Yeah. So I think it was very well said, looking at the aspect, the four aspects that the professor called out, right? The infrastructure, the data, the model, and the operations. I think they're beautifully called out. And we are, as India, we are headed in that direction as well. I mean, we have caught up something called as the DPDP Act that has come in perspective, right? We also have gotten what we call it as what was released, which was the DGPIN, which was how you could secure the address in that space, right? Essentially, sovereignty is getting more and more critical given the geopolitical issues in that space, right? So the question that arises is who will own the data, who will own the intelligence, and that's where the AI models definitely play a very important role. And how are we gearing up to build our own models, build our own embeddings, build our own logics in that space. And finally, how can we take it forward in terms of the future aspects of mobility? Because I think the important aspect is the citizen data governance, which is also critically important in that space. As rightly said that, which was rightly put up when asked that is right to privacy a fundamental right of Indians. And I think I personally feel that as Indians, we give away that privacy for a feature or a product or a mobile application that comes in. So we have to also be very particular about the citizen data governance. That needs to be kept in mind while we speak of the operations and speak of the models that need to be built. So that's my view.
Oh, wonderful. I think you have actually logically extended what Professor Kandaswamy has mentioned. Now, I would like to just turn to Dr. Sudhir Saxena from IT, if he's ready now with his audio. Okay, I think he's having some issues with his audio. So I think we will go to Professor Ramakrishna Srinivas or Dr. Pratush from Sarvam, because you have been on the AI sovereignty, especially on the models. Can you throw some light as to where we stand in terms of this mobility, sovereign mobility in this particular pillar of operational and AI sovereignty?
Yeah, thank you, Satya. So I think Professor Kandaswamy's exposition in terms of how to look at sovereignty is a very useful framework, right? Now, when you think about mobility, we have vehicles that are designed outside the country. which we allow them to operate in the country. So we have to be very clear about what is made in India versus what is allowed in India. So sovereignty is when it does not infringe on the independence and the decision-making capability, right? So things that are allowed to operate have to be governed, right? So when a vehicle is imported or a component or something is brought into the country, we have to be very clear that we have a governance.
Professor, your audio is a bit on the low level.
Hello, is that better?
Yeah, now it's better, yeah.
Really sorry about that. Okay. No, I was just kind of commenting on the framework that was laid by Professor Kandaswamy. So I want to make the distinction that sovereignty is more defined by the governance of what is allowed to operate in the country rather than what is designed or created in the country. So in that sense, we have, for instance, vehicles that are actually imported into the country. We have a lot of different goods and services, and including when you look at our Microsoft 365 or our operating systems, from various software companies that are allowed to operate. Now, we have and we should have a very robust governance system around that. So when you think about mobility, right, we should be very clear on how we have our regulatory framework in terms of approving the use of these in our roads or on our tracks, okay, or how we use them to gather information and data. So we just had an earlier panel, and we can talk a little bit more about that later in today in this panel's discussion around sensing as well. At the root of creating data is a sensor that is gathering information. Now, the very fact is that sensor itself could be something that is actually made or designed or controlled from some outside the country. But then when it is deployed here, we need to have a framework on what is acceptable or not acceptable. If we do not put that in place, we cannot sit here and kind of complain about we don't have sovereignty. We need to put that in place, right? I think that's something that we should explore in this panel as well, in terms of how the governance systems around that work. That'll be my perspective in terms of enforcing sovereignty in the space of mobility.
Thank you, Professor. I think that was a logical extension of Dr. Kandaswamy's exposition of infrastructure and data sovereignty, not to lose track of the data acquisition systems as well as the model sovereignty, and also getting a regulation or standard certification process and robust governance systems into place. Then only I think we can really say that we are on a path for 100% mobility sovereignty as far as DPI architecture is concerned. Now we'd like to hear from Sri Banu Bhadoria from MOH in terms of what is the government's roadmap. I think you're at the center of it. I would think with all mobility, metro systems, everything coming up, National Common Mobility Card coming, DPI, DPDP Act, and trying to integrate both the freight and passenger mobility across multi-modes. We're all keen to hear from you as to what is the roadmap from India, for example, starting from the two buckets of infrastructure and data, where perhaps we have certain sovereignty here, but on the other parts, the model sovereignty, the operational, and of course on the standards and regulation. We are keen to hear from you now.
Thank you, sir. Thank you for having me. Am I audible? Am I audible, sir?
Your audio is not proper.
Thank you for having me. Am I audible, sir?
Yeah, you are.
Okay. So I would, because a lot of has been said by sir regarding sovereignty. So I would like to put it in another fashion, like we should think about bottom up. The problem is in this country, which is my personal opinion, we always think from customer facing side. Building blocks nobody thinks about, right? So as Professor Ramakrishnan has already told that, owning technology. So sovereignty flows from the building blocks. Like if we don't own the propulsion system technology, we don't own the product specification, how can we create a market for any product? Like I was lucky enough, because I've served in railways, I saw some of the better stories in railways, like every technology was fully indigenized within 3 to 4 years, right? From the Alco locomotives, then GM locomotives, and there was only mechanical TOT, no electrical or electronic control technology transfer. But there was a system in railways, they could make it happen, and we have a Vande Bharat now, which I can proudly say that it is completely owned in India. Be it vehicle control software, be it traction control software, everything. So when you own full stack, then only you can have data sovereignty. Data is only output. So my point is that this is the high time we should think of embedded softwares. We must own all the embedded softwares, be it point of sale machine. I could not find any product where the chip design is owned by Indian company. It is coming from China. Are we creating market for China? Be it e-buses. So this is a really wake-up call, and the technology is moving so fast, the government don't have the capacity to regulate, I'm telling you. So these are my personal opinion, which I could feel I am expressing in an academic forum, which I could not say openly anywhere else. Sir might agree. So this is the thing, like I could do this modeling, I could make a product just by having a MOOC course on AI in 2020, way back in 2019. But I tried to make a digital twin for traction motor. We had a lot of data for voltage, and since we were doing this monitoring of locomotive since I think 2011. So second thing is, everybody talks about data. There's a lot of talk about interchangeability of data. One institution is not sharing data with other institutions, but nobody thinks about the use case. What will you do with that data? First, we should have a repository of use cases. How we can make use of data. So first, we need to find out what are the use cases. So I have been thinking like this only in the last 3 years, because bus industry I was not. In the last 3 years, I could acquainted with all the bus technology, what is happening in this. The first thing is capability is missing at every level. Governance level, industry level, and supply chain level, right? So what we could do, we have success stories. Like in railways, we have success stories. We have other success stories as well, but we need to focus on this owning the intelligence by owning the product, be it IT, be it hardware. Propulsion technology is such an old technology, but we can't make it our own. So we need to think about first, we are talking about cyber physical system. We are mostly focusing on cyber system, but physical system is missing. So this is my only, because this is a place where young students are there are a lot of problem statements are there. Go visit and railways. We are not able to develop one bogie design, high-speed bogie design. We have many center of excellence in all the IITs. So what I feel, there has to be a better collaboration among academia, industry, as well as the user. So coming back to this DPI sovereignty, so I am also learning by doing. I have not done any research, but gradually I am learning what should happen, because there is a lot of data generated, but we are not able to make use of it. So like we have taken a decision, we are trying to come up with a national IoT platform for all the city buses. So when I was floating, when we were floating a tender of PME Bus Seva, one thing was in my mind, how there are different types of ITS hardware existing in the market and there's no single specification. How will I gather the data from all the platforms? So I just did crowdsourcing. So, and there was only one protocol. This Vahan was collecting three parameters only, and that was on HTTPS protocol. I could learn from, by having this discussion with we should move on to some other we should publish data on some other communication protocol. So simple, this thing now we have made a beginning, the tender is out. Hopefully we'll be having a national IoT portal within a month or two. Then we'll have a lot of data and lot of research. We have made at least 25 parameters which will be coming onto our platform. You can have vehicle health monitoring. So the point is that, but there again the sovereignty, because this entire hardware, the firmware and the software, I have no control. So I can only gather data. So we cannot talk about sovereignty at this stage. Unless until we have full stack, we cannot have sovereignty of data. These are my final words. Thank you.
Yeah, I think that was a good exposition of, instead of giving an answer and roadmap, we actually laid more questions than answers. And I would like now to turn to Mr. Sudhir Saxena to give a perspective from the academics. I mean, you heard Professor Kandaswamy lay out a structure for the entire discussion in terms of the 4 buckets, that infrastructural, sovereignty, data, model, and operational. Then Professor Ramakrishnan talking and emphasizing on the governance that are required. And now Mr. Banu talking about the end-to-end control of the system, the full stack control, rather than having individual controls of the different components. And of course, Mr. Danny also talking in terms of the citizen data governance framework that needs to be in place. I mean, we are keen to hear from you, Mr. Sudhir, in terms of the perspective you look at it as to how to get into, at least on a scale of 0 to 10, where are we in terms of the sovereign mobility, 0.5, 0.6, and how do we get to 0.9 to 1.0 on the scale? I think Mr. Sudhir is still offline, looks like. Yeah. So what we'll do is, while Mr. Sudhir gets online, I would request some of the audience who are there, if you want to ask any questions to the panelists, you're welcome.
Thank you all for explaining the issue of sovereignty. It's a very interesting discussion. The term data infrastructure was mentioned, and there is also infrastructure data, and they sound similar, but I'm not sure if they are the same. So I would like to, especially the first speaker, if you can explain what you had in mind and whether the issue of data about infrastructure, road inventory, for example, how does that fit into the picture in your opinion or in others' opinions? So the road inventory was mentioned earlier today in some sessions, and is that data also part of the picture somehow? Thank you.
Yeah, I think Professor Kandaswamy, would you like to take, or should I just start with my perspective?
You can start, Mr. Satya.
Yeah, I think as we heard, I think infrastructural sovereignty perhaps includes both physical and digital. And when I say physical, since we are talking about sovereign mobility, who controls the railways, roadways, ports, airports, the electric vehicle chargers, the hydrogen systems, and of course the digital systems in terms of the ticketing systems, the mobility, the fleet management, the digital twins, traffic management. I mean, all this of national mobility, I think that actually comes into the infrastructure part of the sovereignty, which perhaps is what was trying to be converted. Now coming to the data, the data as to who owns the data. Data is of, and then coming to the finer of who owns the models. The data in terms of the ownership of who owns the vehicle data, passenger data, the freight data, I mean, the location for the mobile vehicles, and of course, the data when it comes, the storage, who controls the storage, who shares it, and how is it accessible. I think there's a clear distinction between infrastructure in terms of both physical and digital infrastructure and the data. And of course, the other part of when you try to apply onto AI, who controls these models. With these thoughts, I would leave it to Professor Kandaswamy.
I think he has really started well. To explain in a different perspective, one is the data sovereignty with regard to the individual. There are a lot of data collected from me. It could be my certificate or my driving license. I go through a toll tax, my fast tag. These are the data that the government is supposed to collect from me for primarily for the use of me only, or for the primary use of the country good, not for any personal purposes. And it should be used only for this. They can't use this to check my credit history. They can't use this to check my medical history. That is the data the state should ensure that the sovereignty is maintained, the citizens' rights are maintained. The other aspect is the data that is collected, assuming that the state is using only for the purpose of the national good. If it's going to go to some other country for the purpose of training the supermodel, in that case is not right. For example, for another next 4 or 5 years, another country wants to kind of import some vehicle, they can't use the passenger data of India. That is not the way I'm talking about. The sovereign data of the Indian should reside only in India. Going back to what he said, certainly we will not be in a position to reinvent wheel. We will have the operating system of Microsoft, whatever it may be. That is not a problem. The problem is such of those information that pertains to one particular individual where quote unquote privacy is involved. Whereas the available algorithm, for example, the model which is going to be obtained from say XYZ resources, that could perhaps be a little bit of diluted standard that we can perhaps import and train the model to our advantage. But the core, namely the infrastructure and the data sovereignty, is much more important than the other two sovereignty. I'm not saying other two are not important. They're important. When you compare this and that, that is more important. Have I answered to your satisfaction? No.
Yeah. We can take the next question. Oh, you want to have a follow-up?
There is a follow-up. There's a follow-up. Yeah. Go ahead, Hillel.
I'm asking not about people, but about roads, intersections, signs, physical infrastructure. There is a lot of infrastructure, physical infrastructure for roads, for railways, for other modes, and the data about it is missing. The only owners today of this data are big companies. Google Maps was mentioned earlier today. Most governments do not have very little information that they own about the infrastructures that they build. That's my question. How does that fit into the picture that you described, which was focused on personal data, on activity, on where I drive, where did I go? So that's you were talking about people, and I'm talking about physical infrastructure. Is it now clear?
It's very clear to you, clear to me now. Here, even within the government, for example, one particular data is relating to Vahan, another is Sarathi, another with regard to some other NI, this night. So they don't easily kind of part the data, okay? Unless there's a government kind of intervention, only then they part of the data for interoperable purposes for the national good. Similarly, government, if they come with some project, if at all they want, certainly government can force the private entities to share with the data, and they cannot say no. They're not asking the data of particular person. They're asking the macro data, which I'm sure they'll be in a position to share if government insists. And this happened with us in the law enforcement when we wanted the dump data with regard to telecommunications. We were provided with that, okay. So there again is the role of the government in having certain policy in place or rules in place, where for the national good, for the AI mission, they'll be certainly making it available. And in case they're not able to comply with the directions of the government, I'm sure there'll be some coercive action taken.
Can I just add a quick point?
Once again, he's adding.
As far as I understood, you're talking about the the infrastructure data available with the government. So there's a Gati Shakti portal. So government has started building layer into it. There are many layers right up to the accessibility locations. So this is a work in progress, and like if you talk about metro, a complete alignment is with the Gati Shakti platform. Then you have all the stations. So this is happening. So government has started gathering this static database, and it has become quite richer over even all the municipality related data. So it is there on the Gati Shakti platform.
Yeah, exactly. I mean, it's good that you brought up Gati Shakti. I was going to talk about one of the first things that we did with MInT was to think about, oh, we have Gati Shakti. Okay, that is Gati Shakti 1.0. I think Professor Geeta will remember we wanted to propose Gati Shakti 2.0. How information is kind of gathered with a focus on, these types of problems, right? And also make it more active, not essentially static, right? So the data is actually something that can be used. But I think there's one other element that Hillel was kind of referring to. If we don't have a full understanding of the mobility infrastructure in the country, then you will not be able to reach good decisions or good understanding of the mobility using artificial intelligence or anything that requires the data to be processed. So one of the questions that we have to collectively answer is, how do we get sovereignty about what is being built? And how do we standardize that information creation and the upkeep of that information? Gati Shakti definitely is going to help, but I think there is also a question around the standards and what is required when an infrastructure project is initiated. What is the outcome? What is the quality of event when it is finished?
Yeah, I think we'll continue to poll him for the next 2 minutes till we can take another question from the audience.
Sorry, very interesting topic. I'm just going to put forward a question that may not be directly tied to sovereignty in the context of what you're speaking, but just reflecting on a trend that we've been seeing in the last 3-4 months a lot more publicly, right? There's a lot of data that everyone outside of India is looking at India to be the source for today. And there are both regulated and unregulated mechanisms of data collection that we are hearing about. Every other news article is about people wearing these, cameras, and there's a lot of motion capture that's happening. There's a lot of data capture that's happening this way. That's literally being farmed out of the country. This goes back to your point on until we own the thing end to end, how do we do things? This is one part. There's also a lot of, in the mobility space too, data that in an unregulated manner people are capturing that's being sent out right out of India, stored in databases, right? I mean, not in India, but elsewhere, and being used to train models. And of course, this is making models better and whatnot globally, but it's also in some ways lost opportunity for India, right? How do you look at that? What do we do? Maybe there's no single straightforward answer to this, but it's closely tied to the sovereignty we are seeking, right? So just wanted to put that out in the context of what we're talking today. What are your thoughts on that? So it's a fairly open question, but it's relevant because I'll just leave with one other piece, which is in the LLM space, it's pretty clear. Everyone today talks about LLMs, everyone talks about ChatGPT because sure, these companies made it very accessible in India for a very selfish reason, right? End of the day, because 90% of your users do not know that they have to go turn off certain settings. Otherwise, the data is still, of course, going to be used for all training, right? And there are all these ways where people and organizations will find ways to take data in an unregulated manner. So how are we looking at that as we move forward?
Yeah. Professor Kandaswamy, would you like to take that, being from the police service?
What you say is very true. As of today, except for those data relates to financial transaction, nothing can go out. But as you rightly said, humongous amount of data in the social media is all taken elsewhere. It's not all part of India, it's all going elsewhere, okay? And you rightly said, many people very smartly obtain the data, either legal or extra legal, a gray area, they exploit and do it, okay? As of now, we don't have, the DPD Act does not explicitly say you cannot do it. In fact, on the other hand, DPD Act says that there can be cross-border transfer of data as long as they're not a blacklisted country, okay? So therefore, as of now, taking the data from India is not a legally an offense, as of now, okay? And probably as things go, like how the Trump administration became very strict about their own development in terms of technology and data, perhaps probably in the days to come, we may be forced to think like that because, as you rightly said, most of the players outside are watching India primarily to train the models or use, like how the medical people using India as a guinea pig for the new drug. Something like that in the AI space also could be possible. So, but as of now, to my best of knowledge, it's not there. I think I'll ask my other colleague to add in case I'm missing out on anything else.
Just add to your point, sir. Actually, way forward, there are two things. We don't have to wait about the sovereignty is, of course, a question. But there are a lot of challenges which we can solve. There was a debate going on day before yesterday regarding how to bring down the logistic cost. So to bring down the logistic cost, we need to interact all the transport sectors like shipping, aviation, railways. So the way forward, as you told, we need to have an institutional mechanism for data. Data cannot be handled by one institution. So it requires, like now we have a security thread already in terms of legislation, we have DPDP Act, right? Sir has already spoken about a lot about legislative matters. But what is missing? The synergy. And there is huge data is being generated which can be used for bringing down the logistic cost and enhancing the operational efficiency at the system level, right? So in terms of capability, railway is quite a capable organization, but if I talk about the bus ecosystem, it's entirely missing. So then it is not that one institution can do everything. So I was discussing with Professor Geeta how we can develop come up with the good standards. So BIS has not got that capacity. So we need to have, like, distribute this strategy of standardization, like every ministry come up with their own standard. Let us build it bottoms up. So, like there is a need of national transport exchange. We have a mobility exchange where we can share data. Then we can make many applications. We can find many use cases where we can bring down the cost of transportation as well as planning the transport, new transport. Right now, as sir is told, we are totally relying on the static data. As there is a network planning group, whenever there is any railway line is there, any shipping line is there, so they do. But we have to build a service layer over it. That sir is talking about 2.0. So that service layer is a cross-cutting, right? There are a lot of dynamic data coming up. We can schedule many things. So for that to happen, we have to have center of excellence on all the ministries, let them come up with their own standards. We can integrate all standards upward, and we can have a mobility exchange. And then we need to have a national data management authority. So it's a huge task. We need to institutionalize it, and then we can make use of it. We can take care of security as well. We can take care of operational efficiency. We can bring down the logistic costs. So that should be the way forward in my view.
Yeah, on this topic, Mr. Danny, you would like to add something?
Yes, I would definitely like to add. Am I audible? Yeah. So I think to the question asked that data can go out of India. Well, there are many ways that can happen. However, the Indian geopolicy had been revised that any sub-meter data, it cannot be collected by any foreign entity. Not only could it be collected, but it could also not be saved, served, or processed from any foreign cloud environment or any foreign servers. So that was put in perspective. Taking another example is when we collect, LiDAR data from aircrafts or from drones, for the matter of fact. Of course, aircrafts need permission, but even drones, there is the DGCA licensing that comes in place. Your drones will not be active in the areas where it cannot operate. So yes. Do we have adequate policies? Sorry, I have a echo of myself.
One more thing.
Can
I'd
you hear
like
me?
to bring to the notice of the moderator that Mr. Prasudhi is online. You want to ask his opinion before I get reaction?
Yeah, sure. I think we'll just take Mr. Danny. You can finish your point, and then we'll go to
Yeah.
Dr. Sudhir.
So where I was coming in is that the geopolicy of India has started putting the curves in place where sub-meter data cannot go out of India, right? Of course, at above meter level, the data is already available in public. There are satellites roaming around collecting data anyways. So that's the space that even satellites do not collect sub-centimeter data. They are now directly under the Bunidi systems. So all data that you want has been directed towards Bunidi. So geopolicy is coming in place, and I think we should see more details coming in there.
Yeah, thank you, Mr. Danny. I think with this we'll go to Professor Sunil from IIT Kanpur. Professor Sudhir, you are ready?
Speak louder, please.
Am I audible now? Hello?
Yeah. We can hear you. We can hear you. Louder, please.
Okay, am I audible?
Just check 1, 2, 3, please.
Check 1, 2, 3.
Yeah, good. Please
Yeah.
go ahead.
It's audible.
What I'll do is I'll try and be brief because much has been already spoken. May I remind the audience of the Niara Energy episode in July 2005. Now, why I'm mentioning that is that that was an Indian company working within Indian law, but was subjected to what Microsoft did, and it was blanked out of the licensing. Now, as simple as Microsoft cloud-based word processing and office automation system was disabled and the company suffered losses. Now, that's an interesting episode. But I don't want to repeat what others have already mentioned. Yes, there is a supreme requirement of technology stack being digitalized. Yes, there is a requirement of hosting most of the data and cloud infrastructure and AI infrastructure in India. But let's zoom out a bit and go towards future, because our northern neighbor has already graduated in that. And that is the post-quantum world. Now, why we are mentioning this is because coming from the security background, and as my fellow colleague with IPS background will agree, that many of the threats that we are looking at today within our perspective have already happened. These technologies are already materialized across the borders. And I'm not even talking about US of A. We are talking about China, and they have the capability to access data which is in current stack. So let's talk about some digital sovereignty in the post-quantum world, and let's make our life even more miserable. Quantum AI world. These are not exotic, these things are happening. So I would like to highlight that today the digital sovereignty, and where I find mobility sovereignty is a subset of it, would need to address these futuristic architectures today. These are the frameworks which you need to address. One more thing, while we are talking about all these current and near future technologies, as somebody mentioned in the past, there is a supreme requirement of addressing the standards and certification aspect also. And last but not the least, all these are great thoughts. We can do a lot of indigenization. We have AI mission, we have quantum mission, we have semiconductor mission. But as I was listening to the conversation during the last session, the human resources ultimately will be the crutch. Are we ready with that? We in academia and the government, we need to address this problem as a national crisis issue. All this stuff, we are having great academics, we are having great academics and experts online, but our own indigenous human resource, is it there in sufficient quality and quantum to address these requirements in the future? And I'm not even going into the details of smaller, technology stacks and all that stuff. That HR is finally going to be the bottleneck. I'll end my case right.
Over to Satya.
So, thank you, Professor. I think that is an excellent roundup for the panel discussion what we had. I think that was a missing piece in the 4 pillars of infrastructural sovereignty, data sovereignty model, and then coming into the operational sovereignty, getting in picture the cyber sovereignty, especially in the post-quantum world. And you couldn't have been more articulate in terms of saying that the human resource, in terms of getting these gaps filled, would be perhaps the biggest challenge and needs to be addressed through suitable policies. I think, thank you all. Thanks the entire panel for taking your time out and giving your valuable insights on this topic. And I'm sure the country will be better off through certain insights which have come from here. And I'm sure IIT Chennai will take this discussion forward in the months and years to come, and will finally, on a scale of 0 to 1, we will perhaps reach to the level where we want very soon. Thank you very much.
Yeah, that's fine.
Thank you.
Yeah. Ramki, just wanted to make. Yeah, I think most of the points were made, but I just wanted to share one specific case, which I think is very useful for us. So when the Aadhaar thing was happening, UADI had to procure these iris scanners, right? And the iris scanners used to be several $1,000s, and was mostly dominated by Western, of course, agencies was happening. So while the procurement went through, one of the things UADI did was they put out the technical specifications of that, right? Very nicely and neutral manner, in a vendor neutral manner, saying here is a technical specification. As long as you guys can comply to this, you can use it for all the scanning work that happens across the stuff. And I think that model needs to be studied very deeply in terms of many of the procurement that the government does. Rather than trying to do procurement, if they put out open specifications, right, then what has happened over the period of time, just to let you know what has happened in the next few decades, the innovation that happened within the Indian ecosystem, right, the price of that has basically crashed. The market competition stepped in. It takes 5-10 years for that to happen. But the government needs to put out those specifications and hold those specifications, version 1, version 2. They need to hold those specifications rather than doing these gem procurements, which are I'm not going to get into that. So I think putting those out, allowing market to compete, unless we do that, then there is a way. So that's the whole procurement model, whether you're procuring a wheel of a railways or whether you're doing procurement of sensors. Instead of trying to procure from a specific vendor, need to put out a specification and let market compete. Then you have a chance of market coping up. There's a spec, they know there is a huge market because government needs to procure it. And that is the way markets work, right? If the government is getting into procurement themselves directly, so unless government changes its procurement models, it exists. The ways exist to develop technology, allow private sectors, and also to understand sovereignty in when you're looking at LLMs, etc. This doesn't come from public agencies owning LLM models in the US. It comes from private agencies owning attracting talent, building capacity, investing in academia, and making it happen. So I think some of this we need to think very deeply about in terms of if we talk about sovereignty in a very sense and then point to the government saying you need to make it happen. And like Bhanuji was saying, the capacity doesn't exist. So to where we are pointing to build the sovereignty, that capacity has to exist in the markets, but you need to allow markets to play out. So I think we need to think through how we procure, how we create those environments, and we need to be a little patient in terms of how then the talent will come, then the startups can innovate, right? Today they are struggling to compete with large players in the standard procurement approaches that the government chases. So unless until government, what is required? Government needs to change their procurement models. They need to work with academic institutions who can help them put out these specifications. While the academia here can't build those, technologies, they can guaranteed put out those, help you put out those technical specifications. That I'm absolutely sure of. That capacity exists, right? And then allow market to compete. In the first few procurements, you may still have to procure with the Western vendors. But see what happens in the third one. See what happens in the fourth one. And you will start seeing how this market changes.
I can't agree with you more on that. Really very good. I can give a small comparison analogy, something like your open source, okay? Open source resources, okay? That's something available and anybody can do it. Something like that you're kind of advocating for the Indian vendors, Indian talent.
Yeah, specs, just the specs.
Yeah, yeah, I understand.
More on this. You have spoken my words actually. So I'm completely echoing your thought only. See, it is not that capability exists in India. A lot of capacity exists, but we are not seeing it. See, there's a lot of cross-fertilization happens when you move from one institution to another. So I am bringing all the experience, all the learning from railways to bus ecosystem. So it was to my surprise when I joined MOA, there was one UBS 2 specification. It was basically developed way back in 2011 or I guess, I don't know. So it was a great effort at that time. I also keep telling everyone, you have to differentiate between standards and specification. These two are entirely different things. The standard is a broad one, it's a framework, right? The specification is for a product. This bottle, many type of bottle can be made with one standard, but this bottle have to have one specification. So this bottle has different specification, this bottle has different, but both can be governed through one standard. So this is the effort, and I could share this thing, very innovative model, aggregation model, which has happened in procurement of buses. There is only one bus specification for all the 117 cities in India, right? It has done a great good because the supply chain has been standardized. Your cost is coming up because ultimately it will go to the component manufacturer. They have the visibility that all the buses will be having same type of wheel or same type of chassis. So there is very much required from the efficiency aspect and also from the visibility aspect. So specification is must, then only you can come up with a product and you can develop a product market.
Yes, and only thing I'll add is, you don't need to specify the entire bottle. All you need to specify is the cap and how the cap fits on the bottle. Then somebody else can innovate the cap and somebody else can innovate the bottle. And I think that allows competition to happen. Otherwise, if you over-specify, I think the problem also happens in many cases is over-specification. You come up with these 500,000 pages of specifications, and I think what we should specify, we should be very clear about. So the whole issue of minimum principle, how do we hold the minimum principle of specification rather than doing infinite specification where then the politics of specification starts?
But I guess this over-specification doesn't exist in India. People are not able to make framework specification. I'm telling you, I will tell you my story. In 2019, so when I joined RDSO, there was one project on elephant going on with the Bharati School of Electronics, IIT Delhi. So the problem state was quite crystallized that time. So it was they were doing, but since then COVID happened, but it could not materialize. So when I joined there, the first question came to my mind. I was working on a fog vision system with Tata and Bell. So we collected a lot of data on the fog, and nobody was trying to, basically, people were telling that we are not able to capture the fog because kab fog aayega, kab nahi aayega. So we could collect the data on fog, and we could find out this LWR will not work in the fog because the intended headway we will not be getting. We will be getting hardly 100 meters. So we could generate a 1 month report, and based on the data, this technology is not going to work on the fog. Then we realized that there is another problem statement, production of wild elephant. There is a train-elephant collision. There is quite a problem. So the first challenge in public procurement, you have to specify then also you have to evaluate. So these were the challenges, and that time I interacted with ISC, IITs. Sir, what kind of headway we can get through AI, autonomous headway? So I'm frankly telling you, with my hunch, I went with I could muster the courage that this product should not fail because fog vision system has failed. So at least some bare minimum product should come up. So based on my reverse calculation, I could find out at least we should have 500 meter headway. So with that, we went ahead, And luckily, we were fortunate that we could develop a system. So you are very true that framework, any new technology, any new specification, any frontier technology, we should not over specify. We should give a framework specification and give designer a freedom to develop. Thank you.
This is a great set of discussions on the product and capabilities. I think one other aspect which we haven't quite talked about today with regards to mobility and sovereignty from a perspective of decision making. So we explored, we started the day today at the MInT Summit on looking at digital twins. What it is it's about how we collect data and how we create the models and process the models with the ultimate goal of actually making decisions. The real question that becomes in all of this is, okay, what does sovereignty mean in the context of the decision making? Who's making the decision and who's controlling the models that inform to make the decision? So I think one of the questions that we have to kind of set up and answer is, what does sovereignty mean in terms of running a transport corporation? Or how we actually look at, for instance, I'm very sure in the railways, when you look at the entire network's digital twin, okay, is that sovereign or is it controlled or is it something that can be manipulated or can be modified by external intervention? What are the security elements that are built in, right? Where you might build it with some foreign source, that may be true, or but how is it controlled and how was the decisions being made based on that? So I think we need to think about that aspect as well.
With that, we can round up the panel discussion. I think we started with 4 pillars from physical, digital, data, operational. Now we extended to cyber, standards, industrial, now decision-making, sovereignty. I think this panel has had enough, and I'm sure the audience had loved the talk, and maybe some other time more pillars to be added, and surely we'll go up the scale from up to 1 at some point. Thank you very much.
Thank you.
Okay, thank you, everybody. Thank you, Mr. Satya, for moderating this remote. We had a couple of glitches, but at the end, we have some fabulous takeaways. And what will stay with me is also what Mr. Manish said, that we decide the cap and the bottle that it fits and we don't over-specify. And also some practical insights from Mohua and your previous experience on why we under-specify and we're not in the problem of over-specification in India. So fabulous there, and the different buckets starting with 4 going over to 6. Thank you. I would request Professor Geeta Krishnan to wrap up the whole day and share insights. Feel free to stay over, Mr. Satya, and you get a full bird's eye view of what we discussed through the whole day. Thank you.
Do you have something? I think I'm still processing. It's been a day packed with insights. We've actually, from the first Mobility Summit, I think every year the size and the number of panelists, everything has been growing, as well as the work that we have to do, right? That's also been increasing. So my team has put together some, points here. Oh, it's showing up there, or? Yes, I think thank you to the panelists. You can maybe take your seat in the audience so that it's easier. Yes. Only thing is, even I cannot see it yet. Yeah. I think in the meanwhile, maybe I'll request Professor Ramki to hand over goodies to our panelists. Yeah, if you could come up front. Wadhwani, sorry, if you can also come up front. Yeah.
என்னப்பா Okay. Yeah. So I think, thank you, sir. Thank you. Yeah, the day started with, presentations on different digital twins. So, in fact, Professor Ramki was saying, you've, scheduled it for 60 minutes and you have 6 digital twins to demo. This is not going to work out, right? So a couple of them couldn't show, but even with the 4, we needed 90 minutes and that was not sufficient, right? So we got to see how different organizations are working on this. One of the takeaways that I had from that particular first session was something Manish and I were talking about. There is a lot of work happening. We need to all get together, discuss so that we're not reinventing the wheel over and over again, right? So if there is already work that's been done, standardizations that have been done by one organization, we need to see how we can take that, build further. But there is already an excellent set of work in terms of digital twins applied to different domains. So let's work on that, build on that. So that was from the first session. The second session that I chaired, I think, there was quite a bit of berating, some industries, right? We're over dependent on them, how they are taking away data, without naming them. They got all the data from people, right? So it was not like that company actually deployed employees to go and collect data everywhere, right? All they did was, they created an app and then they said, all of you use it, and we started using, they got all the data, right? So the data collector was actually the crowd. Basically, they crowdsourced all the data. And if there is a strength as a country we have, it's our crowd, right? If we can come up with an app that can be used for data collection. So we were hearing from a few people, like I think Kumta and others, there is no data on the footpath, width of the footpath in different places in the country, right? And all we have to do is, create an app. There's no footpath. Yeah, there are places that way too, right? Create an app and then make it a school project. I'm sure my 8th grade son will be very excited if I tell him, here is the phone, you walk these 4 roads in the city, take pictures, upload here, you'll be recognized for your work, right? He'll be super thrilled with something like that. So I think we need to have innovative ways in which we start collecting this data. So that was something that I thought came out of the second panel that we had, right? And of course, the third panel was on foundation models, right? So I was perhaps expecting maybe people questioning, do we need foundation models? But that did not arise at all, right? There was unanimity in saying foundation models is a must, right? That's the way forward. So, and having sorted that out, now we need to figure out what is next. And it came out rather beautifully from the sensor stack to the model training to the talent to do this, right? And also to some extent the economics of it, the cost part of it. I think a lot was covered there, right? I already see this white paper that's going to come out of this is going to be so rich, right? I think everybody would want to have their hands on that, right? So that was great. And finally, the fourth panel for today was on sovereign AI. I think started out with Professor Candy actually talking about the 4 pillars, and then more started getting added, right, to that, and it has left us with a lot more questions, right? So I think excellent thoughts in terms of maybe don't over specify, maybe don't over expect sovereignty as well. Think about it strategically, right? Maybe taking a leaf out of what Manish was saying. Maybe think about a sovereignty in terms of standards and specifications, and then allow the ecosystem, again, in some way, let the crowd jump in and help create some of these technologies, right? And maybe in a decade's time, I think that was one of the questions from the online participants. In a decade, we would have most of these puzzles, part of the puzzles, right, in place. So, excellent day, I would say, right? I should also mention Professor Bhargava's presentation, the technical talk on modeling
Indian traffic, right? So there is a lot of talent here. There is a lot of capability here, right? As was suggested. I think it's all about harnessing these and, you know, bringing everybody together, co-create, right? This digital twin for mobility, make it sovereign, right? Build foundation models and make it multimodal. I think all of these parts of the puzzle will fit in. This is just the day 2. We have one more day, right, left. And tomorrow we're going to have another blockbuster panel, right? Manish will be, of course, chairing the panel. And, you know, please be here on time. We'll also have a couple of talks, you know, planned for tomorrow. And in the second half tomorrow, we're going to have the startup teams, MINT-a-thon teams. They will present what they have developed, right? So there is a lot of excellent work that the team has done in the last 4-5 months, mentored by, you know, several of our students as well as faculty, as well as our core group members. So I think please come back tomorrow at 9:30. It's going to be another full day of events, and we'll of course cap it off with dinner as well. So please do stay the entire day tomorrow. Those who are online, please do join us online. If you are in Chennai, I encourage you to come in person. The experience in person is very different from being online. The energy here is definitely very different. So invite you all back for tomorrow's session. Thank you so much. Thank you so much for a fantastic day. Thanks.